we are so back. I just looked at my Apple Watch and it's charged. Oh, you didn't get me any cafe ready?
That's not. Oh, tweaking. What the fuck? What the fuck? Was that why? Yeah. Okay, I guess it can be connected to that. I can't do AirPods and at the same time. My calculator dies in my exam, I'll fail. Okay. Let me lock in. Okay. Thank you, bro. I'm glad to see all the information about me is readily available on the internet. That's my goal. Thank you, bro. Okay. So I think I can just do like I use I have an iPad Pro, not the newest one, but like one model back. I don't think it really matters though, as long as you have an iPad Pro, any model is fine. And I use Freeform in Notability. Freeform is like the Apple note-taking app that comes with your iPad, and then Notability is a free proprietary app that you can download on the App Store. Okay, the answer is incorrect. Okay, what's the problem? Wait, I don't understand this. Oh, no, I do. Oh, the weight of the bench. Okay, wait, I'm trying to find the weight of the bench, not the lever. I don't really think there is an ideal roadmap, right? But the roadmap that I'm taking that's ideal for my situation is school. So I'm just going through the university system, and then I'm gonna hope to get into research after I graduate. I'm pursuing my master's and my PhD. My PhD is gonna be in machine learning. But right now, what I do to learn is just like learn the math behind it, right? Because it's like machine learning is a bunch of math, linear algebra, vector calculus, statistics and probability. Just learn all the math, and then you'll be able to understand, I guess, like the entirety of neural networks and whatever. But I would say start with the math, because that's the most important. If you don't learn the math, then you're just going to be confused. It's just going to be a black box. Like, you're going to understand how to like implement machine learning models and how to make them better and stuff, but you won't understand how they work. So it's literally a black box. Like, you're just coding and you have no idea what's going on behind the computer, which kind of sucks, because then you can't really do like special optimizations that are necessary for like high level machine learning research. So I would recommend learning the math first, and then going into it. Okay, this is my axis of rotation. So wait, okay. What's this force? Okay. Yes, I need to find this angle here. I mean, it looks like it's gonna be 20 as well. Oh look, you know what we can do? Wait, how can we do this? Well, this is gonna be 20 up here. We know that. Yeah, I don't know. Like, I'm trying to find this force here. I think this would be N sine theta, sine phi. And then that's going to oppose that's going to be equal to mg. Do we think, I think it's 20. No. Yeah, I don't know. What? MG has a sine theta on it? Oh no. I'm an idiot. So I'm correct. Look. My axis of rotation is here. This distance is W over 2. Oh, I guess I can leave that. Wait, but wouldn't those just cancel out? No, this would be W. How'd they find that angle? 90 minus theta. Wait, why? Bro, like, how do they know that? Okay, whatever. Wait, okay, well, let me do this. Okay, so we get 2n sine 70. Right. Yeah. 2n sine 70 over g. Wait, but I get 7.66, not 7.56. This force F here? Is that what they're talking about? Yeah. So if we have the rotational axis here, our net torque is going to equal 0, right? We have, what's the distance? 2/5 L. Do we not know what L is? Okay, I guess we don't need to know what L is for some reason. Okay. So our torques are going to be here. We have the upwards torque Um, Wait, phi. You see where phi is, bro? I don't think the angle's in the correct place. No, it is. Oh, because n is already perpendicular. Okay. So, we have n 2/5 L equals L. Yeah. Okay, so we can solve this. We get. Wait, what are we solving for? F. So we'll just pull the 2/5 out front. Bro, what am I doing? NL over sine. Okay, I guess we didn't need to know L. 2/5 times 40 over sine 20. You did it correct, right? Yeah, it's correct. Yeah, but this again, I don't get. I have 46.7. Why are my numbers off? Whatever. Okay. Oh, okay. Wait, before? Before or after the collision? Oh, I guess it would be the same because it's elastic. So V1 I'm a James scholar and I do research, so I have like some research scholarships, but I'm gonna start applying. I'm applying to more because I would like free tuition. I think it's attainable, honestly. I just need to maintain a high GPA, but I want free tuition, and my tuition is not free right now. It's very, very expensive, so I'm trying to get more scholarships. And I'm an out-of-state student. Tuition's so terrible. It's like, it's roughly $60,000 a year for 2 semesters. Well, actually, It's not really true. Like, the base is like 50 something thousand for Granger. It's like, I saw when I was like making my decision, the tuition is like $30,000 for out-of-state students, but Granger costs $20,000 extra. So like if you're not in Granger, you can have like $30,000 out-of-state tuition, but I have $50,000. It's kind of stupid, and it's really, really expensive. Okay, I mean, there's on the equation sheet. Where is it? Okay. About like 100% of students got this right. Oh, I got it wrong. About 193% of students did get it right. Okay. Oh. 0.318. That's funny. I don't know, remember how to do this, but it's like of which cart? Cart 1. So it's like 1.2. The velocity of the center of mass is positive. So you'd add it times -1. And then you add 1.2. No, I don't remember how to do this. Of course, college is always worth pursuing. Usually people, well, it depends. It depends on your situation, right? But people will tell you college is stupid or college is a scam or idiots, right? I'm not going to say college is like the end-all be-all, but college is a fantastic tool that you can use, and it's a great place to learn. And like, learning is really how you become successful. It's just like how much knowledge you're able to attain and apply to your life. But and college is a great place to learn and I guess network if that's what you're interested in. But yeah, it's not the end all be all, right? But it's a great opportunity if you have the money and you have the time. I genuinely think you should pursue college, everyone. You just learn so much. I mean, it makes sense though. 90% of millionaires have a college degree, right? Yeah, it's if you go to billionaires, if it's a little bit less percentage, but I don't know. I mean, everyone should strive to be a billionaire, but those are kind of different. They're outliers. If you look at the percentage of millionaires and people who make over $100,000 a year, it's nearly 90% of them have college degrees. So if you can see that it's simple statistics, look, it's like direct correlation between college and increased success. It's not going to make you successful. Going to college does not make you successful. You still have to be hardworking and intelligent, but going to college can help you a lot. a lot. And you can see that by the statistics. You don't need to go to like the best university in the country. You don't need to spend $80,000 a year on tuition. Those are things that you don't need to do, but I think everyone should go to college. It also depends on your opportunities. If you can't go to a good college, there's no point to go to a bad college, right? A bad college is... I wouldn't necessarily want to go to a bad college either. So it's very dependent on your situation, but I think overall, everyone benefits from going to college. Well, actually, that's not even true. Not everyone, but most people benefit. And society benefits because we gain another intelligent person, which is, of course, what we need. But I'm also biased because I'm currently in college, so. Okay, I really forgot how to do this. Yo, you wanna hop on Discord? What? Where are you? What? Where's your computer? You packed up already? What? What do you mean took? Like they took it home for you. Yeah. Nigga used to have my cousin from jail came to my room and took my PC. Yo. Okay, well, look at this question. Look. You remember velocity of center of mass and shit? Yo, how do I calculate, how do I calculate final velocity using the velocity of the center of mass? You like subtract it and then turn it negative or something? Mm-hmm. And then you add BCM. Wait, but it doesn't, wait, I thought, hold on. Oh, yeah, it would be subtraction. Times -1. Add, what's the initial velocity? 1.2. Okay, I got 0. No, dude, that's not one of the answers. Bro, I subtracted the center of velocity, or the center of mass, the velocity of the center of mass. I multiplied it by -1, and then I added the center. Oh, wait, you add the initial velocity back? Oh, okay, I see, that's where I did it wrong. Okay, I got -0.56. Yeah, okay, good. Alright, bet. Bro, how are you studying for this exam? How are you studying for this exam? all the time. Alright, I'll talk to you later. Bye. Alright, bye. Let's see. Hey, if you can go to college on a full scholarship, I mean, that's the whole reason people don't go to college, is because it's expensive. So if you can go to college on full scholarship, you should 100% go. There's no reason at all to not go to college if you have a full scholarship. It's crazy. I mean, kids dream of getting full scholarships. It would be a waste if you didn't pursue that. International, yeah, I love everything about just going to school and learning at any means necessary. It's amazing. I don't know what my recommendations would be. Just do well in school, in high school, and make sure you submit a strong application. Yeah, I don't really know. That's what I did. Just make sure you do well in school and submit a strong application. Okay, inelastic collision. I think the conservation of center of mass velocity, right? 1.5 times 6 plus 4.5 times 1.5. Oh, because there's a negative. V2 is negative. It says they move in the positive direction. Wait, magnitude? Wait, kinetic energy should be a magnitude. I think it's a plus. I'm gonna do plus first and then I'll do minus after. Oh, it would be plus anyways, because the velocity would be the only thing that's negative and it gets squared, so it becomes positive. The velocity of center of mass squared. Holy shit. It's 76. Yeah. Mm. This is an interesting question. Okay. No, it's not. It should be 0. Yeah. Okay. Okay. Root 2GH. Oh, they don't even give us the mass, that's why. Yeah. Negative, yeah. Okay, there's an elastic collision. I guess momentum would be conserved. Yeah, momentum's conserved, so we have M and 3M, so M1, V1 is going to equal, Oh, it tells us if the velocity of the ball just after the collision. Okay. Negative V over 3, yeah. What makes a strong application and how a student in 12th grade can add extracurricular in college application. My extracurricular was hockey. I played hockey all through high school. I founded the chess club at my high school, took a bunch of AP courses. That's pretty much it. I kind of had a bad application, but it was like, well, not a bad application. I had a good application, obviously. I got into a pretty good school. But I played hockey, so like my extracurriculars were pretty limited because I played hockey at a very high level. I was planning on, I wasn't planning on coming to college this year. I was gonna play juniors and then hopefully play D1 hockey afterwards. But I got injured, so I had to apply to school, and then I was paralyzed, and then I started my applications. So I think I had like one really, really strong extracurricular because I was putting in like, they just want to know like if you put in a lot of work in something outside of school. And so I was like, with hockey, it was like 40 hours a week of training. So they knew that I was like a dedicated individual who's hardworking, and that's all you want your extracurriculars to show. I don't think that's true. I don't think I'm a genius compared to you. I don't know you, but no one's a genius. well, that's not true. I don't know what I'm saying. I'm not a genius. Yeah, I'm sure there's plenty of things that you're more intelligible than me. Yeah. It's like maybe you're not as good at physics or something, or I don't know what your metric of I'm a genius compared to you, but I don't think that's true. Everyone's a genius. Yeah. I don't think I don't know. Thank you for the compliment, but I think you're a genius as well. Everyone's capable of being a genius. That's what Richard Feynman said. He's like one of the greatest physicists of all time, and he said that he's not a genius. He says he's an ordinary man who spends his time studying physics, and that's how he became Nobel Prize winning, one of the greatest physicists of all time. And he just said he's an ordinary guy, which is true. It's like everyone's just an ordinary person. No one's really that different. If you look at the biology of humans, we're all pretty similar in every single way. Greetings from Germany, greetings from the United States. Yeah, see, that's fine. Physics is a subject where if you just spend more time learning it, then you'll become good at it. So doesn't mean you're not a genius, it just means you haven't put in the time to learn. And once you do, then you'll become a genius. Do you have any source of income? I do. I started a company a couple years ago. And so, currently we're sold out. I have a clothing brand. It's a mental health awareness clothing brand. It's called You Are Never Alone. It's probably my YouTube bio. But it's also on my website and my LinkedIn and my Instagram. But yeah, I have a clothing brand, and we were making money. We're not currently making money, so I guess technically I don't have an income right at the moment, but I made a lot of money doing that, and so that's kind of helped me. But I also spend a lot of my parents' money, which is yeah. I just want to be honest. But yeah, I mean, I have investments, but I wouldn't really consider that an income because they're all long-term investments. You want to get into electronics? Yeah, electronics is great. I think computers and electronics are the future. Then again, I am biased again. This is what I'm studying. Okay, I need to solve this. This is my equations. We don't have mass or anything? Okay, well, we can cancel out the mass. We have V1 equals negative V1 over 3 plus 3V2. Alright, I can easily solve this. What are we solving for? What is the velocity of the block after the collision? Oh, we don't even have to... So we have 3V over 3 plus divide both sides by 3. Do you separate degree for AI and machine learning course and university courses? So I have my whole bachelor's degree. Bro, are you kidding me? Okay, I have my whole bachelor's degree here. So I'm graduating the spring of my junior year. And I'm taking a bunch of AI courses, so like CS 440, CS 446, 441, 443, and 444. These are all machine learning and AI courses. Yeah. Yeah. So I'm taking a bunch of machine learning courses. I try to learn as much as possible outside of school as well, but obviously the teachers and the professors here are going to be able to teach me much better than any online resource possibly could. So I'm waiting for those. I'm pretty excited. Oh, fuck this question. Okay. Okay, well, we know the final velocity is... Okay. To compare the kinetic energies, 1/2. Okay. So our initial velocity is 3.8, yeah. We can cancel out m, so 1/2 times. Okay. Yeah, I didn't get, it was, the collision was inelastic. This might be incorrect though. Harvard would be the best place for you to get a PhD in physics. Yeah, I mean, Harvard's PhD program is RA. The school that I'm at right now, we're ranked number 9 in physics, in the US at least. But I'm planning on going to Oxford for my PhD. And I'm getting my PhD in machine learning, not in physics. I'm getting my bachelor's in physics. What is the least number of subjects we can take in undergrad? It's completely dependent on where you go to school, but at my school, the least amount of subjects. They don't really categorize it by subjects. It goes by credit hours, and you have to meet credit hour requirements in like each subject. So like, for example, this is my degree. This is my degree, so I have to take like general education requirements, which I'm pretty much done with all of these. Yeah. And then you have to take your foundational, foundational mathematics and science is required for everyone in the engineering school. All of these courses, which I've taken most of them, just these 3 I haven't taken, and these 2. And then like I have to take my physics technical core, my program track. I'm doing computational physics, so I have to take 24 credit hours from these courses, 6 from here, and then 1 from here. So I guess in total the amount of subjects I take is like computer science, physics, and then like these gen eds. So yeah, it's completely dependent on what your major is, but I would say like 4 to 5 subjects, but you really only focus on 2, and mine are computer science and physics. Oh, and I guess math, but that kind of coincides with physics. Yeah, on Harvard's a great school for physics. For computer science, they're not that good. Like, so like my school is here, for best computer science schools, and Harvard is, I think they're 18th. Oh, 17th. Harvard's 17th. So they're still pretty competitive school, but my school is just a lot better. I really want to go to MIT, but or UC Berkeley. My parents went to UC Berkeley, and my sister, but I don't really see an opportunity for me to do that because I'm gonna do my bachelor's in physics here. I'm probably gonna do my master's here as well, just because of how easy it would be for me to transfer my credits from my undergrad to my master's, and then I'm doing my PhD at Oxford because I want to become a Rhodes Scholar. They pay for your entire PhD. It's very competitive. You have a 3.8 minimum GPA to apply, but that's not really a problem. Yeah, that's why I want to go to Oxford for my PhD. But I may go to like MIT or UC Berkeley or something for my master's, depending on how I feel when I'm doing my applications. As of right now, I don't really see a reason to, besides for that I just want to. So I'm not really pursuing that too heavily. And then my school also has like this thing where if you teach a course during your master's degree, you get free tuition, which is great because I'm going to be in school for a pretty long time, so I want to get as much free tuition as possible. That's amazing. Free learning is amazing. Oh, I don't like this question. Oh. Okay. All the mass is the same, yeah. These are both cosine. And the masses and the velocities are the same? Yeah. So this is just m v cos squared. Oh. Oh, all 3 masses are the same, so we can cancel out. Wait, why am I solving for v? What am I doing? You divide them. So we get 1/2 mv squared. I think the V's are different though. What the fuck is going on? I think it's 2 cosine squared. It's just the difference. Multiply that side by 2. Yeah, mv squared. And these cancel, so it's just v squared cosine squared. Yeah, it's just 2 cosine squared. I want to apply for Ivy League, and I'm an international student. Been into music for more than 5 years. Top 16 candidate of singing competition nationally, and done some volunteering work. Yeah, it sounds great. Sounds like you'd have great application. Volunteering work is obviously amazing. Top 16 candidate is nice. It's good to see you've been dedicated to something for a long time and you've kept pursuing it. Yeah, Ivy Leagues are great. I would look, you should continue to apply to Ivy Leagues, but some schools you might want to add, you should look at just specifically what you want to do and look at the rankings for that in that major. Because Ivy Leagues will look at all candidates like holistically, but if you apply to like something very specific, you can maybe go to a school with a higher acceptance rate, but still a very competitive program. Like if you like, I don't know, if you want to go to like business rankings, best undergraduate business program. So if you're looking for like, if you want to go to business school, obviously like there's UPenn, MIT, UC Berkeley, but if you continue looking down this list, like you'll find some schools. Look, University of Texas Austin, number 5 in business programs. If we go to UT Austin, their acceptance rate is 31%. And they're obviously a very, very good business program, number 5, but it's 31% acceptance rate for the school compared to like NYU, which is below 10%. UMich is like 2%. UC Berkeley is also. MIT is the hardest school in the country to get into, and UPenn is also insanely hard to get into. So it's like you should apply to these schools because the competitive schools are really good, but there are still some schools that are a little bit less competitive, but you still get the same caliber of learning. So those are like the most lucrative schools to apply to because you have a higher chance of getting in, but you don't compromise any level of education. And stay away from like the overall rankings because that's stupid. You want to look at like your like rankings that are specific to you and what you would be doing at that university. It's like if a school is number 1 in the country, but they're only number 1 because they're ranked top in all music programs, but you want to go into STEM, then like there's no point for you to go to that school even though it's ranked high, because it might not be as good for something that you want to do, and you should go to the place that's going to benefit you the most. I've not participated in the math Olympiad. I wish I did in high school. I'm not really interested in it anymore, but yeah, I've not participated in the math Olympiad. I think this is the answer though. 2 cosine squared. Yeah, I think it's 2 cosine squared. It's not. It's 4 cosine squared. Okay, so let's see why. 1/2 is 1/2. These are the same. Okay. Oh, we can kind of cancel. Oh, wait. No, but that doesn't change anything. You still don't get 4. You still get 2. Yeah, I don't know how they got 4. Oh. Oh, I get it. I get it. Okay, well, let me redo it. Wait, what? What'd they get V1 equals? Don't you get it? How did... Oh, they did conservation of momentum to solve for the velocity. I was gonna say, like, what? Where's the square going? Yeah. Okay. M1 V1. We can just say V. And so now we get half. Because the masses cancel, we get 1/2. Four cosine squared. Exactly. This explosion was part of this. Oh shit, the center of mass. The center of mass would remain the same. Oh wait, no, what wait, let me see what cosine. Okay, it will become smaller. So the velocities of the tube and down here would become smaller, so I think it'd move upward. No, it would remain at rest. Yeah. Yeah, I'd have to. It'd have to remain at rest. What's up, Robert? How's it going, bro? That's fire. What book are you reading? Okay. Do you want to do conservation of momentum or what? No. We'll do conservation of velocity of center of mass. Yeah, I've got to study discrete math later today. Got to do state diagrams, induction inequality, or inequality induction. I think you're referring to like how much free time you have in college, and it's a lot. It's a lot of free time. I mean, every single day you have at least like 5-6 hours of daylight where you're not in class. Yeah, I mean, people have jobs while they go to college. Like, you have plenty of time. People work 40-hour work weeks while in college. You have tons of time outside of school to do anything you want. Yeah. Hardware, yeah, I have to take discrete math for, it's a prereq for a lot of the classes I want to take. Velocity of the ball, it's like conservation of center math. So go. Wait. Wait, the initial velocity is 0. Oh, right. Exactly. So it's going to be 0. Okay. So we're essentially saying that 80 times 0.04 equals 0.25 V. What's your thoughts on A-level? A-level, I think it's courses. Yeah. Yeah, okay, yeah, it said A-levels are generally considered to be more challenging than AP courses, which is great. Do you get college credit? Yeah, okay, A-levels are great. It sounds, from what I've seen so far. My school gives college credit for A-levels. Yeah. So that's great. I mean, taking college credits in high school is like a cheat code. Especially the introductory courses, like the weeder classes. The weed out classes. Taking those in high school is such a cheat code.
Are you done with these?
What?
Are you done with these?
Done with those, yeah. Are you taking them home?
Yeah.
I think I might have more as well. I don't know.
Hi, Dream.
What?
Hi, Dream. One slow dance in my head.
Oh. Wait, this is, what is this? Oh, work equals force times distance. Yeah. Oh wait, no. No. Yeah, A levels are great, it seems, from what I've seen so far. Just briefly doing. Yeah, I do not remember how to do this question. Shut the fuck up. Wait, they're saying the integral of force is what? Oh. Is work? Okay. Oh shit, they have a bunch of shit. Okay. Which is just gonna equal force delta T. And work also equals change in K. Starts from rest? Everything starts from rest? Yeah. I'm just gonna solve for force. Okay. Yeah. Yeah, I mean, I think you're fine. Sounds like you're taking a lot of A-level courses, which is great. Rob went to CC and then went to Berkeley, which is great as well. Yeah, I bet you saved a bunch of money. I know kids that took like dual enrollment in high school, and their high schools paid for the classes, so they didn't even pay at all. And they came in with like 80 credit hours for free. They graduate in like 2 semesters. Just so crazy. Yeah. Sounds like you're chilling though, Garav, if that's how you say your name. Sounds like your application is gonna be very good. Oh no. I got something completely wrong here. Oh, my iPad's not updated. Oh, it's probably because it's not connected. Yeah. College student loan debt sucks. Credit transfer, it's like the college will give you credit in the class so that you don't have to take it. Like, if you get a 5 on the AP exam, then you don't have to take that course in college because they recognize the AP exam as if you took the course already. Yeah. Music and art history. Not to say, I mean, those are fine majors, but like the rate of return on investment is very, very low for those degrees. Oh, just of the ball. Just of the ball. Yeah. Wait, but I'm still getting a crazy number. Okay, wait, let me see. Where'd they get this equation from? The change in... Oh, impulse! Oh, I completely forgot that impulse existed. Yeah, they're not using work at all. They're using... Yeah, okay, that's crazy. Completely forgot that. Yeah, my school says, my school says all you need is a C or higher. You don't need an A star or A plus or whatever you guys call it. Yeah. So it depends on like the department. Like the physics department requires that you get a 5 on the AP exam to get college credit. And the CS department does not take AP exam credit here. But like math, they'll take like 3s, which is kind of fire. But yeah, generally 4 or higher is yeah, APCS courses are so stupid. Yeah, 100%. You might. It's yeah. The kids that come in with like the AP CS classes, like you can't use it for to get out of the classes, but they still struggle with the intro CS courses here. There's no cheat code. There's no way to get around it. You gotta learn. You gotta learn the introductory stuff. Jeez, dude. What is this? Bro, this is like an essay. Okay. Yeah, CS 173 is kind of like a weed out course here. Honestly, our CS department doesn't really have that many weed out classes. I thought the introductory classes were very, very easy. I'm done with them, and I thought they were very, very easy. But some people dropped them and changed majors and stuff. But I think that was pretty seldom. But like chemistry is required for all engineers, and like people literally like drop out of school after taking chemistry. Bro, look at this shit. This is the required chemistry course for all freshmen in engineering to take. Bro, look at these GPA averages. You kidding me? If you have this professor, it's like half the class got below a C. Half the class got a C or below. 20% got D's. Like, that's ridiculous. Yeah, it's crazy. 50% is so crazy. Yeah, there's some classes that are pretty hard here, but they're like the 300 level. In the ECE department, the electrical and computer engineering department, those introductory classes, like, people actually like really struggle with. Those are weed out classes, ECE 110 and ECE 120. If you take those the first 2 semesters of your freshman year, and they're brutal. Okay, so this is probably kinetic energy. Okay. Okay, so the coefficient, so the force of friction is gonna equal. Oh, what does it want me to do? Find. Oh, but I know the force of friction. 0.45 times 1.5 times 9.81. Yeah. Bro, I can I can see behind me. I have my I can see my camera. I can see my camera on my second monitor. Yeah, no, I had to cut out all Instagram and YouTube from my life. I don't really enjoy it though. YouTube videos are pretty cool, but yeah, shorts and stuff, I don't enjoy it. It doesn't, yeah, I don't know. I don't enjoy scrolling on Instagram or any of those brain rot apps. Okay, so the initial kinetic energy. Nitin. There's someone at my school named Nitin. Maybe it's the same person, but that's not their last name, so maybe they have different last names. Yeah, 100%. I would think. I think he's Indian. He said, "Bro, stop yapping." Yeah, it might be Nitin. I might know who this is. Okay. It's gonna. We want it to equal 0. We could just use force times distance. So I'm just gonna say 22 equals F times yeah. I just get I have to, bro. I just get up. I get up, I have to. Sun's gonna rise, sun's gonna set, regardless of if I do my work every day, so I just gotta do it. What's really helped for me, I don't know, yeah, I just get up every day, I have to do my work, there's no other choice. I don't really have an option, I've never really thought about it. I mean, it's either this or like I'm homeless, right? I have nothing else. I have to just try my hardest at what I'm doing right now. Yeah, no, this is wrong. Oh. I get it. Okay, wait. Wait, do we know the kinetic energy of friction? Like, done by friction? We know the work done by friction, but like... I know you have to relate this to kinetic energy. Is L like necessary? I don't think so. Okay, so we know the initial kinetic energy at this point here is going to be 22 joules. So we need to know how much distance he travels. Maybe it's this. Wait, this cosine theta. No, sine theta. What do they do? My GPA in high school was 4.8 when I applied, and then after I got my admittance letters, I just like stopped going to school. But yeah, it was 4.8 when I submitted my applications, and then I stopped going to school after that because it didn't matter. The fuck is this, dude? Yeah. MGHF. F. Bro, what the fuck is going on right now? Yeah. Oh, this is incorrect. Yeah. Gave him your whole daily routine. That's great. I mean, I can't help but wonder, did they do this more? Bro, I mean, this is like for students to learn. How can they possibly look at this fucking scribbles, bro? This work is impossible to follow. Yeah, you can be as loud as you want in the dorm. Yeah, there's a skill diff, bro. This guy's a PhD physics guy. I'm a fucking student. Should be explaining it like I'm a toddler. I'm also not watching or listening to the video, but I didn't think I needed that much help. MGHF. What are you talking about? Oh, MGH final. Okay. Yeah, that makes sense. Work non-conservative. Oh, that's what they did. Wait, what?
And so
Bro, can this thing go out of the way? Get out of the way. Bro, I can't see the text on the bottom. Okay. Yeah, I mean, I get it. Okay. I get what he's doing. So it's still the same thing. Like, the initial kinetic energy is going to be the same. How much was this? 22 joules. So that's going to equal the final potential energy. Yeah. Final potential energy equals mg final. Oh, no, it's not, because the energy is not going to be conserved, because there's a work done by friction. So we have mu times n times d equals what? Yeah. The difference in the difference in potential energies is going to be equal to the force done by friction. Kinetic friction. 0.45 times. It's a normal force. mg cosine theta. Oh, times d. Yeah, I read tons of nonfiction books. If you go on my website, I have my bookshelf. It's all the books I've ever read. Every single book I've ever read in history. The links don't really work because I haven't I have to copy and paste all the links into the HTML file, which is like very tedious. But for the top 3 books and the honorable mentions, there's links. I think for all of them. Yeah. So for my top 3 and honorable mentions, there's links. But all the other books you're gonna have to look up yourself. But yeah, every book in my collection is right here. They're all behind me, but I don't really want to get up and show them. But yeah, you can see them on whatever device you want. aidenandrews.info. Hopefully I spelled that right. What is that, dude? Yeah. And sent the link in the chat if you want to see it. Okay, let me solve this. D equals D sine theta. MG is 1 point. I'm just gonna leave these. Who was that?
No, you just seem focused. So.
I'm gonna keep this as a variable. Okay. So now we need to solve for HF. Oh, I can't do that. Wait, how can I do this? There we go. Oh my gosh, okay. Yeah, I made my website. Took me about a week. It sucks though. I hate front end development. It's so stupid. 1.5 times 9.81. This number's gonna be tiny. Times 1.5. Oh. Both thetas are the same. Yeah. Oh my gosh, that's fucking nuts. Bro, look at this fucking equation. Dude, do you see this equation? Oh, you guys can't even see like the whole thing. Bro, that's nuts. Like, why would they do that? Alright, see you later. Best of luck in your college applications. Good night. Everyone the phone. $75, dude? Are you fucking kidding me? Jeez, bro. $60? Are these textbooks? 2,000 ratings, 4.3 stars. What does a spiral bound look like? Oh, that's disgusting. Yeah, I don't know about this pattern recognition book. I'm gonna have to do a little bit more research on it. But, look, I love adding to my book collection. And this one's nice. It says Elon Musk, MIT. Not really ranked that high, but great reviews.
So disappointed.
This guy didn't get so lucky. These are all about the book getting destroyed. Yeah, no. But that's not on the book. Like, that's on the whoever delivered it. Or maybe they bought a used one. User error. Oh, wait, no. I want to deliver that to my house. I'm about to go home for summer break. I just ordered the book. Oh my god. No, that's crazy. I can't believe that. Those people's books were just completely destroyed. The pattern recognition, I mean, whatever, I guess I'll buy it. It's just free delivery by tomorrow is kind of crazy. But what about if I delivered it here? So I have it here by tomorrow. Okay. Well, I guess maybe I'll be able to buy it. Oh, $81? Alright, I bought this book too. It's getting delivered by tomorrow. $81. It's kind of crazy. Love it. I love adding books to my collection. I'll have to read them over the summer. Damn it, I have too many books now. I can't read them all. No, I can. Okay, after reaching H max, the block. Oh, interesting. Does it overcome static friction or not? The max force of static friction is gonna be mg cosine theta times mu s. I will. That's the goal. I want to become an ML researcher, head ML researcher somewhere. That's the goal. I will remember you, Robert. I think I'm gonna, once I get a little bit bigger, I'm gonna make a Discord, free Discord, of course. I don't believe in stealing people's money, but I want to make a Discord so that like everyone can talk. I can talk to a whole bunch of people about like machine learning and stuff, and just science. But that's gonna be in a while. It's not gonna be paid. I'm never gonna make anything paid. No ads, nothing. I'm not doing it for money. I don't care enough about about that money. But yeah, I think a Discord would be fire. So I need to know if this is gonna overcome static friction. So the max force that static friction can exert is 6.26. And wait, I forgot. Okay. So should I relate this to like the kinetic energy? So you know the work done by gravity at that point is going to be mgHf, and that equals 1.5 times 9.81. Oh, no, it's going to be the same thing. Cosine times HF 0.913, which is 11 joules. Oh no, it is MGH. It is MGH. What am I talking about? It's just MGH. It's not no cosine. 9.85 times 13.437. This is joules. This is newtons. Okay. Yeah, I don't know what the fuck to do. Yeah, I'm learning linear algebra right now on my own, but I'll learn it formally in school next semester. I'm doing vector calculus over the summer. Sent you LinkedIn invite. No, wrong email. Wait, it doesn't even matter. That doesn't exist. That account doesn't. Oh shit. Right email. I bet Robert. Yo, we're locked in. Me and Robert are locked in, bro. That's funny. Yeah, that's great. Me and Robert are locked in for real. Okay, wait, I need to do this problem. I don't know how to do this though. After reaching Ace Max. I mean, I can just use like intuition, but that's going to be completely incorrect. I think it just stays at rest. Because what's going on? What happened to my music? Wait, does it matter like how high something is for friction? Because friction's just the normal force times. I'm just like trying to think. I mean, it should stop, right? Okay. Now they're making this crazy. Okay, let's see what the... Bro. What? Sine 25. Oh. Dude, I'm such an idiot. Okay, look. Bro. Like, this is our theta. And F max is 6.2. So the force of gravity is going to be 9.81 times 1.5 sine of 35, which is 8.4. 8.4 is greater than 6.2. Yeah. That was stupid. I don't know how I didn't figure that out without the help. A block of mass size on a horizontal friction surface. What the fuck? Okay. I mean, I see this. Okay. Should we do conservation of momentum? Yeah, not kinetic energy. Is going to equal M1 V1 plus. Oh, it's going to be the system. Wait, they moved together? Oh, yeah. That's the answer. No. Okay. Now we do kinetic energy. Now we do kinetic energy. So we know that half k delta x squared, right? Yeah, half k delta x squared. V squared. Oh, it only gives us VC. Gosh fucking damn it. Okay. So we need to use this equation. Equals 0.4. Okay, so V1 is going to equal 0.4 times M1. Bro, why does this always happen? This app is useless. I don't even know where I was now. I think I was up here. Gosh damn it. Oh, I did draw a free body diagram earlier, right? I think I was down here. Dude, gosh damn it. This app is so useless. Bro, I have no idea. Oh, here we go. Oh yeah, I did this earlier. There we go. Stream audio is bugged. Oh shit, actually? Oh no, stream audio is not bugged. Yo. Yeah, it's just your device. Robert says it's not bugged, listen.
Alright, switch then. Wait, you gotta talk.
What?
You gotta talk on the stream so you can hear the audio. You can't hear the audio.
I don't have it live. But am I talking?
You're not even playing the video. Yeah, is it still messed up for you?
Yeah.
Yeah, it's fucked. I don't know if I
Not
guess
for
it's not
you.
the stream though.
Do you hear it though?
No, yeah, it's fine on here.
Yeah.
Oh, that's weird.
I don't know. Rob says it's
Yeah,
fine.
Rob says it's good. What the app?
But thanks for the heads up. That's good looks. No, his audio was actually bugged. That sounded terrible. It was disgusting. I mean, that was like unbearable. I couldn't listen to that for like more than 5 seconds. Okay. Oh, now I've completely lost my train of thought. It's a skill issue. What was I? Oh, right. I was solving for this. V1 equals 0.4 times M1 plus M2 over M1 V1. Okay. M1 plus M2. 6 plus 1.5. Oh, no. Wait, what am I doing? What am I talking about? It's just over M1. It's just over M1, right? 2. Multiply both sides by M1 plus M2 divided by M. Yeah. Okay, so it's 2. So V1 equals 2. Flat. I don't know how that's possible. So now we can do half times 1.5 times 2 squared. Dude, what are these numbers? What? Work of the spring is going to be equal to half times K, which is spring constant, 175. Oh, just times 2 divided by 175. Delta X is 0.03734. I got 0.034. Uh-oh. Let's just think about how I did this. Okay, so there might be another way to solve this. Well, do we know if kinetic energy is conserved? It has to be. In this instant, it has to be. Regardless of the collision is elastic or inelastic, leading up to the collision, kinetic energy is not lost. It's transferred into the spring. Yeah, dude. Yeah, no, it's wrong. Okay. We did p squared over kinetic final minus kinetic, so yeah, equals 0, right? Kinetic. Why'd they solve it that way? Changing. Interesting. Why? They use p squared over 2m. I don't see the need for that. I guess you get a different answer. I don't know how you possibly get a different answer. But okay. So kinetic energy initial equals p squared over 2m. Kf equals p squared over 2m. And I guess half k delta x squared will equal kf minus ki. Okay, pi equals mv 1.5 times v1 times 2. pf equals 0.4 times 1.5 plus 6. I think this is 3 as well. Oh no, this is 8. This is 8. Right? No, it can't be 8. Wait, what's M1? 1.5? Oh, so it is 3. Oh, no. 3 times 1.5. It's 4.5. I think. 0.4 times 1.5 plus 6. It's 3. It is 3. An idiot. Okay. Okay. So half k delta x squared equals 9 over 2 times m plus m minus 9. Okay. 9 over 2 times 1.5 plus 6 minus 9 over 1.5. Oh, 2 times 1.5. Yeah. Times -1. Okay, times 2 divided by 175 and the square root of that. 1.65. I got delta x equals 1.65. Okay. Oh yeah, let's move. Let's move. We've gotten to askew. Let's go over here. So it's positive 44. But let me solve for it. So okay. Start at rest. Okay. Kf minus Ki equals half mv squared minus half times 2.8 times 3.9 squared 21. What's the force? Wait. Work done by the rope. Wait a minute. Wait, so M is just 1? The work done by the rope is positive, right? Yeah. So M is just 1. Okay. Oh, there's friction. There's friction. Okay. I was tweaking. I was like, what? Okay, so this is the work total. Okay. Work done by the rope equals 44. Work done by friction equals 44 minus 21 equals 23. It's 44 minus this number. It's 22.7. Okay. What is mu K? Okay. Work of friction is also going to equal... Bro, I can't write. What's the... Oh, that's what I'm trying to solve for. Mu K times M times G times 2M. And apparently 2M just equals 2. Yeah, 2M just equals 2. So we can just do that. Whatever. What's mass? 2.8 times 9.81 times 2. 54.9. Okay. We have theta. Is there friction? Frictionless. Okay. We know the work of the spring. Oh. This is not true. None of this is true. This is incorrect. We know the force. Where's force of spring? K delta X. Yeah. We actually done it much simpler than all of this. Mg sine theta equals K times delta X. Okay. Oh, and we also don't know the height. Yeah. Wait, what? So we're trying to solve for L naught. Oh. Okay. Yeah. Alright, no, I guess this is correct. Yeah, okay. The block is then pulled down the ramp, further stretching the springs. At what length will it be moving the fastest? Oh, I guess this is just intuition, right? Because at L naught, it's going to have the highest force, but not the highest, and the highest acceleration, which is what that means, but not the highest speed. The block is moving. The block will be moving the fastest right before the force alternates to pull the other direction, so at L1. The block is then pulled down the ramp to L2 as the block slides up the ramp. Yeah, no matter what, the greatest velocity is going to be at L1, the equilibrium. What is the speed of the block when the spring's length is 0.35 meters? 0.35 meters. So delta x is going to equal 0.05. 0.35 minus 0.05. So the speed of the block, we're gonna have like half mv squared equals half k delta x squared. Wait. But what about gravity? What about gravity? MGH. No, we don't know H. So there's no let's just ignore MGH because we don't know it. I don't know how we'd calculate that. 1/2 times 250 times 0.05 squared times 2 divided by 2.8 square root. Wait, what do they do? Equals half k minus half. Jesus, this fucking handwriting is so terrible. 0.5 minus 0.4. Zero 0.5. Initial. What the fuck? Okay. Minus is claiming that they're oppositional. Where does the 0.5 come from? Yeah, we got this one. 0.5. Initial. Oh, from this? Oh, from this. Oh. I didn't know this was part of the question. Okay. Zero 0.48 minus 0.35 squared. I think it's the right one. 1/2 times 250 times 0.48 minus 0.35 squared. No, not this one. Zero 0.59. .59. It's crazy. It's the same speed. What's going on? What just happened? Is he like actually calling me or no? It's an accident? Okay. So oh, you know what we should do? We should do impulse. That's a little bit easier. So we want the V's to be equal. Divided by 2, so yeah, what? Apply the force to block 2m over twice the distance compared to block m. No, it's time. No. Applying the forces over identical time periods will have mv equal to 2mv, but so the v's won't be equal because the v's won't be equal. Over identical distances would be work, which is like force times distance equals half mv squared. And we get for the other block. Yeah, if you have the same distances and the same force, then your velocities are going to be different. Is this not the answer? I mean, it seems like this would be like a trick question. Okay. I guess it's not a trick question. What the fuck? That's whack. Oh. The y component of center of mass? The y component of center of mass. Case 1 should be larger. Oh. What they mean by y component is how high it is. So the second one will be higher. Because more mass is concentrated around this point on this one, and then the mass is more spread out. This mass is farther than this mass. Like most of the mass of this block is in this section, which is pretty far from the center. This is equal. So this is going to be right here. The center of mass is going to be right here. For this one, all the mass, most of the mass is down here, and most of this mass is down here, so it's going to be a little bit lower. So y1 is going to be lower than y2. Yeah, of course. Okay. This is universal gravitation. A satellite of mass 200 kilograms. Is released from rest at distance above the... With what speed is it traveling when it hits the surface of the Earth? Okay. So... U equals KF. Potential energy due to gravitation is right here. We get negative G M times little m over R equals KF, which is just half mv squared. Half mv squared. Right? Kinetic energy is always half mv squared. When it's really far away, it's going to have zero kinetic energy and only potential energy. And when it's close, it's going to have only kinetic energy and very little potential energy. When it hits the surface, it's going to have no potential energy, exactly. So G is 6.67 times 9 times 10 to the 11th, right? 6.67 times 10 to the 11th. Where's G? It's on this sheet somewhere. Big G. 6.67 times 10 to the 11th, exactly. Negative 11th. Yeah. And big M is 7.4 times 10 to the 22nd. Oh, surface of the moon. Okay, yeah. So big M is 7. Little m is 200. Radius or distance is going to be 1.5 times 10 to the 6th. Is it to the center of mass? I think it is. 1.738 times 10 to the 6th. So U equals 3.04 times 10 to the 8th. So times 2 divided by 200 and rooted. It's 1746. Fuck. What was the answer? 1620? GMM over RM plus GMM over RM plus H. So the potential energy at the surface plus the potential energy at the point. Why is... It makes no sense. Okay. I guess we'll add... What? Negative GMM over RM plus GMM over RM plus H. What? What? Oh, okay. So you're saying it does have a potential energy at the when it hits the surface. It's saying that it does have a potential energy when it hits the surface. Okay. So we have to subtract that. I guess we should always write out the total energy equals kf or equals u plus k. Right, u equals u initial minus u final. Wait, no, what am I doing? Okay. So we have 6.67 times 10 to the negative 11th times 7.4 times 10 to the 22nd times 200 over r plus h, 1.738 times 10 to the 6th plus 1.5 times 10 to the 6th plus g, big G, 6.67 times 10 to the negative 11th times m, same m, 7.4 times 10 to the 22 times 200 over the radius, 1.738 times 10 to the 6th. Okay, so we have half mv squared equals 8.7 times 10 to the 8th. Okay, times 2 divided by 200 and root that. Nope, still get the wrong answer. So I don't know what this guy's talking about. We still get the completely wrong answer, bro. Oh. No. I get the right answer. Sorry. My sign's incorrect. Times negative 1. Okay, there. Okay. Times 2 divided by 200. And then root that. We get 1622.09. $1,620. Perfect. We're done with this. Okay, I'm gonna heat up my sandwich and eat it. So I'll be right back. I'm gonna mute up. Yo, how much longer? How much longer, bro? No longer. I'm about to pack real quick though. I'm about to pack up my room real quick. My mom's coming to pick up all my stuff tonight. Sorry if that echoed. It shouldn't have been bad. Oh yeah, forgot to change that. Oh, I can't edit the name either. Okay, I just need to pack this one suitcase. Cause that's all I really needed to bring home with her. I'm just gonna throw all the clothes in there. Don't want that. Clothes are folded in. I'm gonna keep these here. Oh no. I don't know what else to put in this suitcase. Should I put all my books in it? I have way too many books. The heaviest suitcase I've ever felt. Jeez, dude. So many boxes. It's an evil world we live in. Oh, I still haven't bought those shoes yet. compelled me to keep these. Use some more. Oops. We're so messy. Okay. Let's get started. Okay. Let me grade my students' net IDs. What are their net IDs? Okay. There we go. Guess we can get started on this practice final. I kind of wanted to wait till later, so I actually am going to wait till later. I'm going to look to see if there's any optional questions. From the homeworks that I can do. No, I don't want to be a learning assessment. Okay, so there's no optional question here. I don't think there's optional questions on either of these. It's the same thing I just saw. Check this one. Check this one. Check this one. Oh, we can do that one. Oh, I guess then I don't need to check the homework assignments. Because we can check this stuff. Oh, why did I check so many questions? Okay. Well, I've done this for the most part. You know, there's these. No, I've done all these already. Okay, this is the exam 2. I've also done this already. But exam 1, I didn't do a single one. I don't know how I even studied for exam 1. That's only what I'm doing. Oh, that was AT2. I'd like no practice for the second or the third midterms. Okay. Let me see if there's another. OMG. Wait, let me grab my other phone. Just give me a second, bro. Whose fucking wedding is this? But his net worth is $1.2 billion into UPenn. We're in. Bro, why is their wedding so expensive? Why is their wedding so expensive? Fuck. Okay, let me lock in before I tweak out. Yeah. Streaming for 3 hours and 1 viewer. It says 0 viewers. I don't know how you even hear. Well, what do you mean by that, Chippy? Bro, it says 0 views on my thing. 0 viewers. I've only been streaming for 3 hours? No, that's not true. I've been streaming for like 5 hours. Oh, 3 hours and 40 minutes. 4 hours. Almost 4 hours. Wait, why does the chat not go all the way back? Why did the chat not go all the way back to the beginning? Robert showed up like halfway through. Oh, now it says 1 viewer. Yeah, I did. I'll send it. Yeah, me and Robert are locked in, gang. Fuck is you talking about? Are you with Jonah? Oh. I don't know why you can't see all the chat. How am I supposed to tell them to accept your chat? Show all messages. There we go. No, I still can't see all the way up. He said hi to me in chat. We were tight. I don't think he's here. I don't think Robert's here. Yeah, I think Robert left. Yeah, he was earlier, but he left. Bro, why can't I see all the messages? Like, no matter what I do, I can't see all the messages. Elsa Olsen? Bro, what the F? Oh look, see they go up, but I can't see them. Whatever. Alright, I gotta do the physics. Bro, I know I gotta lock in. Drew, no, low-key the physics is easy. This exam's gonna be so easy. I was stressing for the calc exam, but I'm not really stressing for this one. Alright, let me lock in. I remember this question. You gotta do quadratic equation. Okay, you get an A if you get 102. Okay. So not too difficult. Yeah, no, that's chill. That's chill. So height of the building is 50 meters. So the first block, or the first ball, is just gonna be, which one? The one that's dropped. Ew, dude. No, he doesn't. 0 equals 50 minus 9.81 t squared. So T1 equals 2.25. And then T2 is going to be, okay, so we get, okay, so we can calculate the time that it takes for it to get to, yeah, okay. So we get 0 equals, what's the initial velocity? 9.9 minus 9.81 t. And then you just get 9.9 divided by 9.81. T half equals 0.9. So T2, oh, well, not like T2. But this equals 1.9. So after 1.9 seconds, it's going 9.9 minus 9.81 times this. Okay, so we have V initial equals negative 9.7. Okay, so we want to get to 0. We start at 50. Our initial velocity is negative 9.7 minus half. Oh, this is divided by 2. T1 is divided by 2. This is actually 3.1. Just 3.1. Half AT squared, half 9.81 T squared. Okay, and now we need to solve this. So 4.905. So we get negative 4.905 T squared minus 9.7 T plus 50 equals 0. Right. And now we gotta solve for the time. Okay, quadratic equation. Nobody knows the fucking quadratic equation, bro. It's completely unnecessary for my life as a human. Negative b. So positive 9.7. Where do we get 9.7 from? Oh yeah. Positive 9.7 plus square root of b squared 9.7 squared minus 4 times a, which is negative 4.905 times c. What's c? 50 over 2 times a, negative 4.905. Okay, so we get a negative, so it's minus on the top. Okay, we get t equals 2.3. So our difference is going to be 3.1 minus 2.3. 0.8 is not a possible answer. Gosh damn it. It's definitely not 2.2. Oh. 2.3 plus 1.9. That's the problem. 2.3 plus 1.9 and then subtract 3.1. I got nope. Okay, I think T1's incorrect. So we want it to reach 0. It starts at 50 meters. We have initial velocity of 0. And we have minus half a t squared. And a is 9.81. So we get 50 times 2 divided by 9.81. And then the square root of that. Yeah, I mean, I'm just getting t equals 3.19. Okay, so there's a problem here. This is somewhere. The t to the max height is 0.9. We can just recalculate that. 9.9 divided by 9.81. Oh. Yeah, this is wrong. This is 1. Wait, 9.9. What did I do? 9.81 divided by 9.9 earlier. Yeah, 9.9 divided by 9.81 times 2. So our T2 is 2.01. So our VI is going to be 9.9 minus 9.81 times. This is negative 9.9. Okay, quadratic equation again. Such bullshit. 9.9. Bro, who invented the quadratic equation? This shit is so stupid. Times A. What's A? Negative 4.905. C is 50. Yeah, but I'm still getting 1 point something. I'm getting the first ball lands at 3.19 seconds. I'm getting the second ball lands at 2. And the second ball lands at 4.3. That's funny. I love G. Bro, Drew, how do I do this question? How am I doing? I don't understand what I'm doing wrong. I remember this question was stupid as hell, though. I'm getting 1.16, bro. No, I mean my calculations are 100% correct, so I don't know what they want me to tell them. What? Am I doing this incorrectly? Am I missing something? How would they possibly hit the ground with the same velocity? Still only 337. I remember this question. Yeah, dude, I don't need to do any of these questions. I know how to solve them all. Just need to do this. I'm gonna have to log in before when I do this one. I'll do some 173, guys. I already did this? Damn it. Bro, how did I do all of these already? I mean, I guess these aren't inequality induction anyways. Damn, I did not remember how to do any of this shit. All natural numbers. Oops. Yeah, I mean, I kind of remember this stuff. Okay. State diagrams. Review session. What? Bro, what the fuck is going on? Okay. So we start with state 1. This is our input state. Oh, we're roommates, yeah. Bro, what the fuck is going on? Yeah, I'm taking 11 credit hours this summer. Calc 3, physics, electricity and magnetism, general chemistry, and oh, is that it? Yeah, that's it. I'm so, bro. My exam on Wednesday. Bro, it's funny. Looking at it, SpongeBob and Patrick. Bro, I do not know how to do this at all. Like, I don't even know where to start. Yeah, I don't understand what's going on. What do you mean, okay? What's going on? No, we're doing like state diagrams. I have not learned FSM. Or I guess they're kind of similar. What the fuck is going on? My eyes don't work anymore. My eyes are broken. Bro. I kind of want to take a break, but I don't need to. Okay. What? Two mod 5. No, Chippy's not a physics major. Yeah. I'll learn this stuff tomorrow. Just trying to think if I'm fucked for that exam or not. Let me peep some past exam odds. Rob, I'm sorry. I can't do it. I'm not gonna do it. I don't want to. Yeah, I can do phone lattices. Like, look how easy this is. Bro, this is so easy. This is way easier than that one. Is the set of all RGB rings countable or uncountable? Prove justify your answer. In the rational number in the range of 0 and 1? It's countably infinite, right? Yeah, it's countably infinite. I'll put my life on that. Damn, this exam is long. Oh my gosh. Okay. Every function from the integers to the integers has a corresponding finite length formula. Yeah, I think it's true. No, that's false. They're not the same, no. A subset of a countable set is countable true. All circles in the real plane is uncountable. It's from the textbook. We can build a program that decides whether an input program halts. false. Review exam, that's kind of crazy. Okay. Okay, so it's not it's not irreflexive. It's also not reflexive. What the fuck does symmetric mean? It's not anti-symmetric, is it? No. Damn, I gotta look over these definitions again. Oh, I can do this one. Just draw state. True or false table. What are those called? I forgot. Shit, what the fuck? Okay, we haven't worked with LCM this whole semester, so I don't know.
Yeah. Yeah, I just need scissors. No? People would probably think you're so weird, bro. What? The 7th. So Tuesday, or no, sorry, the 8th, Wednesday. Do you have or no? Do you have them or no? I need scissors. Alright, can I use that then? Can I use that? Use it.
No, you're gonna break it.
I'm not gonna break it.
Yes, you are.
Then answer me. Do you have scissors?
Give me my screwdriver. It's gonna break.
I just need to cut tape, bro.
Yeah, it's gonna break.
Yeah? Yeah. Bro, come on, dude.
Okay, let me figure this out. The cardinality of A minus B equals the cardinality of A minus true for some sets, right? Because well, A minus B is the elements in A minus the elements in B. But if all of the elements... I think it's true for some. A function from the reals to the reals is strictly increasing if and only if it is 1-to-1. Increasing? Well, yeah. Yeah, that's true. It would have to be 1-to-1. 100%. All elements of M are also elements of X. Okay, M is a subset of X. It's the second one. M is a subset of X. Okay, I mean, this isn't too bad. Oh shit, there's another page, dude? Is the graphs... Okay, that's super easy. I just did the graphs exam. Cycle 7 bipartite. I don't know, I'd have to write it out, but it's easy to figure out, very easy. That best categorizes each number. K squared. What the fuck? Okay, so it starts at -2. +2. I think it's this one. But now you know to be defined recursively by for all integers n is greater than or equal to 2. 1.5. Oh, this is easy. Is O. No, it's not. It's neither of these. It's definitely not theta. And it's not big O of it because... Oh, it is big O. Because n to the 1.4 is greater than n to the 1.5. Right? Oh, no, it's not. No, it's not. What am I talking about? It's neither of these. Total number of leaves in a full and complete 5 area tree of height h. 5 area tree. So it either has 5 or 0 nodes. Total number of leaves is going to be less than or equal to 5 to the h. Well, it could be 0, right? Oh no, it couldn't. It could only be 1. Oh, it might be 5 to the h. Oh no, it's not. No, it's not. It's 5. It's just less than or equal to 5 to the h. Yeah. 4 n over 2 equals 1. The height is log base 2 of n. 4 to the log base 2 of n is root n. Same thing as n to the log base 2 of 4, which is 0.5. Oh wait, log base 2 of 4. Oh no, that's 2. N squared. It's O of n squared. It's theta n squared. Plus n. Summation of n over 2. 4 leaves. It's gonna be 2n at each level. Summation of 2n. Oh no, it's just gonna be 2. It's gonna be 2n log n. Yeah, no. N squared. It's n squared. It's theta n squared. Ah, see, I told you I'm chilling. Not really that big of a deal. It's this physics, boy. Alright, 52 question exam. I'm gonna do it in a second. I just need to, I don't know what I need to do. I need to take a break. What time is it? 4:01. Fucking hell. Oops. Beautiful. Need to do something that requires 0 thinking. I'm playing chess. I'm playing puzzles. On chess.com for like 10 minute, I'm 1600. But over the board, I think I'm probably like at 21. Like no time limit over the board, probably 2100 or something. I dropped puzzles so hard. I was at like 2300. I've been selling. No, I wouldn't do that because then he's getting made in. No. Fucking piece of shit. What's the difference, bro? That's pretty good. Anything over like 1200 is pretty good. Yeah, the thing is I can block like all his checks. There's no way he's telling the truth. Yeah, no, he didn't switch it for me. Bro, stop talking to me, Siri. Is that me? What? I mean, I see sack, but I don't see what the move would be after that. Oh, I could also take. Yeah, that's it. Wait, but wait, but now what? Am I missing something? Knight h5. Oh yeah, that looks good. Yeah, knight h5, that was good. What? It's the same thing, dude. I don't know what you want from me. Oh, what? What? What's his move here? No. I should be 2100 puzzle. You should be. That puzzle rating was, it was 1870. Oh no. Wait, which one was that? Oh, this one? It was 2005. think it's take sax. No, yeah. Oh, wait, what? Why can't I do that? Oh, I'm an idiot. I thought it was second rank. Second rank pawn. Okay, so that's definitely not the move. Then it's here probably. Do I see a maze only thing? Yeah, I do. Oh. Oh no, this is mate. That's mate, yeah. Okay, I got it, bro. Dude, I don't care. Yeah, I already did this. No, I don't think that's move. I think it's sack and then take and then plays. I don't see anything else. That's what. No. Yeah, I think I'm thinking too hard for this. D4 pin. What? D4 pawn must up pin move. Must move. Alright, Jerem. There you go, Jerem. D4 pawn. Takes and then yeah. D4 pawn. Should I take first? Should I take or takes? I already did it. Rewind. I packed up. I packed up a bunch of stuff. If he takes, it's check is the only thing. But then I take, or I can take. Oh, but if I take, takes. Yeah. Wait, why can't I see the puzzle rating? Okay, whatever. Okay, this puzzle is actually going to be a difficult puzzle. So this is pens. Oh, because that's me. Yeah. What? 2268. Wait, What? That's kind of crazy. That's a crazy ass puzzle. Oh, never mind. Okay, let me think. Is that mate? It's not. Is that mate? That is, yeah. Minus 13? Are you high? What? Wait. Oh, because he has takes. And that's check. Yeah, that was stupid. That was stupid. Should I take? This is like a no-brainer. I'm confused. Yeah, but that's a... There was a time looking through my father's eyes. Happy home. Yeah, I mean, I imagine I'd want to save my queen. Is that winning? No, it's losing. Because it is king. Oh. Wait. Oh, because he has queen. What? What is this? Oh. Was it 1816 puzzle, bro? Oh. Obviously, that's what I want to play. That's ideal. But there's nothing to protect it. Oh. Yeah, but doesn't he have... Yeah, but then I have this. And then he's... That's me. That's me. Oh no. Oh wait, no, we can't play that. I gotta make, cause like I'm just losing a little bit. Oh, then I have no idea what the move is. Oh, I'm an idiot. This is my iPad. It's my iPad. It's connected through AirPlay. Oh wait, it's about to be connected to AirPlay. It's my iPad. Oh, what? This is nuts. Bro, do you see this? I'm just like completely killing him. Yeah, it's sack. Takes. Whoa, this is like not very winning. Is that mate? No. He blocks. And I assume it's check, because I want on the move. Bro, like, I just don't see it. I'm getting, he's queening, bro. Like, I'm just losing. This game's just over. Let's see how I can. Bro, if I play any move that's not check, he takes and queens. But if I play check, then he takes. I don't see. Yeah, but then he queens. Yeah, then he queens. But I don't see any other move. Like, I don't know. Like, what is this? Oh, yeah. I don't know what this is. And then you mate. I guess I just didn't see it. I mean, that's a 2165, so I guess. So many moves. Oh, I'm in check. So few moves. Thought I had so many moves. And then it's mate. So it's definitely not here. Oh, I can't go there. Yeah, I don't see. What do you want me to do? But it's mate, I thought. Wait, what? How am I not getting mated? Yeah, and then takes. Wait, how am I not getting mated? Oh, no, see, it's me, yeah. Oh, I can block? Okay. Oh, I'm an idiot. An idiot. Your brain CPU is getting cooked. Well, that's how I felt doing the 173. I had no idea what was going on. That's me, right? Nope, guess not. Hate this game. Checkers. Yeah, AlphaGo. I'm gonna play AlphaGo. I'm gonna play against AlphaGo. It's the only reason I know what that game is. what? Yeah, I've never played that game, like, ever. That reminds me of one of my favorite animes. Samurai Champloo, I just finished that. It was fire. Yeah, Samurai Champloo was fire. What I have to say about it? Did I like the ending? No, I didn't really like the ending. I didn't like how they both just got beat up. Yeah, I've seen it. Yeah, I don't know how, what's his name's alive. I forget their names, both of them. Oh yeah, because he was, yeah, the characters and the soundtrack were so sick. The characters were so sick. Okay, what's his name? Mugen. I don't know. Yeah, I've seen Cowboy Bebop too. Mugen got beat up by some randoms. It was so stupid. The guy in the wheelchair, like, come on, bro. Like, the whole thing, the whole show, we've seen Mugen just, like, absolutely destroy everyone, and then some guy in a wheelchair and his brothers come along and start, like, beating him up. If he died, I actually would have been so pissed. Because, like, that's a terrible way to die. There's so many times in the show where he could have died and he didn't, and for him to die there would have sucked. But, I mean, it would have been it was pretty cool. Oh, yeah, and Gene was fighting the one dude who was insanely talented. Yeah. Yeah, Gene, he was getting cooked. It was crazy. It was just like, yeah, it was so crazy. Yeah, no, the end of that show was crazy. It was sad. It was sad that it ended. I was like, no, I can't watch anymore. Yeah. He was getting cooked. OD. Yeah, no, that's great. Yeah, Samurai Champloo's fire. Almond Chef. Yeah, Samurai Champloo is pretty good. I have it rated. I don't know if I have. No idea what the password is. What the fuck? Login failed. Be touched. Or people, including me, listen to the. Yeah. No, the music, the Samurai Champloo music was so fire. Yeah. So this is, I've seen every, like, I'm currently watching Monster, Solo Leveling. I'm also watching Legends of the Galactic Heroes, but the dub on Crunchyroll hasn't been. They haven't updated it. I don't know why. It's so stupid. It's like one of the greatest, like, it's actually one of the greatest anime I've ever seen in my entire life. And I'm watching like the bad version. Like this is the new, like they remastered it, so it's not as good, like 5.4.9. But like this show is so good. But the new season is not dubbed. No, this show is so fire. I'm not gonna lie. Commander Yanlin Lee, you're gonna love him. Yanlin Lee and Kirshites. Oh my gosh. I miss watching that show so bad. Bro, it's so stupid. I can't believe the dub's not out. Solo Leveling. I'm waiting for the dub to finish and then I'll finish it. It's not really that good. Monsters Fire, of course. It's really long though. Attack on Titan was so good. Code Geass, Full Metal, Berserk. But I've literally seen every anime. What's my lowest rated? 7 Deadly Sins. oh, these are just unrated. My lowest rated is No Game No Life. That shit was ass. My roommate last year, I went to boarding school for hockey, and this kid watched this. It was maybe the worst thing I've ever seen in my entire life. Bro, Bungo Stray Dogs is supposed to be good, is the problem. And I have it rated as 4. It's just like, I don't know. I didn't like it. It's supposed to be good, too. Maybe I need to finish it. I haven't finished it. Yeah, I gave it up after 3 episodes, too. Dude, it was like, it wasn't serious enough. There was like, everything was a joke. I didn't like it. You're lying, April. I want to eat your pancreas. Those are like the saddest shows I've ever seen. Well, there's a movie, but A Silent Voice, fire. Dotaro, fire. Steins Gate was so fire. Bro, I wish I just could erase my memory and watch all of these again. Everything that's rated a 9 or above. I wish I could just watch these all again. Tokyo Ghoul only seasons 1 and 2 though. Yeah. I wish I could watch those again. They're so fire. What time is it? 4:37. Check out Furion. Oh, I've seen this. Bro, it's rated really high on like on my Annie list. Ranked number 1. Number 1 in what? Wait, it can't be number 1. It's number 1? Wait, what's the rankings on the Annie list? What? It's number 1 on both. How many ratings? 720,000. It was rated by 338,000 users. 332. I think Attack on Titan has the highest amount of ratings. 1 million. Holy shit. Alright, y'all, watch it. Let me see. Let me pull it up on Crunch. They have the dub. Yeah. I'm not gonna lie, it looks ass. Yeah, I can only watch dub, bro. I don't know. I feel like, first of all, I read a lot outside of watching anime. But I can, I don't like sub. Yeah, I like to multitask. I feel like it's a lot harder to multitask if I have to like read the words and watch the show at the same time. Like when I'm watching the dub, like I can go on my phone and I hear what's going on still, and I won't be lost. And there's only one season, so I actually could watch it. Hopefully, it's only one season. I mean, obviously, everyone says it's super good. What? It's adventure drama. Yeah, I mean, everyone says it's insanely good. Fruits Basket. Wait, what was the problem? Why haven't I watched this one? Oh, because it's a comedy. Wait, but this looks good. Is there no dub or something? Oh, because it's a romance. That's why I haven't watched it. Bro, I have Hulu. Oh yeah, I'm definitely not watching this. It's a romance. Yeah, I'm not watching that. I've watched like everything in the top list that's not romance. Well, I haven't watched these. Gintama is just a comedy, so I'm not gonna watch that. My brother watched it. He said it's like Japanese Family Guy. Fruits Basket, it's romance. Not watching that. FMAB was so fire. This is romance. Attack on Titan was so good. Hunter x Hunter was fire. I don't know what either of these are. Giants Gate was fire. Gintama. Bleach is so good. Bleach is so good. I haven't finished it, but Bleach is so good. Of course. I was just talking about this show. It's so good. Season 2? Wait, Season 1 would make sense. I don't know about Season 2 being rated that high. But it was good. Season 1 was better. Season 2 of JJK was so fire. Monsters fire. Silent Voice is fire. One Piece is way too long. It's way too long. Violet Evergarden was fire because the animation. Mob Psycho is good. Yes, Vinland Saga Season 1. AOT. Clan Ad, I've seen a couple episodes of that, but it's, I don't know. Code Geass was so fire. I don't like Demon Slayer that much. Yeah, bro. I'm so excited to watch anime once my finals are over. I'm so excited. It's like the summer I'm just gonna do research and watch anime and my life's gonna be complete. It's fire. Bro, no, even when you're in school, bro, when I was doing Ramadan, I'd wake up at like 6 a.m. every single day to eat breakfast, and by the time it was like 6 p.m. I had absolutely nothing to do because I'd already done all my schoolwork before school started, and then I went to class, and then I was done with everything after class ended, and I watched Solo Leveling, Legends of the Galactic Heroes, which is 4 seasons long. I don't know. I watched a couple other shows in 1 month. Bro, Legend of the Galactic Heroes, I finished in like 3 days. It was like after school, because I would go to bed at like 10 p.m. From 6 to 10 every single day, consistent. I would watch it. Yeah, that's fire. That's fire life. Well, that's sick that your girlfriend likes anime. Yes, I've watched Chainsaw Man. It's pretty. I think it's actually low on my list. Or maybe I don't have it rated. Oh, I don't have it rated. I would probably rate it like a 7. It was solid. It was. Wait, no, Chainsaw Man was actually kind of fire, but yeah, it was kind of fire, so it was 7. Yeah, it was pretty fire. I watched it in literally a day. The animation was so fire. I literally watched it in a day. I remember when it like came out. But yeah, I think there's only one season out for dub or for anime. So whenever season 2 comes out, I guess I'll watch it too. Yeah, I don't know. I didn't think the storyline was insane. It looked pretty good though. Yeah. Oh crap. No, like ever. 100%. Yeah, 100%. Bro, the Attack on Titan, bro. Oh my gosh. It's like bro, Attack on Titan, like you could study at AOT. You could also study Jujutsu Kaisen. It's like they make it like really complicated. AOT is complicated because like there's so much time. Like it's 4 seasons. It goes over like things like 6 years. JJK is just like really, really complicated, like the science and stuff. But like AOT's storyline and plot is just unmatched. Oh my gosh, I could think about it for like years. That's nuts. I started it in 2022, and I finished it. I finished the whole thing in about a week. I watched it again in 2023. I watched it 3 times in 2023. I think I watched it 3 times in 2023, and then waited like 2 years for each of the episodes to come out. A 3-year wait? Okay, but I feel like season 1, I remember seeing it on like Adult Swim when I was a kid. But when I watched, like, because I watched it when I was a kid on Adult Swim, I saw it and I was like, this is low-key weird. So like I feel like if it came out and I just watched season 1, I would think it was weird. Yeah, it was. It just got in every... Remember, season 1 was good, though, actually. It was, what, like 4 episodes in is when Eren becomes a Titan, right? 3 episodes in is when Eren becomes a Titan. Right? Am I tweaking? Okay. Oh, I am tweaking. Eren becomes a Titan 13 episodes in. So crazy. Annie. Bro, when Bertold, oh my gosh. When Bertold and Reina, when we found out that they were Titans, that was insanity. I freaked out. Like, I started screaming at the TV. Oh my gosh, this is so good. It's such a good show. I could watch it like again. Season 3 was the most insane, like mind-bending. No, season 4 was. To You 2,000 years ago or whatever. That episode was insane. From You 2,000 years ago. Oh my gosh. Bro, hell no, I'm not watching it in sub. No, dub is fire, dude. I've heard the sub. It sounds different, but dub is still fire. I like Eren's voice. The only person is like Armin. Armin's voice is a little annoying. But But he's supposed to sound annoying, like it builds his character. Oh, I hate, what's his name? Wait, just say his name. The nigga that slobs Aaron in the final season. Flock. I hate Flock so much. And Gabby, at the beginning, Gabby pissed me off so bad. When she shot Aaron, like shot Aaron's head off, I almost freaked out. Because I thought he was like actually gonna die, which would have been some bullshit. I actually would have freaked out. My whole life would have been over. If Aaron died like that, that'd be bullshit. I want to rewatch the episodes. Where are they? I need to rewatch the new episodes. I don't know where they are. Yeah. Bro, I'm so glad Levi like healed. I thought he was gonna be crippled, which would have like actually sucked because Levi's so raw. Dude, I'm thinking of getting a cat for next year. I'm gonna name it Levi because Levi's so raw. Is that glazing? Is that glazing? Yeah, he's so raw. I couldn't name my cat Aaron, but that's actually glazing. Yeah, but of course it's appropriate. I mean, if you've seen the show, then you know, glazing Levi. Of course you are. Of course you're glazing Levi. Have you even seen the show? The OADs, when it goes in like Levi's backstory, were so raw. No, I haven't watched One Piece. I have like One Piece stigma because it's so long. I think it's like, oh wait, I think it's, no, I didn't mean to do that, but, oh, that's still the wrong move anyways. Yeah, right, exactly. Bro, it's 1,000 episodes and they're still releasing episodes to this day? Hello? How is that even possible? Just stop. They need to stop. If they ended, then I would watch it. But it's not ended, and it seems like they don't have any plan of ending it soon, so I don't know where they think I'm gonna have infinite time to watch 1,000 episodes of anime. Yeah, I heard One Piece stuff is good. No, I heard One Piece is really good. Everyone who watches it like slobs One Piece. They're like, well, One Piece is the best anime I've ever seen. So I imagine, okay, I'm like done. I'm just losing. I imagine it's pretty good, but I just never gotten into it. It's too late. Yeah. I mean, how many episodes are there? Yeah, 1,100 episodes. Are you high? Bro, I thought Naruto was insane. Like, once I get to Naruto Shippuden, like, season 4, I stopped watching the filler. I just skipped all of the filler and only watched canon, and it still was hella long. And I thought Naruto was pretty good. Well, I was like, because, like, today, I would never even think about rewatching Naruto. Wouldn't even think about it, like, not even for a split second. It's way too long. It's 18 seasons long. And One Piece is like 4 times longer than that. So I couldn't even imagine. Like, I don't know how you could watch that. It's like if you watch...
Speaker.
What?
Do you have the speaker?
Why are you whispering?
I don't know, interrupt.
I actually can't hear you.
You have the speaker that was in the bathroom?
No. Tyler has it. I just snitched low-key. Yeah, I don't got that free time, bro. Yeah, Naruto was long, and... yeah, Naruto's only 720 episodes. Bro, 367 hours? Hello, what? If you watch it for 2 times, if you watch it on 10 times speed for 1 entire week straight, you won't finish. I don't think that's true, but no, I think it's longer than that even. 438 hours. Yeah, because some of the episodes are like 24 minutes long. 438.8 hours. 438 hours. It's like how many hours I have on Fortnite. Wait, how many hours do I actually have on Fortnite? How many days is 438 hours? 18 days. Oh wait, I have way more hours on Fortnite than that. What am I talking about? Yeah, no, that's crazy. It's still hella hours. Wait, how many hours do I have on Fortnite? Now I'm actually curious. I think I gotta go to like Xbox. Ten years on League of Legends is crazy.
No, give me your stream taken down.
Why?
Just kidding. She's down bad.
She's not down bad, but that was never my girlfriend, so it's fine.
Oh, I can't find it. Whatever, sorry. I'll
Oh yeah, sorry. No. Thank you for apologizing. But why can't I see how many hours Xbox is tweaking? I want to see how many hours I have. See if I actually have time to watch Attack or One Piece. But what is going on? Is it my Wi-Fi or something? No, it's not my Wi-Fi. I'm at 10 kilobytes. Wait, I should do a Wi-Fi test. I thought Google had a built-in one now. Not long ago. Fortnite. Fortnite is 100% my highest. Oh, minutes played. 147,000 minutes. I don't know why they do it in minutes. 2,000 hours. I could watch One Piece. I watched One Piece. How many times? 6 times. I watched One Piece 6 times. That's so nuts. I'm not even ranked 39th out of my friends. People have like a billion hours. Dude, Cam has like a billion hours. But Xbox app sucks, so how many days is that? Yeah, 102 days. Cam has like, bro, he's like 300 hours on, or 300 days on Fortnite and 2K. Okay, I don't know where 2K is. Why can't I see it? Compare. Yeah, I guess you can't see. Whatever. Yeah. So nuts. I enjoyed every last second playing Fortnite, so I don't even care. Alright, let me do this practice final. I gotta lock in. I gotta get every question right first try. I need to go to the bathroom first. No, I don't. I don't play Fortnite anymore. I used to though 5 years ago. I stopped playing like 4 months ago. Mm-hmm. Yeah, I stopped playing like 4 months ago. I just didn't have any time. But yeah, I used to play Fortnite. I was ass in those videos. I'm really good now, but unfortunately, I don't play anymore. Alright, bet. Let me lock in.
Aiden.
What's up?
Aiden.
I said, what's up?
Jonah just said, when we doing our formal goodbyes?
Okay, wait. I actually do need to fill up my water bottle though. What?
He's like, when we do our formal goodbyes?
Dude, we did our goodbyes at Olive Garden yesterday. Alright, let me lock in. It's 5:21. I have until 8:21 to finish this exam. Should I do no headphones either? Should I actually lock in? Pretend like it's a real exam, and I'm gonna turn off chat then. Alright. Let's fire. We'll lock in together. Let me pin this.
Are they mean like so people?
Alright, close OBS. Okay, OBS is closed. Let me see if the stream's still chilling. Yeah, stream's still chilling. Okay. Alright. Gotta lock in. Okay, then I'm gonna close my door. I need to check something. Lock in before I tweak out. Ow! That hurt really badly. Ow, that hurt. Hits the ground again. We also know that it travels a horizontal distance of 56 meters. VIXT. So VIX equals 56 over 4. Equals 16. 14. What am I doing? Why did I say 16? 14. Okay. The y component. Okay, so we know that t equals 2. It's at its max height. Okay, so we know that 0, its final, so look, final velocity y equals velocity at initial y minus 9.81 t, right? We know the final velocity at the height is going to be 0. VIY is going to be unknown, and it's going to be 9.81 times 2. So VIY equals 9.81 times 2, which is 19.62. Okay, continue. An entrepreneur pencils. Okay. Eight meters per second. Oh, with respect to the passengers. Oh, what? What? Yeah, the ferry. Hungry passenger. Oh, train on the ferry with a hamburger on it. Okay. It's 4 meters per second. Assume that the toy train carrying the hamburgers travels 4 meters per second with respect to the ferry. Well, it's technically negative 4 meters per second, but the speed is going to be 4. Of the plate of hamburgers with respect to the passenger is 4. What is the speed of the plate of hamburgers with respect to a stationary observer on land? This one's 8. I mean 4 meters per second that way. The boat's moving at a total of 12, so it's 8. Yeah. Okay. A mass m equals 3.2 kilograms hangs motionless. Okay. The springs are identical. Yeah. Both are 60 degrees. How much is each spring stretched from its equilibrium length? Okay, so look. We have 3.2 times. Okay, let's draw the free body diagram of the block, right? Okay, wait, let's make this a little bit. Okay, dude, what's going on? Okay, the block weighs 3.2 kilograms. We're pulling up on this side, pulling up on this side, pulling to the left, and pulling to the left. And then this is mg. This is mg. Right. This is gonna be F of the spring sine theta, and so is this. This is Fs sine theta. This is Fs cos theta, and this is Fs cos theta. Net force equals they're both 0. Springs with spring constant K equals 507. Okay. It's sine, right? Yeah, sine. How much is each spring stretched? Okay, so 2fs sine theta equals mg. Okay, mg is 3.2 times 9.81. That divided by sine of 60 equals 36. So we get fs equals, divided by 2 equals 18 newtons. F of each spring equals 18 newtons. So then we get 18 equals kx. Yeah, k delta x equals k times delta x. The spring constant is 507, so 18 divided by 507. Kx is 0.03, or delta x is 0.03. 0.0355. Yeah. What? What?
I want to give you something.
No, I'm doing an exam.
Well, I'm not joking, but like when you're done, I'll give you something. It's not a joke.
Okay. Okay, the angle was changed. So we're gonna do the same calculation, but the angle is now 45, and then now we divide that by 2, and then now we divide that by 507. And we get 0.04. Okay, we get 0.04 is the new stretched length, which is larger. Be more than before. Stretch more than before. Delta x is larger. Yeah, so the discrepancy is larger. Satellite A, okay. I know how to do this one. Satellite A has mass MA, so wait, let's see. Okay. 1517, it moves in a circular orbit of radius around the planet. The mass of the planet is universal gravitation. The speed of the orbit is VA. Okay. How much time does it take the satellite to make one complete orbit around the planet? Minutes? Why is it in minutes? Okay. So we gotta use this equation. So I assume this force is like, so we have a planet, a satellite around a planet. So let's just draw the planet here. Here's our planet, here's our little satellite. It goes around. Okay. It goes around. And it's being pulled here with the force F. I think. Wait, how does it not just get pulled? I mean, it obviously has an acceleration, so like it will have an acceleration perpendicular. As it goes around, right? Okay, let's just solve for F12. I think that's like what I'm supposed to use. So F sub 12 equals negative G M1 M2 over r squared. Okay, there's a couple things here that I think might be an issue. Okay. So we do negative 6.67 times 10 to the negative 11th times m1 1517 times m2 5.2 times 10 to the 24th over r squared. 10.4 times 10. 10.4 times 10 to the 6 squared. Yeah, so that's our force. If we divide that by the mass, we can get acceleration equals 3.2. And A equals v squared over r equals, what is r? It's the only r they give us, so I'm just going to do times 10 to the 6th and the square root of that. Okay, so we get v equals 5774.95. Okay. So that's its velocity. VA. How long does it take to complete one complete orbit? To make one complete orbit. Yikes. Okay, is there like a universal gravitation section? Oh yeah. Okay, this question's out of nowhere, dude. Out of left field. I don't. Okay. Apparently we've done universal gravitation. How long does it take the satellite to make one complete orbit? So you have the velocity, which is what, meters per second. This should be meters squared per second. What do we divide that by? T. Okay, wait, we get like VF equals V naught T. So, wait, no. Distance equals V naught T. So time equals distance over velocity. Okay, so I'm just gonna do the radius divided by. Bro, I don't think this is correct. 10.4 times 10 to the 6 divided by this. Yeah, 18. No. Yeah, I have absolutely no idea how to solve this question. We'll come back to this. I don't know how to do universal gravitation, bro. I'm not gonna lie. It's like I zoned out in that section. Did we? I don't know. We didn't even like have that section, bro. I don't know. Whatever. Let's move on. A vehicle with mass is traveling at a speed 37 meters per second. But this is all the first unit, so I guess it's like in order. It's kind of stupid. I thought I was gonna have to like figure out which one was which, but these are all season 1 questions. Okay. So force of friction equals N mu, okay, equals 1100 times 9.81 times 0.32. $3453.12. Okay. So we know that that's its force. That's the only force acting on the car, and F equals MA equals 3453.12. So that divided by 1100. A equals 3.1392 meters squared per second. Negative. Okay, so she's slowing down at a rate of 3 meters per second. She wants to get to 0. Her initial velocity is 37, and her acceleration is 3.13. So 37 divided by that. T equals 11.78 seconds. We want to find the distance that she traveled. X equals, she starts at position 0 plus 37 T V naught T. Okay, whatever. That's the equation minus half 3.13 T squared. That's the equation, bro. I don't know what to tell you. R equals R naught plus V naught T plus AT squared over 2. Yeah, I don't know why there's a time on your 37 times answer minus 1/2 times 3.13 times this squared equals 218. We got X equals 218.049. Okay. This is 50 questions. So mass M equals 2.1 kilograms. For a while, I was like not paying attention, but I still should be able to answer all these questions. Which of the following just describes the net force acting on the upper box? Okay. Before we answer any questions, free body diagrams of everything. M1 is 2.1 kilograms. M2 is 5.1 kilograms. The kinetic coefficient of friction. What is the statement of the best? Okay, so this is mg. This is Fn. We'll just say Fn. This is going to be Fn, and this is going to be mg plus mg. This is going to be, neither of them are moving in the y direction, so they're going to be equal. To the right is moving a box of mass m equals 2 is being pulled by a horizontal. Okay, so the only M1 is being pulled. M1 is being pulled by T, which we do not know. Okay, there's friction on the top box. So this is the force of friction. So then this will be applying the force of friction and be accelerating. Yeah. How can this make any sense? Oh, because the lower block has a lower acceleration. Wait, but the net force on the upper box, like it's 0. Oh, assume that the upper box is moving faster than the lower box. Is being pulled by a horizontal string with tension T, so it moves with a constant velocity across the top of a second box. The kinetic coefficient of friction between the upper box and lower box. There's no friction between the lower box and the horizontal floor. And the lower box accelerates to the left. Oh, the lower box accelerates to the left. Assume that the upper box is moving faster than the lower box. Okay, the upper box is going to have 0. Because it says the upper box is not accelerating. Because it's like F equals MA and A equals 0. So F by contrast also equals 0. Thank God that was right. Which of the following statements best describes the force of friction acting on the lower box? It points to the left. Because it has to have acceleration to the left. Because it says there's no friction between the box. And the lower box accelerates to the left. Meaning that there has to be a force to the left and there's no other force acting on the block in the horizontal direction besides for friction. What is the magnitude of the acceleration of the lower box? I don't understand how we're supposed to solve this. So we can calculate the forces. Okay, so we know the force of friction equals T equals mu K times 2.1 times 9.81, which is going to be 2.1 times 9.81 times 0.6 equals 12.36. Because net force in the horizontal direction has to be 0 on that one. So 12.36 is the force of friction, and F equals MA. So 12.36 equals 5.1 A. So A equals 12.36 divided by 5.1. A equals 2.42. Dude, we're still on chapter 1. Chapter 1, season 1. A box of mass M equals 3 kilograms. Can we go this way? Box of mass M equals 3 kilograms. Initially held at rest near the top of a frictionless ramp that makes an angle of say at 20 degrees. Accelerates down the ramp. The total work done by all forces on the block as it moves a distance d down the ramp is... Fuck you. Looks to make a positive distance. I mean, the y component of it would be negative, right? But the x component, the total work done by all forces. Okay, so first of all, let's draw the free body diagram. Because that's all season 1 was about. We're just drawing free body diagrams. We have a 3 kilogram box. It's being pulled down by, straight down by mg cosine theta. It's being pulled to the right by mg sine theta. And it's being pulled up by Fn. and it is not being pulled to the left because it's a frictionless ramp. And we can prove this by drawing the triangle, however terrible it may be. That's mg, this is theta, meaning geometry, this is theta, this is mg cos, and this is sine. No force that way. And we're accelerating. Mg sine theta equals ma, just for the record. The acceleration equals, it doesn't ask for that, but it's fine. Oh, we don't need it. This isn't kinematics. This is, well, I guess it still is, but work and kinetic energy. The total work done by all forces as it moves down a distance d on the ramp. Thing is, this is a little tricky because we have x and y components. So the work done in the x direction is positive, right? It just equals mg sine theta times d. Equals mg sine theta times d equals positive. The work in the y direction is mg cosine theta times h. But I mean, relative to the surface, I mean, I think it's positive. Well, regardless, sine 20 is larger than cosine 20, right? Oh no, cosine 20 is larger. Fuck. Okay, look, if I set my axis like this, and this is the plus x direction, this is the plus y direction, then that is oh, mg cosine theta doesn't provide a work. Well, a network, right? Because wy equals fn minus mg cosine equals 0. This is not accelerating the y direction relative to the box. So it's positive. Yeah. After the box has moved distance 1.1 meters down the ramp from its starting point, what is its speed? Okay, so this wants us to use kinetic energy. So we know that mg sine theta times 1.1, we'll just do d, equals half mv squared, the final velocity, because it starts at rest, only the final velocity, half mvf squared. Right, and that's what we're trying to find, what's its final velocity. Okay, so we know all these numbers. We have 3 times 9.81 sine of 20 times d, which is 1.1. Okay, and then we multiply that by 2, divided by the mass, and then square root it. And we get 2.718. We get VF equals 2.7168 meters squared per second. 2.72. Now suppose that there's friction between the box and the ramp, but the box still accelerates down the ramp. The kinetic coefficient of friction is mu k as the box moves distance d down the ramp. Total work done by friction is going to be, so we're going to have work x equals mg sine theta d minus mu k cosine oh, mg cosine theta times d. Negative mg cosine theta. Wait, how are we doing universal gravitation again? But this is dealing with energy, which is easy for me to figure out. What is the speed of rock Vf when it has fallen to a distance d of 4 above the surface of the Earth? This is great. I just did a question very, I knew it was going to be like that. So, just go to the top and work across, right? Okay. So we have the Earth right here. We have is there any preliminary? No, or not. Okay, so at a distance d, here's the mass at a distance d, has a mass of what? It doesn't tell you the mass of the thing. Okay, so here's its mass. It's irrelevant because we're using energy, of course. It all cancels out. This is a distance d away. We don't need to draw it. And then at a distance d over 4, it doesn't matter. What is the speed of rock when it has fallen to a distance d over 4? So we need to do total energy equals 0. Wow, crazy, right? Total energy equals UF minus UI plus KF minus KI equals or actually we can just kind of KI equals 0. KI equals 0. Starts with 0 kinetic energy from rest, of course. So let's solve for UF equals at a distance d over 4. So let's calculate what d over 4 is. D over 4 is 3 times 10 to the 7th. Oh, that's it. Over 4. So that's what d is. So UF equals negative G M big M over d by 4 plus radius of the Earth equals negative 6.67 times 10 to the negative 11th times 5.97 times 10 to the 24th. Oh, okay, wait. I gotta set up the equation and cancel all the masses. Why did I just turn my calculator off? I gotta set up all my equations. No, wait, let me click. Okay, I need to set up all my equations. We can't solve individually. We can't. So we're gonna do that. Minus plus G M over D plus R plus kinetic final kinetic energy is going to be half. Oh, we can just say this. Oh, we have to rewrite this. So UF minus UI plus KF equals 0. So we get KF equals negative UF plus UI. So this is actually going to be a minus. And this is going to be positive. Equals half mvf squared. Exactly. Okay. And this is a little m, right? So this cancels on all fronts. So we have G big M over D by 4 plus R minus G big M over D plus R equals 6.67 times 10 to the negative 11th times mass of the Earth 5.97 times 10 to the 24th over D by 4, which is this number here, D by 4 plus R 6.38 times 10 to the 6th. And that is minus 6.67 times 10 to the negative 11th times big M 5.97 times 10 to the 24th over D plus R 3 times 10 to the 7th plus 6.38 times 10 to the 6th. Our difference is 1.7 times 10 to the 7th. It's a little bit more accurate than that. So we do times 2, and then we root that. We get 5957.04. The fact that my answer is even here is a great sign. The fact that my answer is correct is another great sign. Planet Hondo has the same radius as the Earth, but has a smaller mass. Suppose the same rock were released from the same height d above Hondo. How would the speed of the rock, a distance d4 above the surface, compared to the speed back then? Okay, so the only thing is has a smaller mass. So let's just do the same thing, except instead of 10 to the 24, we do 10 to the 2. 10 squared. Instead of 10 to the 24, we do 10 squared. Same radius, times 2, square root. We get a teeny weeny number, I think. It's too small. I can't do 10 squared. 10 to the 20th. We'll just do by times 2 root 59. Velocity now is 59, so the velocity will be smaller. Because we get VF equals root 2 times GM over D by 4 plus R minus GM over D plus R. The larger M is, this is larger, this is a larger number, no matter what. This is a larger number, it has a smaller denominator. So any increase we make to this number will cause an increase in, decrease, will cause a decrease overall, holistically. So it would be smaller. Oh shit. This fucking one again. Okay. I kind of remember how to do this. Not really. There's fucking, oh my gosh. Newlywed to Allie. I don't know why they... Oh, newlyweds. Fucking piece of shit. Okay, so think. Try to remember how the hell you do this question. Okay, so let's just think about what's happening here. The thing is, we're not going to know the force. What type of problem is this? This is a center of mass problem. I fucking remember doing this, bro. Okay. Okay, so we know VCM initial is going to equal VCM final. Position XCM. We know that at the beginning we have 58.2 times 5.5 over 2, right? M1 minus 77.6 times 5.5 over 2. And this is incorrect. This is a plus and this is a minus. Okay. Now we know that the denominator is just going to be 58.2 plus 77.6. Because Allie is on the negative side, right? They said that in the question. 58.2 times 5.5 over 2 plus 77.6 times 5.5 over 2 is in the positive direction. We have 58.2 plus 77.6. So we get this equals 0.392857. And that's not going to be the answer. But look, we get XCM equals the same thing, but their positions are going to be different. So we'll have to know the entire system will have to move to compensate. So they're going to be wait, I'm confused because isn't it just going to be 0? Same thing. Fuck, okay. Let's think. Oh. It has a mass of 15.9 kilograms. Oh, look. Look. I got it. 58.2 plus 77.6 plus 15.9, and the numerator is going to be the new position times all of these, because they're all going to be at the same place. They're all going to be in the middle of the... They're all going to be in the middle. Oh, but that's just one. Oh, no, it's not. No, it's not. They're all going to be in the middle. But that is 1 there. It's just x times 1. Okay, there's a problem with this. It's conservation of center of mass. Maybe it's just 15.9x. No, that wouldn't make any sense. Or maybe it would. Let's do 15.9 over 8.2 plus 77.6. That's definitely not. Can this get off my screen, please? That's definitely not the answer. Yeah, no. Okay. Wait, I have to think about this. So... Oh, wait, I remember how to do it. I remember how to do it. You have to draw it. Okay, wait, let me restart. Hello, chat? So this is our person originally. This is our second person originally. This is the center of mass. And then now, it's gonna end up being like somewhere like, who weighs more? Him, 77. So it's gonna be somewhere like here. And so this is M now. This is gonna equal D. And this is where the people are. Okay, it's something with the free body diagrams. Something about the free body diagrams. Not free body diagrams, but like this drawing. Oh, my shit disconnected. Oh. What happened? Can he unplug his router or something? No. What is this? That's pretty sad. Oh. So somehow I'm supposed to use Why won't it connect to Wi-Fi? I want to click this help button so bad. I'm coming back to it. It is definitely not, it makes no sense. They have the same. It's like not even possible. Look, you guys can't see my screen. Can't see what I'm doing. Bro, come on, Wi-Fi. Well, I guess I can still work. Okay, so we have v naught squared. Somehow, for this to be elastic, would have to equal half little m v naught over 2 squared plus half big M v naught over 2 squared. Do we know the weights? Let's do conservation of momentum. mv naught equals That's so stupid. Oh, welcome home. What? Bro, what? I did conservation momentum. It's 2 over 2 plus 1 over 2. What? Oh! I'm fucking times 2. Bro, that's bullshit. Okay, well, I had it wrong, but, I have the answer right here. Fucking idiot. Okay. Alright, imagine V0 is 1. We have half. Imagine, V is 1 and M is 1. Half times 1 times 1 over 2. 1 over 4 plus 1/2 times 3 times 1/4 equals 1/2. Oh, this is saying kinetic energy is conserved. How is this possible? Wait, why am I actually getting this equals 1? We get 1/2 times 1 times 1/2 squared plus 1/2 times 3 times 1 over 2 squared. 1/2 times 1 times 1. What the fuck? I'm getting momentum is conserved. Oh, but that's after knowing the masses. Wait, I figured that out using the masses. Yeah, if we don't know the masses, it's kind of useless. How? It's fucking bullshit. Fuck that question. Can I skip Wi-Fi, please? Gosh damn it. Question pissed me off. Let's continue. Dude, I got the second part right. I got 3M right. I don't care what you said. I got it right. I didn't look at my thing. An exam. Okay, I'm marking it right because I got it right. Okay. That's it. The first part, I did actually get that wrong. I don't know how we were supposed to determine it without knowing the masses. I determined it, but I knew the masses. It's kind of bullshit. Oh, velocity of center mass is conserved, right? Okay. V1I times M1 plus V2I times M2. I had 2.38 is the velocity of the center of mass. To the right. Before the collision. Oh, and after the collision. It's the same thing. Let me make sure that my signs are both correct. MV plus MV. 2 times 3.4 plus 3 times 1.7 over 2 plus 3. If I got that wrong, I'm so pissed. Okay. As measured by someone in the center of mass reference frame, in what direction is M2 moving before the collision? Okay, so if you're in the center of mass reference frame, your velocity is 2.38. And M2 is moving at 1.7 seconds. So it would be negative. It would be negative. You would be moving faster than M2. You'd be moving faster than M2. So it would be negative in the negative x direction. At the instant during the collision when the compression of the spring is maximum, both blocks move with the same velocity as the center of mass VCM. At this instant, which of the following correctly expresses the potential energy stored in the spring? What? At an instant during the collision when the compression of the spring is maximum, both blocks move with the same velocity as the center of mass. At this instant, which of the following correctly expresses the potential energy of the spring? Potential energy of the spring. So relative to the center of mass, they're 0. Velocity is 0 relative to the center of mass. What the fuck is it talking about? Potential energy of the spring is a half kx squared. Okay. No, we gotta relate it to the... Bro, what is going on with the Wi-Fi, bro? Let's try to connect to 5G Presley Hall. Error. Bro, this is fucking bullshit. I'm in the middle of my exam. Why you gotta do this to me? Okay, at the instant during the collision, potential energy is gonna be, there's gonna be a minus sign. Is this one? M1 V1 squared minus M2 V2 squared. It's gonna be minus, dude. Or it might be this one. They should be equal. Okay. So, wait, let me think about this. The initial kinetic energy of this. Yeah, it's gonna be minus. Has to be. We're in the same direction. It can't be plus, it would be if they were going in opposite directions. And potential energy is going to be more if they're colliding head on than if they're colliding like that. Like this. Wait, no. Like this. Potential energy is going to be way less And if they're colliding like this, they come in with hella kinetic energy, and it adds the two kinetic energies in opposite directions, adds together, and they bounce the other way. Oh, but it's completely elastic, so it's gonna be the same. Oh, but the potential energy in the spring is just gonna be VI, I think. Yeah, VI minus V2I. Ooh. Alright, this one. Or this one. Those are crazy, dude. There's no way. No, connect to... Fucking forget this shit, bro. I think it's this one. On my exam, I'd mark it and come back to it. There's this one too, though, but I think it's this one. Aren't they gonna be equal, bro? I should just do it. Let's just figure it out. Half m plus m 2 plus 3 times 2.38 squared. Nope.
Oh my god.
Aiden! Drew! Okay.
Oh, yeah, that's right. Half times 3. Oh no, this is last. Yeah, so it is the last one. Fucking gosh. How is it that one?
Bob! You just need Bob!
Oh my god, it smells so good.
That's so pretty.
Oh.
Oh, I can't do that. I like so much. There's so much. Ah, let me in. Ow! Let me in. He's gone. Let me in, bro. He's gone. Let me in. Yes, he is. How did you get in?
Oh, constant torque.
Let me in, bro. He's spraying it under the door.
Oh my gosh, I'm cooked. Am I connected?
Yeah.
So stupid.
No. He's covered with a towel. Like fuck. I can't put any more on. I lost interest. The joke. Who you talk? Oh, I thought I was like out there.
Okay, torque equals I alpha. I think that's what I should be using.
Oh, yeah, no problem.
So the moment of inertia, solid cylinder, half mr squared.
Stop. Get in.
Bro! Big Thomas, open the door!
Bro, can this kid not yell or laugh so fucking loudly? Okay, bro, we get it. Connection failed. Got it.
Go bomb! Go bomb!
Did you swing it? No. Get the fuck out.
Go bomb!
So we know what alpha is this. Oops. So we know that theta equals 0 plus 0 plus half 44 times 4.7.
Yeah! That's what you get! That's what you get!
What the fuck's that bullshit?
It's fine, it's fine, it's fine. It's okay. We already did it on my side. We already did it on my side. I'm on it!
Good, thank you. Good, Thomas.
Oh, and I
Keep
need
going,
rotation.
keep going, keep going. Keep going, keep going, keep going.
I'm like, whoa!
Keep going. Keep going.
Wait, no, this divided by 2 pi. This divided by 2 pi. Oh, both of these are wrong.
Oh, stop.
I get 750. I did theta divided by 2 pi. Oh, sweet. Suppose the answer to the above problem is n. If the same cylinder is restarted from rest and the magnitude of the applied torque is double, how many turns would the cylinder make in half the time? Piece of shit. Why do you ask these specific ass questions? Okay, let's do this. So torque is going to be equal to half. So we still have a moment of inertia. Same moment of inertia, right? Wait, is that the moment of inertia? No, that's not the moment of inertia. This is the moment of inertia. 2.4 times 0.343 squared. Okay, so we have the same moment of inertia. Torque divided by it. Half the torque, it said? The torque is doubled. Torque is doubled, so 9.763 times 2 divided by this. Okay, angular acceleration equals, new angular acceleration equals 88. Theta equals 0 plus half alpha times, the time is half, 14.7 divided by 2. 7.35 squared. Okay. Half times alpha times 7.35 squared. And then this divided by two. The new one equals the old one divided by 2. The new one equals the old one divided by 2. I might be like wrong just because my brain isn't working. I'm pretty sure like the old one divided by the new one equals 2. So that means that the old one times 2 equals, oh no, the new one times 2 equals the old one. So 378 equals 757 over 2. And 757 was the original one. Yeah, submit n over 2. Exactly. Correct. Okay. Oh, right, because there's new questions. Fuck, I forgot about those ones.
Yeah, I'm gonna take it right now.
of the what are they talking about? The left end of the rod. Okay, the moment of inertia around the left end of the rod is 1/12 mr squared. Hold on, let me. End of the rod is 1/12, right? Oh, it's 1/3. Look at me. I'm a bot. Okay, so I total equals 1/3 ml squared plus. Wait, ml squared or ml over 2 squared? No, it's ml squared. The sphere is gonna be is a solid sphere. Solid sphere. It's 2/5 mr squared, right? Yeah. Plus in parentheses 2/5 mr squared plus md squared. Ml squared because it's at the end of that. It's at the end of the rod. Ml squared. Bro, I don't know why my freeform keeps quitting. I don't know why the Wi-Fi won't connect. My life is terrible. My life sucks. What's ml squared? 1/3 ml squared. So it's one of these two. It's not the last one. It's not this one. It's not this one. 1/3 ml squared plus m times l squared plus 2/5 r squared. L plus r squared. The fuck is L plus r? Oh, L plus r. It is L plus r. Plus 2/5 r squared. Wait, it is L plus r. Yeah, it's L plus r. Suppose the answers of Rn if the orientation of the axis were kept the same but moved to the right so that it passed through the center of mass of the system, how would the new moment of inertia compare to the old one? Okay, the old one would be this. The new one would be the exact same thing, right? But the center of mass of the system would be like here. So, oh, they would both have parallel axis theorem now. Oh my gosh, we actually have to calculate this, dude? Okay, well, the position of the center of mass of the system is going to be, okay. Well, we're not going to know the position of the center of mass, actually. It's going to be here, though. So, we're going to have to use parallel axis theorem for both of them, right? We're going to have to use a parallel axis theorem for both of them. Well, we can just assume it's here. So we're going to get 1/3 plus 1/3 ml squared plus r squared plus 2/5 ml squared. So it's going to be less than. The CM is going to be less. Yeah.
You're going home Monday. You're going home tomorrow, Tyler, right? Drew, is your physics fine by 8 a.m.?
Bro, I was zoned out. If the box is hung directly under the left rope, how would TL compare to DR? what is the value of D, for which TL equals that? So let's choose TR as our axis of rotation. So we have net torque equals 0. TL times 2L over 4 L over 2 minus M L over 2 minus M times L over 4, or 3L over 4 minus D. 3L over 4 minus D.
Why would I be leaving today? Physics finals on Tuesday.
Okay, there we go. So now we substitute TL. We get 3/4 mg minus ml over 2 minus m 3l over 4 minus d. Okay, we can solve most of this. 3/4 times m times g, 4.3. Wait, mg. Why is mg? Oh, that's what it tells us. 9.81 times L over 2. Almost forgot about L over 2. 5.1 over 2. Minus M L over 2. Wait, L over 2? Oh yeah, L over 2. Minus M L over 4. M L over 4. Minus M 4.3 times L over 4, 5.1 over 4 equals 75.19 equals M, was M 4.3 times 3L over 4 minus D. So divided by 4.3, and then subtract 3 times 5.1 over 4. 13.6. You fucking piece of shit. I have to look at my distances again, right? So TL from TR is going to be L over 2. We have L over 4 plus L over 4 is 2L over 2. The center of mass, oh, mg. I'm forgetting the g's on both of these. I forgot the g's on both of them. Times 9.81 divided by 4.3 divided by 9.81 minus 3 times 5.1 over 4. 3.18. 3.18. If the box is hung at the right end of the beam, i.e. D equals L, what is the value of TR? Okay, so now we change our rotational axis to be around TL. Equals, where is it? The box is hung at D equals L, right here at the right end. Yeah, okay. So the box is held directly into the right end. We'll go right to left. Actually, we'll go left to right. So we're gonna have mg L over 4 L over 4 minus TR L over 2. Oh no. Negative mg plus TR. Wait, no. Mg is negative. Mg is down. Down around the left axis is going to be... Oh no, that's clockwise. So it's negative. PR is going to be positive counterclockwise. And M is going to be negative again. And we get mg 3L over 4. Right, 3L over 4. 2 L over 2, L over 2, L over 4, or L over 4, L over 4, L over 4. Yeah. And now we can solve for TR. Minus T. No, we'll just plus both. mg L over 4 plus mg 3L over 4 equals TR L over 2. So we just do L. mg is 4.3 times 9.81 times L over 4, 5.1 over 4 plus 4.3 times 9.81 times 3 times 5.1 over 4. And then multiply that by 2 and divide it by 5.1. And we get 84.36. I'm close to done, bro. Okay. With a horizontal rod of length L and mass MR equals 1.8 kilograms is used to sign. Is used to hang a sign on a wall. The right end of the rod is attached to the wall by a hinge. A wire having tension T runs from the center of the rod to a place on the wall. Distance each above the hinge as shown. Dude, I hate how I don't have my iPad on my screen right now. It's pissing. It's like it's giving me the heebie-jeebies. I'll just turn on my phone's hotspot. Although I don't know if my phone's hotspot will be able to. I don't know if my phone's hotspot will be able to establish a server. Okay, I'm connected. They're both connected. It says error. Yeah, it's not gonna work because obviously. It's fucking stupid. Yeah, but this just uses Wi-Fi. Fucking stupid, bro. Connected. Let's fucking go, dude. What? Why does it say error? You fucking high? What does it mean, error? I don't understand. Mm-mm. Bro, I need to stop copy and pasting. Oh, I should have installed it using Nala. Whatever. Bro, I don't fucking know. Oh, UX plan. Here. We need to kill this one. -6. Okay. Sudo kill -6. Sudo kill -6. Base 10 5 0 0 9 1. Okay, what if I delete the 10? Piece of shit. I don't like. How do I? Why'd they say 10? How'd they know 10? How'd they know to do 10? You explain a bunch. But we want to kill the TCP. Okay, what if I do this number? Oh. Now if I run the UX play. I hate you. Oh. I just need to restart my terminal. LFG, LFG, LFG. Okay. Now let's log back in, bro. Before I start tweaking. Before I start fucking tweaking, gang. Okay, let me chill. Alright, well, hold on the rod. Okay, what is the tension in the wire that runs between the wall and the rod? Nice. Okay. So let's draw this now that we actually have iPad. Okay. I mean, I know the iPad's ungodly slow, but it's better than nothing. Okay, so this is connected here by this. We have this extending out here, blah, blah, blah. Oh my gosh, what the fuck? It's connected at L/2? Yeah, center of the rod. This is H? Yeah. This is T. This is mg, mass of the rod, 1.8 times 9.81, 17.6. And then this here is Mass of the sign is 0.6 times 9.81 is 5.88. And this is L over 4. L by 4. This is obviously L by 2. So this is, right here is going to be 3L over 4. This angle here is 28 degrees. This is 90. This is going to be 90 plus 28 minus 180 is 62. 90 minus 62. 180 minus 62. This is going to be 118 here. I don't know. I just remember you needed like all these crazy ass angles and this shit. This here is going to be the this theta is 90 minus 28. 90 minus 28. 62. So this is going to be, if we make this a right angle here, it would be here. If we make this a right angle here, this is a right angle, so then this would be 28 again. And then we'd have t cosine 62 or t sine 28. They should be equal. Sine 28 cosine 62. Yep, and they're equal indeed. Okay, so that's the force acting upwards. So if we choose this as our axis, our axis of rotation, we have net torque obviously equals 0. For torques we have, no, let me do the work over here. So we have net torque equals 0. Our torques, so we have 0 equals t cosine 62 times L over 2 minus 17.6 L over 2 mg L over 2 minus m1g 3L over 4. Yeah, what are we trying to solve for? Tension? Completely forgot. Okay, so we get t cosine 62 times L over 2 equals mg. Oh no, they're different m's. Mg L over 2 minus m1g 3L over 4. Because we could pull down an L over 2. Or we can cancel out an L over 2, but we'll just solve. It's a lot easier. Mg, less mistakes. 1.8 times 9.81 times L over 2. What's L? Are you high, dude? Are you serious? What's L? A horizontal rod of length L. Okay, so now we have to solve for, we have to somehow figure out what L is. What? They don't give us any values to do that. It means 90-degree angle. We're only missing, we just don't have the hypotenuse. If we had the hypotenuse, we could solve that, but. Okay, so, we just need one length, actually. Any length. H, anything. We just need meters of something of meters. We can cancel out a L over 2. That's what we need to do. T cosine of 62 equals mg minus m1g L, no, over, wait, if we have 3/4 L and we have 1/2 L, so we can cancel the L's. 1/2. Oh, we can just keep the we can just cancel the L's. Yeah, we don't need to do the fractions. We can just cancel the L's. There. It's a lot better. Okay. 1.8 times 9.81 over 2 minus mass of the sine 0.6 times 9.81 times 3 over 4 times 2, and then divided by cosine of 62. We get 18.8. We get t equals 18.806. So 18.81. Oh my gosh. How? Why would they do this to me? Why would they put my answer on there if it was wrong? This makes no sense. My answer is correct. Are my angles wrong? Don't tell me it's cosine of 28. No, it's not. It's not. I got. What? There's no possible way I got this wrong. Am I missing a torque? Mm-mm. 3L over 4. Did I use the wrong masses? No. There's absolutely no way I get this wrong. I'm not gonna redo it, but I'm not gonna change my answer. Bro, if that's not what I have, then T equals no what? It still doesn't change anything, dude. Look, I'll rewrite what I have down here. I'll rewrite it all on one side. I'm not going to change a single thing about... Oh, wait, no, he has it written on two sides. I'm not going to change a single thing about what I have written. The mass of the rod, G over 2, minus mass of the sine, G times 3 over 4, equals T cosine 62 1/2. And if you cancel the 1/2, you get MR. This is exactly what I have. It's the same. So you're gonna give you the same answer. MRG minus MSG 3/2 equals T cosine or T sine theta, T cosine theta, or T cosine phi. It's the same thing. It's the same exact thing. That is what I have. That is what I have. And he says times 2, but what do you mean times 2? Oh, times 2, yeah, times everything by 2. Yeah, exactly. MSG 3/2 minus, why do I have a minus sign? Oh my gosh. Oh my gosh. Why do I have a minus sign? When I switch this, you plus this to both sides, and then you plus this to both sides. Why the fuck do I have a minus sign? Oh, my fucking shit's out of connection. It's not connected. Bro, why the fuck do I have a minus sign? I'm about to lose my mind. But why did I have a minus sign? If I do that on the exam, I'm gonna freak out. Bro, use your brain. Do you not know how to do algebra? Can this shit connect? Like, I don't know how to do algebra, but this doesn't know how to do its job. It's basic algebra. I mean, this is like 2nd grade math. My gosh, dude, I'm such an idiot. Okay, whatever. Let's recalculate it just so that we have the answer correct for our next. That's how we answer the next question. This is a plus here. Times 2. I also wouldn't be making these mistakes on the exam because I also cosine of 62. 56.4. Yeah, T equals 56.4. I look over all my answers multiple times, so there's no way I would be getting these that I would not be catching that stupid mistake. I'm gonna leave it wrong though for now, until I come back. What is FV, the vertical component of the force at the hinge? So I'm gonna do it again later in a couple hours, so then the question's completely out of my mind and I just don't make the same mistake. What is FV, the vertical component of the force that the hinge exerts on the right end of the rod? What is it talking about? Positive answer indicates. Well, the hinge exerts on the right end of the rod. It's negative. Positive answer indicates an upward force. Oh, hint. Balance torques about an axis through the center of the rod. Are you high? Okay. I mean, I can do this. I need to get the... So this again is net torque equals 0, obviously. The torques we have here about the center of mass, we have the sign at L over 4 away. The sign's L over 4, so M sine G L over 4. This is counterclockwise, so it's positive. We have the tension, which is going to be negative T. Oh no, we don't have the tension because that's the center of mass. And we're just going to have the hinge, force of the hinge times L over 2 equals 0. right? Because the tension will go through the center of the mass. The center of mass obviously goes through the center of mass. And then the sign is hanging a distance L over 4 away. So this is our answer. MSG. Just make sure our signs are correct. Obviously, it has to be negative because it's equal to 0. It's either negative or the force is, oh, well, it's positive. But look, I'll write it explicitly so that we can get the correct answer. The force is negative. The distance can't be negative. The force is negative. So MS is 0.6 times 9.81 times L. We don't know L. We can cancel out the L's. We just have over 4 equals negative F over 2, so times 2 is 2.943. Negative 2.94. A positive answer indicates an upward force. Oh, what? A positive answer indicates an upward force. Oh. Wait, what? Wait, no, the force is downwards. The force is downwards. The force is downwards. Yeah. Negative 2.94. Yeah. 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 Yeah, I get this one right, just 63%. This one wrong, 84%. Fucking my dick, dude. So the answer. I didn't even get this one wrong. Well, I did, but it was stupid. Like, had nothing to do with the way that I calculated it. I did everything correctly. It's fucking negative sign. Okay, come on. Suppose the answer to the first question of the page is T if the wire is replaced by a longer one that runs from the left end of the rod to the same point on the wall, a height h above the hinge. And if the rod is still horizontal, how would the new tension compare? Okay, so essentially it's the same spot on the wall, so your theta is going to be significantly less, right? So it's just the same exact thing, but with a smaller theta. So I can actually recreate that. 26.4 over cosine of, let's just say 40, which is smaller. We're gonna have a smaller number, a smaller tension. The tension is gonna be smaller. The new tension is gonna be smaller than the old tension. Okay, let's continue. A child of mass M equals 40 kilograms is standing next to a merry-go-round. Let's get some space here. Is standing next to a merry-go-round having a moment of inertia. IMGR equals 834 kilograms per meter squared, and radius R equals 2.3 meters. The merry-go-round is initially rotating with. Let me not read this out loud. Wait, the merry-go-round is initially rotating. He jumps on, the child jumps on with 0 velocity. They didn't tell us, is it? Okay, so I'm gonna assume when the child jumps on, there's no angle, there's no velocity. I don't know why they wouldn't tell us that. I mean, it's safe to assume it, but they should explicitly say that. Poorly worded question. Okay, so we're gonna have this is Li equals Lf equals. Can I do this from memory? Okay, so for tangential it's R cross P. For it's I omega. L equals I omega, exactly. So Li is going to equal moment of inertia of the merry-go-round, 834. Wonder why they tell us that. Did they not give us the radius and the mass? Oh, they give us the mass of the child. Do I have to solve for the mass? The fuck, dude. These are so simple. Okay. I don't know why I speak like that. Times 6. Whoa. Jesus. Jeez, dude. 834 times 6. 5,004. Li equals IF WF equals 5004. IF equals 834 plus M40 times 2.3 squared. 834 plus 40 times 2.3 squared. Angular velocity is going to equal 5004 divided by that number. We get WF equals 4.78. That's right. I don't even have to check. I know it's right. Continue. Suppose the total kinetic energy of the system with the child standing on the edge of the merry-go-round is K edge. Child now walks inward and stands at the center of the merry-go-round. How does K center the new kinetic energy of the system when the child is at the center as compared to the edge? So the child is going to exert a work on the system as they move, so they're not going to be equal. Our kinetic energies are going to be half. Oh, we can just calculate it, and that will be the work done by the kid. So I guess it's irrelevant, kind of, to the question to even know that that is true, because we're about to figure it out anyways. So Ki, or K edge, I guess they would call it. K edge is going to be half I omega squared, and it has no tangential kinetic energy because there's nothing in the tangential direction. K, this is K center. So delayed, bro. What is up with this? It's the Wi-Fi. Yeah, it's because of the Wi-Fi. Okay, whatever. Half IF omega squared. Okay, we know omega initial, we know omega final. I initial, we know I initial. We don't know I initial. We do know I initial. It's the same I from the last problem. I initial equals 1045.6. I final is going to equal just the kid's mass plus the... So, a fucking piece of shit, dude. Okay, so I'm going to have to solve for I final. Okay, right. So, let's go back to the previous. Oh, well, we can just do with the I initial. No, we're going to go back to the original. So, half mr squared disk. It's a disk. It's a disk. It's a disk. It's safe to say. It's safe to assume it's a disk. Equals what? 834. 834. So 834 times 2 divided by what's r? 2.3 squared. Divided by that, we get mass equals 315.312. Okay, now we can solve I final equals half mr squared plus, half m plus m child r squared. So 1/2 times the child 40 plus answer times radius of 2.3 squared equals 939.8. Okay, so this equals, so 1/2 times 1045.6 times omega initial squared, 4.79 squared. Does it have the same omega? 1/2 times m plus m. Oh, no. 1/2 times this is 460. Oh, wait, this actually doesn't really help us at all. I just realized. Solving this doesn't help us. Let's just think about it intuitively. Well, the moment of inertia... Oh, the angular velocity is the same. The angular velocity is the same. Or angular is the same. Times, yeah, angular is the same, 4.79 squared. Okay, so we get K center is 1078.1.4. This is 11995.2. On the outside, the edge is greater than the center. This is bullshit, dude. What did I do wrong? Fuck you. A hollow ball, spherical shell having a mass m equals 2.02 and a radius r equals 0.17. Okay. This, the ball. Okay, the ball rolls without slipping, so technically the acceleration of each point is 0, but the acceleration of the center of mass. Okay, so we can find the rotational acceleration. Okay, so look, mgh, right, is going to equal half I omega squared plus half mvcm squared. Oh, what are we doing this for? No, we want the velocity. I don't give a fuck. Oh, well, I guess we can still have that because we want the acceleration. There's gonna be oh, because torque equals I. Yeah, okay. Torque equals I alpha. No. Should we just do F equals MA? This is not right. Okay, 2.02 times 9.81 sine of 30 divided by 2.02. It's one of the answers, but that's not it. My gosh, my brain hurts. When did you do F equals MA? F equals F. F does not equal MA. F would equal. Oh, F would equal MA. Yeah. Friction would equal MA. It would be F equals mg cosine theta. Okay, I got 4.9. Yeah, I was wrong. 58% of students got this question right. No, I knew that one was wrong. I don't know how to do it, so I gotta come back to it. I don't know how to do it. It's plain and simple. I wasn't really paying attention, but what is the maximum speed the mass attains as it oscillates on the spring? Simple harmonic motion. A mass m equals 3 kilograms plus an ideal spring with spring constant and is free to oscillate on a horizontal surface with no friction. The mass is pulled 16 centimeters to the left of equilibrium and released at t equals 0. Okay. Simple harmonic motion. This. Oh, I'm fucked. Oh, I'm fucked.
Oh.
Oh shit. I don't know how to do any of this shit. Oh, fuck. Okay, well, we have all these. Mass on a spring. Omega squared equals K over M. So that's what it says, buddy. So we're just going to do root K over M. 185 over 3. 7.8. Oh, no. That is simple harmonic motion. It's simple harmonic motion, bro. Oh, it's just not the equation. Hello? That's it. It's the answer. Is this what it wants me to do? What the fuck is sine omega t blah blah blah? Yeah, I'm not gonna lie, dude. Bro, I don't know how to do any of this shit. Okay, but look, we can figure this one out. This is common sense. 3 masses are in a swimming pool filled with the water density. Blah blah blah. It doesn't matter. None of this matters. Object A floats. Object B is submerged. Object C is sink to the bottom. Compare the magnitude of buoyant force on each block. Okay. This seems like it would be common sense. V volume. G volume. They all have the same buoyant force. It's all the same. Fucking piece of shit. Oh, because this one's out of the water a little bit. I don't know. I don't know. PGV. I don't know. The action object speed due to the bottom of the pool. I don't know. Okay, let's continue. So we don't know how to do that. Okay. Here we go. A wave has displacement units in meters given by this bullshit. The wave travels on a string with mass density. What direction is the wave moving? Oh, this was on the homework. Except the problem about that is I just don't know what that... I guess it doesn't matter that it was on the homework because I still don't know how to do it. Positive... Oh my gosh, you're fucking kidding me. Z equals this. What the fuck is going on? Nope. Nope. Okay, I know how to do this. Speed of the fluid increases. I'm really think I know that that's the answer. I really think that that's the answer. A1 V1 equals A2 V2. Dude, I'm him. Like, obviously. You see this, bro? These questions are so easy. I'm so fucked. Calculate the pressure differential of the fluid in the two areas of the pipe. Okay, I know how to do this actually. This is it. I think pressure differential is like P1 minus P2 equals man, what the fuck? No, bro, why is this not on my equation sheet? Like, actually. Am I supposed to memorize this shit? I think it's like half. I think it's like this. I think that's it. I think that's the answer, bro. Wait, but why would we not have to have area? Oh, maybe because the area, I can get the density? No, we have density. We have the velocity. Oh, that's why it gives us all that information, because it wants us to calculate the velocity of the second velocity. Okay. V2 equals A1 V1 divided by A2. Okay, that's why. I was going to say, they don't give you information that you don't use. A1 V1 divided by A2. 7.57. Yeah, makes sense. Okay, and now we can solve. We do half times 1,000 times v squared, v1 squared, 3.2 squared, plus half times 1,000 times this squared. Okay, so this is not how you do it. We're gonna figure it out though. Let's do a minus this time. Okay. This is supposed to be a minus. Okay, so 23,600. Negative 20. Oh, the thing is though, calculate the pressure differential of the fluid in the two areas of the part. A positive answer means pressure increases in region 2, and a negative answer means that pressure decreases in region 2. Now, how the fuck am I supposed to know where the pressure decreases? The pressure decreases in section 2 because there's less water above you. If you get what I'm saying. Yeah. Positive answer means the pressure increases in region 2, and the negative answer means the pressure decreases in region 2. The pressure decreases in region 2. If this is wrong, I'll pay everyone in the entire world $10. So fucking easy. So, if looking by the green bar, yeah, looking pretty good for this final. I'm just kidding. Obviously, shit. Okay. I mean, I can do these questions, I just didn't really want to. I'm gonna do them later, I think. Yeah, I'm gonna do them later, I think.
What are you doing? Why would you bring the glass on? You just leave it. No one's gonna care. No, you should break it down. You should break it. That's nice.
So let's check the length of this shit. See if we need to finish these questions or if we can get up. What the fuck are they doing? Oh, it's only 58 minutes long. Like, are you guys? Is this? Does YouTube want to be serious for 1 second? Yo, what's up for Hussein? I'm currently getting bodied by Physics 211. I've done very well in this class up until today. 8 hours? I've been streaming for 8 hours? Shit. Should I stream for 10 hours? I'm from Cedar Rapids, Iowa, but I go to the University of Illinois, Urbana-Champaign. I live in Presby Hall for about 3 more days. Yeah, so I don't know how to do any of these questions. And this one I forgot how to do, but I remember I know how to do it at some point, so it's chill. And this one I forgot how to do, but I knew how to do it at some point, so it's pretty chill. Yeah, I just couldn't figure this one out. Yeah, I need help. From EDEXL? What is that? EDEXL. Interesting. What is this thing, dude? Oh, Pearson? I know Pearson. I don't know what EDXL or EDXL. EDXL. Oh, EDXL. Oh, EdXL. EdXL. Yeah, I get it. You're an A-level student. That's sick. I never took any A-levels. I took AP classes. Said I wasn't gonna look at chat, but I'm done, dude. This is all I can figure out how to do. Just these questions. Once I learn how to do these, I'm chilling. This I know how to do this. I just forgot. And I know how to do this too, but I also forgot. Chemistry. That's sick. If I took the chemistry AP exam, I wouldn't have to take chemistry at my school, which would be very great. So I wish you well, because you would benefit a lot from taking that class, from not taking that class in college. Because you can use your A-level exam as for credit. I'm gonna go to the bathroom. I'll be right back. Good luck on your chemistry exam. Actually, I'll just go after. I'm trying to think of what I should do right now. Should I take a break or should I figure this shit out? What is CSE? Everyone, like all the schools have their different acronyms. I imagine it's, I don't know. Yeah. Computational sciences and engineering. We do not have CSE. What is this? I do not know what this is. Yeah, I'm from Iowa, Cedar Rapids, Iowa. There's a minor? Caitlin Clark from Iowa. That's funny. Oh yeah, Caitlin Clark is from Iowa. Okay. CS 101, terrible course. Don't have to take it. They would want me to take EC 220. Taken this already. That's crazy. Taking this. Applied math. Taking this. Oh, the slash. I took that. Took that. Yeah, I took that. 408. What about 400? Wait, what? 409, 410, 420, 430, 461. Why not? Oh, you choose one course from here. Oh, I'm tweaking. Okay. So I've taken CS 225. Yeah, okay. So I've taken CS 225. The name of the degree is CSE, basically software engineering. I think it's a lot. Computer science and engineering is not software engineering. Yeah. Computer science alone would be a little bit of software engineering. It kind of depends on the university you go to. Like at my school, computer science is not software engineering. They teach you a bunch of more stuff than just software engineering. It's all math and theory. So, like if you think, when you go to college to do like computer science and engineering, I mean, you're going to do quite a bit of coding, but it's primarily going to be thinking like math and critical thinking. I don't know any classes. Yeah, I've taken CS 225, I've taken linear algebra, computational methods. I'm taking this class already. Oh, EC 448 and SAT 400. So I've taken this class and this class. 9 courses, any 3 CSE courses to 400 level. Yeah, no, but it's like if you want to do software engineering, you go into computer science and engineering. I'm majoring in physics. I'm concurrently doing a bachelor's I'm doing a bachelor's in physics, a master's in computer science, and then a PhD in machine learning and artificial intelligence. That's what I'm doing. I haven't applied for the PhD yet, obviously, because I'm a freshman, but I will my senior year. A-level physics unit 1. Yeah, I'm in physics right now. It's pretty easy for the most part. Oh, these are the list of courses? Approved courses. That's sick. Yeah, I know those classes are interesting. Fuck those classes. Lord, why don't they have any? What uni are you from? I go to UIUC. What is it? This will answer all of your questions. Yeah, that's so stupid. Oh, maybe because it has to be capital. No. Yeah, no. What's your question? I'm about to end. Well, I'm about to go to the bathroom. I'll answer your question when I get back. I'll do that at least. Yeah, I think yes, God is very compatible with physics. I believe in God, and I also believe in physics and science. I think my belief in, or my understanding of physics and science has escalated my belief in God. Yeah, I think it's pretty incorrect to think that, not like trying to attack you, but like people tend to say that science is a contradiction to God, but I don't believe that. I think that that's incorrect. But then again, it's all just beliefs, so no one knows what's fact, so it's all up for interpretation. They could be correct. I don't know. I don't think they are. This isn't a jersey. This is for a team. Yeah. Oh, well, it is kind of a jersey, but well, I mean, it's not a jersey. I don't know what I'm saying. It's not a jersey. It's just a T-shirt. It's just a long sleeve. But it is for a team that I used to be like associated with. No. Oh, NBA. Who will win? I have no idea. I haven't watched I only watch my brother's basketball games. He plays Division I basketball, but yeah, I don't think I've seen an NBA game in like years. Like they're on, but I don't follow it. I know the teams and stuff. Mavs or Wolves? Timberwolves? Who's on the Wolves? He plays for Eastern Kentucky University. Well, he plays for. Look, this is him. He plays for UMKC this year. But he's transferring. Look, he transferred. He committed to EKU. Or are you kidding me? Okay, whatever. I can't open it, but he's transferring to Eastern Kentucky. To this school. Yeah, he's 6'6". Oh, my mom's on her way. W jeans. Yeah, you could say that. I'll just do work until my mom gets here. What's going on, bro? Why is Life 360 not working? App is useless. Oh, there we go. She is 2 hours and 49 minutes away. Jeez, dude. You're not gonna be here till 11. Bro, I need to be asleep at 11. I'm 6'2", and I play basketball for my school. That's sick. I'm like 6'2", 6'3"-ish. Played basketball in middle school. Now I just play occasionally with my friends for fun, but not competitively by any means. Should I learn how to do this or no? Hello? That's what I did. Wait, that's actually what I did. How'd you get from velocity t equals 2 pi r over v? Look, I have it over here. Yeah, here. 2 pi r over v. 2 pi... Wait, are these the same numbers? 1.7 times 10 to the power of 7. Oh, no, this is a different problem. This is a different problem. Whatever, I'll just redo it. I'll redo it. 100. How to make physics easy and fun? Because for me, it's a drag. Well, if it's a drag, then it's not. I don't think it's ever gonna be fun for you. Well, I mean, maybe that's not true. Yeah, I don't know. Just try a whole bunch of what physics have you taken? AP. Okay, you took A-level physics unit 1. A-level physics unit 1. What is this? Physics on the go. Sounds like a terrible class. Density, fluids, momentum, Hooke's law, forces, mechanics, work, motion, work, energy, Hooke's law. Yeah. Maybe you'll like the higher level courses. That's yeah. Maybe you'll like when you take like 1, 2, 3, or 4, or 5, or 6. But if you don't like the physics that you're doing, you most likely will never like the physics that you're doing. But the good thing about physics is there's a lot of different types of physics to be doing. So maybe you like astrophysics, computational physics, biophysics, physics. Everything is physics. So I'm sure there's a type of physics that you will like. But if the physics that you're taking right now, you think it's a drag, it will always most likely be a drag. But I kind of don't really think about like how much I enjoy it, right? Because well, I enjoy physics, first of all, but when I do classes, when I do my classwork, I don't think about like how much enjoyment I'll get out of it when I'm doing it. You know, it's got to get done. The deadline's the deadline, so I kind of just do it and do it. I have to do it. I like to do it well. Also, where's my phone? I don't have my phone. Oh, there. Hello. I think the greatest physicists of all time were not in. This is not in order. Oppenheimer, obviously, Albert Einstein, Stephen Hawking, and Richard Feynman. Faraday. Faraday is honorable mention, but no, actually Faraday. Faraday is definitely on the list. Yeah. Feynman, Faraday. Oh, Isaac Newton. Am I crazy? Bro, it's like there's so many. Everyone's so good at physics. The Wi-Fi fail? Gosh fucking damn it. This bullshit again. Nikola Tesla? I mean, yeah. He's alright. I don't know. Nothing special, I don't think. Yeah, I know his inventions on Nobel. Did he win the Nobel Prize? I don't know why the Wi-Fi continues to do this bullshit. Says Nikola Tesla refused the Nobel Prize. I think that's a pretty stupid thing to do. think that's a pretty stupid thing to do, but yeah. No, not really. Nikola Tesla's not on my list, no. Well, at least I can do this without or just with my calculator. Oh wait, I can just do it also. It's gonna be, how long does it take the satellite to make one complete orbit? What's going on here? What are you saying? Flex. Nobel Prize is a flex. Nobel Prize is a very, very prestigious award that is proof of your of your physics intelligence if you're getting the physics Nobel Prize. It says that Tesla refused the Nobel Prize, which is very foolish, but regardless of the reason, but it's okay. Okay, so this is our F. This is our F. F equals MA, so that divided by M, 15, 17. F equals MA. M equals V squared over R, so times R, 10.4 times 10 to the 6th. V squared over R, square root of that. And now we do 2 pi. No. We do this divided by 2 pi. Wait, no, we're still getting the incorrect answer. No, Nobel Prize is great. I love the Nobel Prize. What is going on with my math? GMM over R squared equals this is what I just did. GMM over R squared times R Wait, why did I divide? Oh, yeah. Divided by mass, 15, 17, times R. Bro, what is going on? Wait, let me write out what I'm doing. F equals G times M times little m over R squared. F equals MA. Are you gonna be live tomorrow also? Of course, I'm gonna be live every single day. From today and forever. I will be live every single day. 6.67 times 10 to the negative 11th times m 5.2 times 10 to the 24th times 1517 over 10.4 times 10 to the 6th squared. 4864. So A equals 4864 over M. A equals V squared over R. V equals root AR 4864 R over M. Well, yo, is that Guts in your profile picture? Yeah, it is. It is Guts. It's one of my favorite animes of all time. Everyone watches anime. It's so awesome. 15, 17. And you divide it by 2 pi, right? Oh, 2 pi r divided by it. 2 pi r. 11,000. 11,000, bro. What are you talking about? Yeah, that's what I... Yeah, 5,700. T equals 2 pi times r 10.4 times 10 to the 6th over v. 11,000 seconds. Oh my gosh. No, I didn't mean to do that, but I'm so stupid. 11,000 seconds divided by 60. I got 188.8, 100.58. Okay, what are we saying? It's a Griffith. Yo, is that Guts in your profile? Griffith is better though? Hell no. Guts is way better than Griffith. I thought Griffith was fake. Fuck Griffith. Guts was so tough. It's a manga anime trash, except the first one. No, the 1990 anime is so good. It's so good. The 1990 version. The 2016 anime is so bad. Like, it's unwatchable. I heard the manga is good. I haven't read it, but the anime was so good. Okay, let me redo this again, and so that I can just learn, so I can understand. Well, I did it right the first time. I just didn't know that t equals 2 pi r. T equals 2 pi r over v. Where did you get that from? T equals 2 pi r over v. Oh. Because angular velocity equals v over r. And t equals 2 pi over omega equals 2 pi oh no, flip it. Yeah. There we go. Griffith felt betrayed and made deal. Bro, Guts was betrayed. Fuck Griffith. Griffith felt betrayed. Guts was betrayed by Griffith. Bro, Guts is him. Fuck are you talking about? Guts is him. What? I'm trying to think. Like, what can I say? Bro, Guts beat him in a fight. Yeah, dude, the questions are hard as fuck. I'm not getting 100 on... No, I am going to get 100 on it, but the practice exam's hard. The, questions 41 through 50. I just don't remember how to do them. I guess I can learn how to do them, but I don't remember. So do right B has twice the mass. Oh, I was gonna redo this again to drill it into my brain. Okay. So we have here T omega. We have this. Omega equals 2 pi over T. T equals 2 pi over omega. Omega equals V over R. T equals 2 pi R over V. V equals root A over V squared. A equals V squared over R. A equals V squared over R. V equals AR. V squared equals root AR. What's going on? I'm gonna study for chem. Alright, see you later, bro. See you tomorrow. V equals root AR. A equals F over M. F equals GM M over R squared. Plug that in here. We get GM M over M R squared. M's cancel. Plug it in here. We get T equals 2 pi R over root GM over R squared times R. T equals 2 pi R over root GM over R. Okay. 2 pi times R. 10.4 times 10 to the power of 6 over root 6.67 times 10 to the negative 11th times big M 5.2 times 10 to the 24th over R, which is 10.4 times 10 to the 6th divided by 60. Nice. Okay, we got it. Okay, satellite B has twice the mass of satellite A and moves in an orbit with the same radius. Which of the following best describes VB? VB is going to be the same, because we get V equals root GM over R. V equals root G big M over R. And if R is the same, G is the same, and big M is the same, they're equal. Satellite C has the same mass as satellite A and moves in orbit twice the radius of the velocity. The velocity will be smaller, and the new velocity C will be smaller. And moves into orbit twice the radius. If we multiply 2 by the denominator, it's going to be much smaller. Yeah. There we go. This question. Try connecting the Wi-Fi again. This question. Just remember. D equals XCM minus L over 2. Yes, yes. See, I had it on my iPad. Yes, yes. That's exactly right. That's exactly right. Look. This is XCM. Where XCM is actually going to be like this is XCM. And this is L by 2. So D equals L by 2 minus XCM. Okay, what's L over 2? L is 5.5 over 2 minus, oh shit, do we need to know if it's positive or negative? 0.39. 2.36. Fucking serious, dude. I just did exactly what he said. Maybe I calculated XCM incorrectly. Oh. Oh yeah, I did calculate XCM incorrectly. XA. Oh, we chose that to be as x equals 0. Ooh, but I chose the middle to my x equals 0. It should be the same. Oh, yeah. Negative 58.5 or 58.2 times L over 2, 5.5 over 2 plus 77.6 times 5.5 over 2. Wait, yeah, what? It should be the same. It shouldn't matter where you choose your axis. It should all be the same. Okay, let's do new axis. Oh, I forgot the mass in the denominator. I forgot the mass in the denominator, that's why. Yeah, no, I did it correct. I forgot 77.6 times 5.5 over 2. 58.2 plus 77.6. I forgot the mass in the denominator. Hide this. I know what to do. I forgot the mass in the denominator. Where's the mass of the plank? 15.9 plus 15.9. Yeah, that's our... Okay, let's times that by -1. What? What? Oh, 55. I accidentally did 55 over 2. No, 5.5 over 2. Yeah. 5.5 over 2 minus, oops, minus this. 2 point. Chat, I'm sorry. I'm still getting 2.39. Okay, well, if we do the center of mass, okay, let's do 15.9 times L over 2, 5.5 over 2, plus 77.6. 77.6 times L. 5.5 over 15.9 plus 77.6 plus 58.2. Oh yeah, I guess we do get a different answer. Negative 0.35. Oh, but it's positive. It's positive 0.35. It's fucking stupid. Okay, I'm gonna leave these unanswered so I can come back to them tomorrow. Let me figure out how to... Oh, let me figure out how to do this question. Well, they did do F equals MA. I just didn't draw the free body diagram. They said friction? Oh my gosh. Oh my gosh. I remember this. I remember doing that in discussion. I remember that. How do you do this one? Conservation of energy? Okay. I can do that. Oh, times fluid displaced. Oh. No. No, it still doesn't make it. Oh, because of their size. Yeah. Okay, I get it. This shit's beyond me. I don't know what the fuck. Oh wait, I can actually solve that. I already know this. This is on the equation sheet. It's right here. But yeah, I already know that. It's fine. Alright, yeah, I'm chilling. This exam's gonna be light as fuck. I'm gonna do them again tomorrow morning. I'll go over them later tonight after I eat. But then, yeah, I'm gonna go get my sandwich. I'll be right back. I need to eat. I'll be right back. Oh, let me mute up. I bet. I'm about to eat this food. Not gonna do physics for a little second. This is the messiest sandwich ever. Should I eat it with a fork and a knife? Yes. No. I don't want to go all the way over there. Okay, this is gonna be so bad. Here's some naps. Oh my gosh, my mic is freaking out right now. So I'm tapping the desk. So, jeez. I microwaved it for a pretty long time. Okay, dude. Like, they made this thing any harder to eat. Oh my gosh, it's so hot. What should I do while I eat? Watch YouTube? Yeah. Watch Veritasium.
Anything enter a black hole.
Okay, wait, I can't hear it.
Imagine you trap your nemesis in a rocket ship and blast him off towards a black hole. He looks back at you, shaking his fist at a constant rate. As he
Yo, is
zooms
it
in,
loud?
gravity gets stronger, so you would expect him to speed up. But that is not what you see. Instead, the rocket ship appears to be slowing down. Not only that, he also appears to be shaking his fist slower and slower. That's because, from your perspective, his time is slowing down. At the very instant when he should cross the event horizon, the point beyond which not even light can escape, he and his rocket ship do not disappear. Instead, they seem to stop, frozen in time. The light from the spaceship gets dimmer and redder until it completely fades from view. This is how any object would look crossing the event horizon. Light is still coming from the point where he crossed, it's just too redshifted to see. But if you could see that light, then in theory you would see everything that has ever fallen into the black hole frozen on its horizon, including the star that formed it. But in practice, photons are emitted at discrete intervals, so there will be a last photon emitted outside the horizon, and therefore these images will fade after some time. This is just one of the strange results that comes out of the general theory of relativity, our current best theory of gravity. The first solution of Einstein's equations predicted not only black holes, but also their opposite, white holes. It also implied the existence of parallel universes and even possibly a way to travel between them. This is a video about the real science of black holes, white holes, and wormholes.
Some of all these fucking holes, bruh.
Arose at least in part due to a fundamental flaw in Newtonian gravity. In the 1600s,
Hey, that's what I was just doing.
apple falls to the ground in Newtonian gravity. In the 1600s, Isaac Newton contemplated how an apple falls to the ground, how the moon orbits the Earth and Earth orbits the sun, and he concluded that every object with mass must attract every other. But Newton was troubled by his own theory. How could masses separated by such vast distances apply a force on each other? He wrote that one body may act upon another at a distance through a vacuum without the mediation of anything else is to me so great an absurdity that I believe no man who has a competent faculty of thinking could ever fall into it.
The hell is he
One man
talking
who
about?
definitely had a competent faculty of thinking was Albert Einstein. And over 200 years later, he figured out how gravity
so
is
nappy.
mediated. Bodies do not exert forces on each other directly. Instead, a mass like the sun curves the space-time in its immediate vicinity. This then curves the space-time around it, and so on all the way to the Earth. So the Earth orbits the sun because the space-time Earth is passing through is curved. Masses are affected by the local curvature of space-time, so no action at a distance is required. Mathematically, this is described by Einstein's field equations. Can you write down the Einstein field equation?
This was the result of Einstein's decade of hard work after special relativity. And essentially what we've got in the field equations, on one side it says, tell me about the distribution of matter and energy. The other side tells you what the resultant curvature of space-time is from that distribution of matter and energy. And
now, how the
it's a
fuck
single line, it looks like
did he
this is a
derive
simple
that?
equation, right? But it's not really one equation, it's a family of equations. And to make life more difficult, they are coupled equations, so they depend upon each other. And they are differential equations, so it means that there are integrals that have to be done, blah, blah. So there's a whole bunch of steps that you need to do to solve the field equations. To see what a solution to these equations would
Sweet.
look like, we need a tool to understand space-time.
So imagine you're floating around in empty space. A flash of light goes off above your head and spreads out in all directions. Now, your entire future, anything that can and will ever happen to you, will occur within this bubble, because the only way to get out of it would be to travel faster than light. In 2 dimensions, this bubble is just a growing circle. If we allow time to run up the screen and take snapshots at regular intervals, then this light bubble traces out a cone, your future light cone. By convention, the axes are scaled so that light rays always travel at 45 degrees. This cone reveals the only region of space-time that you can ever hope to explore and influence. Now imagine that instead of a flash of light above your head, those photons were actually traveling in from all corners of the universe, and they met at that instant and then continued traveling on in their separate directions. Well, in that case, then into the past, these photons also reveal a light cone, your past light cone. Only events that happened inside this cone could have affected you up to the present moment. We can simplify this diagram even further by plotting just one spatial and one time dimension. This is the space-time diagram of empty space. If you want to measure
am I
how
trying to
far
learn
apart
this
two
shit?
events are in
I gotta
space-time,
learn
you use
physics
something
I'm
called
doing.
the space-time interval. The interval squared is equal to minus dt squared plus dx squared. Since space-time is flat,
What?
geometry is the same everywhere, and so this formula holds throughout the entire diagram, which makes it really easy to measure the separation between any 2 events. But around a mass, space-time is curved, and therefore you need to modify the equation to take into account the geometry.
This is what solutions to Einstein's equations are like. They tell you how space-time curves and how to measure the separation between 2 events in that curved geometry.
Einstein published his equations in 1915 during the First World War, but he couldn't find an exact solution. Luckily, a copy of his paper made its way to the Eastern Front, where Germany was fighting Russia. Stationed there was one of the best astrophysicists of the time, Karl Schwarzschild. Despite being 41 years old, he had volunteered to calculate artillery trajectories for the German army.
At least until a greater challenge caught his attention. How to solve Einstein's field equations.
You think it's the German army?
Trajectories for the German army.
At least until a greater
These are
challenge
all
caught his
Nazis.
attention. How to solve Einstein's field equations.
Einstein was almost Nazi.
Schwarzschild did the standard physicist thing and imagined the simplest possible scenario, an eternal static universe with nothing in it except a single spherically symmetric point mass. This mass was electrically neutral and not rotating. Since this was the only feature of his universe, he measured everything using spherical coordinates relative to the center of this mass. So r is the radius, and theta and phi give the angles.
Polar coordinates.
He chose time as being measured by someone far away from the mass, where space-time is essentially flat. Using this approach, Schwarzschild found the first non-trivial solution to Einstein's equations, which nowadays we write like this. This Schwarzschild metric describes how space-time curves outside of the mass. It's pretty simple and makes intuitive sense. Far away from the mass, space-time is nearly flat, but as you get closer and closer to it, space-time becomes more and more curved, it attracts objects in, and time runs slower. Schwarzschild sent his solution to Einstein, concluding with, "The war treated me kindly enough, in spite of the heavy gunfire, to allow me to get away from it all and take this walk in the land of your ideas." Einstein replied, "I have read your paper with the utmost interest. I had not expected that one could formulate the exact solution to the problem in such a simple way."
Can you guys stop talking like this, please?
But what seemed at first quite simple soon became more complicated. Shortly after Schwarzschild's solution was published, people noticed 2 problem spots. At the center of the mass, at r equals 0, this term is divided by 0, so it blows up to infinity, and therefore this equation breaks down and it can no longer describe what's physically happening. This is what's called a singularity. Maybe that point could be excused because it's in the middle of the mass, but there's another problem spot outside of it. At a special distance from the center, known as the Schwarzschild radius, this term blows up. So there is a second singularity. What is going on here? Well, at the Schwarzschild radius, the space-time curvature becomes so steep that the escape velocity, the speed that anything would need to leave there, is the speed of light. And that would mean that inside the Schwarzschild radius, nothing, not even light, would be able to escape. So you'd have this dark object that swallows up matter and light. A black hole, if you will.
But most scientists doubted that such an object could exist because it would require a lot of mass to collapse down into a tiny space.
How could that possibly ever happen? Astronomers at the time were studying what happens at the end of a star's life. During its lifetime, the
chair is so
Earth's
loud.
gravity is balanced by the outward radiation pressure created by the energy released through nuclear fusion. But when the fuel runs out, the radiation pressure drops, so gravity pulls all the star material inwards. But how far? Most astronomers believed some physical process would hold it up. And in 1926, Ralph Fowler came up with a possible mechanism. Pauli's exclusion principle states that fermions, like electrons, cannot occupy the same state. So as matter gets pushed closer and closer together, the electrons each occupy their own tiny volumes. But Heisenberg's uncertainty principle says that you can't know the position and momentum of a particle with absolute certainty. So, as the particles become more and more constrained in space, the uncertainty in their momentum, and hence their velocity, must go up. So the more a star is compressed, the faster electrons will wiggle around, and that creates an outward pressure. This electron degeneracy pressure would prevent the star from collapsing completely. Instead, it would form a white dwarf with a density much higher than a normal star. And remarkably enough, astronomers had observed stars that fit this description. One of them was Sirius B. But the relief from this discovery
they know
was
the mass of
short-lived.
it.
4 years later, 19-year-old Subramanian Chandrasekhar traveled by boat to England to study with Fowler and Arthur Eddington, one of the most revered scientists of the time. During his voyage, Chandrasekhar realized that electron degeneracy pressure has its limits. Electrons can wiggle faster and faster, but only up to the speed of light. That means this effect can only support stars up to a certain mass, the Chandrasekhar limit. Beyond this, Chandrasekhar believed not even electron degeneracy pressure could prevent a star from collapsing. But Eddington was not impressed. He publicly blasted Chandrasekhar, saying, "There should be a law of nature to prevent a star from behaving in this absurd way."
And indeed, scientists did discover a way that stars heavier than the Chandrasekhar limit could support themselves.
When a star collapses beyond a white dwarf, electrons and protons fuse together to form neutrinos and neutrons. These neutrons are also fermions, but with nearly 2,000 times the mass of an electron, their degeneracy pressure is even stronger. So this is what holds up neutron stars.
There was this conviction among scientists that even if we didn't know the mechanism, something would prevent a star from collapsing into a single point and forming a black hole. Because black holes were just too preposterous to be real.
The big blow to this belief came in the late 1930s
Oppenheimer?
when J. Robert Oppenheimer and George Volkoff found that neutron stars also have a maximum mass. Shortly after, Oppenheimer and Hartland Snyder showed that for the heaviest stars, there is nothing left to save them when their fuel runs out. They wrote, "This contraction will continue indefinitely." But Einstein still couldn't believe it. Oppenheimer was saying that stars can collapse indefinitely, but when Einstein looked at the math, he found that time freezes on the horizon, so it seemed like nothing could ever enter, which suggested that either there's something we don't understand, or that black holes can't exist.
But Oppenheimer offered a solution to the problem. He said, to an outside observer, you could never see anything go in, but if you were traveling across the event horizon, you wouldn't notice anything unusual, and you'd go right past it without even knowing it. So how is this possible?
We need a space-time diagram of a black hole. On the left is the singularity at r equals 0. The dotted line at r equals 2m is the event horizon. Since the black hole doesn't move, these lines go straight up in time. Now let's see how ingoing and outgoing light rays travel in this curved geometry. When you're really far away, the future light cones are at the usual 45 degrees. But as you get closer to the horizon, the light cones get narrower and narrower, until right at the event horizon, they're so narrow that they point straight up. And inside the horizon, the light cones tip to the left. But something strange happens with ingoing light rays.
They fall in, but they don't get to r equals 2m. They actually asymptote to that value as time goes to infinity. But they don't end at infinity, right? Mathematically, they are connected and come back in, and they're traveling in this direction. And this bothered a lot of people. It's bothered people like Einstein, because he looked at these equations and went, well, if nothing can cross this sort of boundary, then how could there be black holes? How could black holes even form?
So what is going on here? Well, what's important to recognize is that this diagram is a projection. It's basically a 2D map of four-dimensional curved space-time.
It's just like projecting the 3D Earth onto a 2D map. When you do that, you always get distortions. There is no perfectly accurate way to map the Earth onto a 2D surface, but different maps can be useful for different purposes. For example, if you want to keep angles and shapes the same, like if you're sailing across the ocean and you need to find your bearings, you can use the Mercator projection. That's the one Google Maps uses. A downside is that it misrepresents sizes. Africa and Greenland look about the same size, but Africa is actually around 14 times larger. The Gall-Peters projection keeps relative sizes accurate, but as a result, angles and shapes are distorted.
In a similar way, we can make different projections of 4D spacetime to study different properties of it. Physical reality doesn't change, but the way the map describes it does.
He had chosen to put a particular coordinate system over space and have a time coordinate, and off you go. It's the most sensible thing to do, right?
What is going on?
People realized that if you choose a different coordinate system by doing a coordinate substitution, then the singularity at the event horizon disappears.
It goes away, that problem goes away, and things can actually cross into the black hole.
What this tells us is that there is no real physical singularity at the event horizon. It just resulted from a poor choice of coordinate system. Another way to visualize what's going on is by describing space as flowing in towards the black hole, like a waterfall. As you get closer, space starts flowing in faster and faster. Photons emitted by the spaceship have to swim against this flow, and this becomes harder and harder the closer you get. Photons emitted just outside the horizon can barely make it out, but it takes longer and longer. At the horizon, space falls in as fast as the photons are swimming. So if the horizon had a finite width, then photons would get stuck here. Photons from everything that ever fell in. But the horizon is infinitely thin, so in reality, photons either eventually escape or fall in. Inside the horizon, space falls
It's not
faster than the
possible.
speed of light, and so
Explain
everything
it in
falls
math.
into the singularity.
dx?
So Oppenheimer was right. Someone outside a black hole can never see anything enter, because the last photons they can see will always be from just outside the horizon. But if you yourself go, you will fall right across the event horizon and into the singularity.
Now, you can extend the waterfall model to cover all three spatial dimensions, and that gives you this, a real simulation of space flowing into a static black hole, made by my friend Alessandro from ScienceClick. Later, we'll use this model to see what it's like falling into a rotating black hole.
Do black holes
Now,
even exist?
I've never been sucked into a black
No, I
hole,
think
but
they do.
sometimes it feels like it when I'm stuck on the phone with a spam
I
caller.
never seen one.
Fortunately, today's sponsor, make sure to
All travel at 45 degrees like we're used to, then something fascinating happens. The black hole singularity on the left transforms into a curved line at the top. And since the future always points up in this map, it tells us that the
This is a picture of a black
singularity
hole?
is not actually a place in space, instead it's
Bro,
a moment
what am I
in
talking
time.
about?
the very last moment in time for anything
Okay,
that
this is a
enters
real black hole.
The map we've just created
Yo.
is a Kruskal-Zekker's diagram.
This is a real picture of the
This
black
only
hole.
represents a portion of
Yo.
the universe, the part inside the black hole's event horizon, and the part of the universe
Like, bro, can you guys
closest
be
to it.
fucking serious? This
But
is real.
what
This
we
is
can
real.
do is contract the whole universe, the infinite past, infinite distance, and infinite future, and morph it into a single map. It's like using the
So this is
universe's
fake or
best
real?
fisheye lens. That gives us this Penrose diagram. Again, light rays still always go at 45 degrees, so the future always points up. The infinite past is in the bottom of the diagram, the infinite future at the top, and the sides on the right are infinitely far away. The black hole singularity is now a straight line at the top, a final moment in time. These lines are all at the same distance from the black hole, so the singularity is at r equals 0, the horizon is at r equals 2m, this line is at r equals 4m, and this is
Yeah, here's
infinitely
what our
far away.
telescope actually shows.
All of these lines are at the same time.
Wait,
What's
this is
great
fake.
about this map is that it's very easy to see where you can still go and what could have affected you.
For
Yeah,
example,
this is
when
just
you're here,
animation.
you've got a lot of freedom. You can enter the black hole or fly off to infinity. And you can see and receive information from this area.
Indirect
But
images?
if you go beyond the horizon, your only possible future is to meet the singularity. You can still, however, see and receive information from the universe. You just can't send any back out. Now, think about being at this point in the map. This is at the event horizon, and now your entire future is within the black hole.
No, yeah,
But
this
what is the
accurate.
past of this moment? Well, you can draw the past light cone, and it reveals this new region. If you're inside this region, you can send signals to the universe, but no matter where you are in the universe, nothing can ever enter this region, because it will never be inside your light cone. So things can come out, but never go in. This is the opposite of a black hole, a white hole.
What color is a white hole?
I mean, it's going to be it's not going to have a color, right? It's going to be whatever's being spat out of it. It depends what's in there and gets thrown out. That's what you are going to see. So if it's got light in there, it's got mass in there, it's all going to be ejected. So the white hole kind of picture is the time reverse picture of a black hole. Instead
Oh
of
shit, that's like 20
falling,
years.
Things get expelled outwards, and so whilst a black hole has a membrane that's watching
When
the
was this
horizon,
posted?
which once you cross, you can't get back
pretty
out.
old.
The white hole has the opposite. If you're inside the event horizon, you have to be ejected. So it kicks you out, kind of thing, right? Relativity doesn't tell you which way time flows. There's nothing in there that says that is the future and that is the past. When you're doing your mathematics and you're working out
I can't,
the
I'd
behavior of
rather.
objects, you make a choice.
No, I'm
about
not. I'm not.
which
I'd rather
direction
actually
is the
do
future.
Java.
But mathematically, you could have chosen the
Okay,
other
fine,
way,
I will.
right? You could have had time point in the opposite direction. Any solution that you find in relativity,
Oh, who was that?
mathematically,
He
you could just
posted?
flip it and get a time reverse solution, and that's also a solution to the equations.
Now, we've been showing things being
No, there's
ejected
one
to the
month
right,
ago.
but they could just as well be ejected to the left. So, what's over there? This line is not at infinity, so there should be something beyond it. If we eject things in this direction, you find that they enter a whole new universe, one parallel to our own.
This is a theory, right?
We can fall into this black hole, and somebody in this universe here could fall into this black hole in their universe, and we would find ourselves in the same black hole.
The only downside
What?
is that we'd both soon end up in the singularity.
I guess I'm just trying to understand where that universe appears in the mathematical part of the solution. Like, can you point to the part of the equation and be like, so that's our universe, and then these terms here, that's the other universe, or do you know what I mean? Like,
Well, it's coordinates, right? Imagine somebody, right, came up with a coordinate system.
Yeah, but I still think this is an assumption, right?
And you looked at that coordinate system, right? You looked at it and you said,
Yeah, most likely a black hole.
Fine.
Yeah, so black holes aren't proven to be real,
Latitudes can be negative,
right?
right? You've only got positive latitudes in your solution. What about the negative ones? And they said to you, negative ones? No southern hemisphere. And you've got to go, well, the mathematics.
I think this is all just
have
clickbait.
negative latitudes. Maybe we should go.
Yeah,
go
prediction.
see if there is something down there.
Okay,
And
I
know
guess that's
a
proof.
extreme
Gamma ray
example
bursts.
Because we know we live on a globe, but we don't know
No.
the full geometry of what's
No.
going on here. In the
We don't even
sense
know if
that
gravitational waves are
once you lay
real.
down coordinates over part of the solution. It was like him
Yeah,
only
so
laying
we
down
don't have
coordinates
proof.
over
We don't have
hemisphere.
proof.
And other people
Invisible
have come along and said,
companion, yeah, it's still
"Hey,
not
this is southern
proof.
hemisphere."
I've seen the
And
X-rays, but that's still not proof.
That's why it's called maximal extension. It's like, if I have this mathematical structure, then what is the extent of
Yeah,
the
this is just
coordinates
clickbait. No,
that
this
I
is
can
not an
consider?
image of a black hole, chat.
And with the structure of the black hole, you get a second universe that has its own independent set of coordinates from our universe. I want to emphasize,
No.
right? This is the simplest solution to the Einstein field equations, and it already contains a black hole, white hole, and two universes.
That's what you get when you push this map to its limits, so that every edge ends at a singularity or infinity.
And in fact, there's another little feature in here, which is that little point there where they cross.
It's also just not a
that
reliable
is
source.
the
So
Einstein-Rosen bridge.
let me see.
To see it, we need to change coordinates. Now, this line is at constant
No,
crossover time,
black. You
and
can't
it
say black holes
connects
are
the
real. They're
space
just
of both universes.
it's a theory.
You can see what the space-time is like by following this line from right to left. Far away from the event horizon, space-time is basically flat, but
No,
as
no.
you get closer to the event horizon, space-time starts to curve more and more. At this cross, you're at the event horizon, and if you go beyond it, you end up in the parallel universe. That gives you
Yeah,
a
see,
wormhole
black holes
that
are
looks
not
like
real.
this.
Well,
So that
evidence.
is hypothetically how we
Possibly.
use a black hole to travel from one universe to another.
This is all so
Hypothetically,
presumptuous
because these
anyways, because
wormholes aren't actually
assumptions,
stable
uh,
in time.
Einstein's
It's a bit like a
theories
bridge,
are
right? It's a bridge
not
that is
proven to
long
be
and
true.
becomes shorter and then becomes long again. And if you try to
Oh,
traverse
can they
this
tell
bridge,
me,
at some
like,
point the bridge is only
the
very
proof?
short, right? And you say, oh, well, let me just cross this bridge. But as you start crossing the bridge and start running, your speed is finite, right? The speed of light, roughly. And then the bridge starts becoming
these
stretchy,
are all
and you never come
predictions.
out the other side.
This pinching off always happens too fast for anything to travel through. You can also see this if you look at the Penrose diagram, because when you're inside one universe, there isn't
Like, can they
a light
stop
cone
editing the
to
images?
this other universe. The only way to do that would be to travel faster than light.
Oh shit, this image is real?
But there might be another way.
But like, I can't believe like all
Describes a black
space
hole
images
that
are
doesn't
just
rotate.
completely
Yet
fake.
every star does rotate, and since angular momentum must be
Can they
conserved,
maybe give us some
every
real
black
photos?
hole must
Yeah, this
also
was literally like NASA said this is
While
fake, a
Schwarzschild
fake
found his
photo. This is
solution
an
within weeks
illustration,
after
yeah, an
Einstein
artist's
published his
impression.
equations, solving them for a spinning mass turned out to be much harder. Physicists tried, but
No, no,
years
this
after
picture is
Schwarzschild's
not
solution,
real.
they still hadn't
Most
solved
of these, pretty much all of these
Years
pictures are
later,
just
one
not,
which
completely
came
not
40,
real at
and
all.
then in
They're drawings.
1963, Roy Kerr found the
CGI.
solution to Einstein's equations
Most of
for
them.
a spinning black hole. Which
It's like
is
something like
more
86% of
complicated than
NASA's
Schwarzschild's
photos are all
and this
not
comes
real.
with a few dramatic
But they
changes.
say it, they just don't like outwardly say it.
First is that the
is
structure is
misleading.
completely different. The black hole now consists of several
Like, this
layers.
photo's not real, dude.
It's
Can
also not
I Google a
spherically
black hole
symmetric.
and they just show
This
this
happens
this
because the
photo
rotation causes it to
simulating
bulge
extreme
around the
space-time
equator,
project.
so it's only symmetric about its axis of spin. Alessandro from ScienceClick simulated what happens around this spinning black hole.
Yeah. So black holes are possibly
Space
real.
gets dragged around with the black hole, taking
Theoretically
the
proven
particles
to
along with
exist.
it.
Like, can we just use like
Get
real
closer,
words? Just saying
space gets
yes or
dragged
no.
around faster and faster until it goes around faster.
That's
than
Cora.
the
That's not even
speed of light.
reliable.
You've now entered into the first new region, the ergosphere.
Oh, this
No
is a
matter
real
how
source.
hard you fire your rockets here, it's impossible to stay still relative to distant stars. But because space doesn't flow directly inward, you can still escape the black hole. When you travel in further, you go through the next layer, the outer
Bro, they need to. I want to see like.
of no return. Here you can only
We need to like watch something go into a black hole. That would be so sick.
Something crazy happens. You enter another
It's like they
region
take a photo
where
of
you
something going
move
in,
around
and then take another photo,
So
and maybe
you're
it comes out the other
doomed
side. Like
to the singularity.
that would be
You're
nuts.
now inside the inner event horizon. Here you can actually
Oh.
see the singularity.
And a normal black hole, it's a point. But in a
Yeah.
rotating black hole, it actually
Well,
expands out
because
to
it
be
just
a
the
ring. And there are
the
weird
theory
things
of black holes is
inside
real, I
the
guess.
center of a black hole,
But we don't know if
rotating
it's a black hole. It
but
could be
it's that You
anything.
can actually fly through the singularity.
Our definition of black hole is not proven to be
We
real.
need a Penrose
I mean,
diagram
it's
of a
this-
spinning black hole.
Well, I mean, I
Where
guess
before the singularity was a
gravitationally
horizontal line
wise,
at the top,
like it is.
here the singularity lifts up and moves to the sides.
Bro, what
revealing
the fuck
this
is going on?
region inside the inner horizon. Here we can move around freely and avoid the singularity. But these edges aren't at infinity or a singularity, so there must be something beyond them.
What's up, George Phillips?
When you venture further, you could find yourself in a white
I'm
hole,
back.
which would push you out into a whole nother
What's up, bro?
universe.
You can have these pictures whereby you're in one universe, you fall into a rotating black hole, you fly through the singularity, and you pop out into a new universe from a white hole. And
Dude,
then
George
you
Phillips is
keep
back in
playing
chat.
this game.
Yeah, I
Extending
know.
this diagram infinitely far. But
Oh,
there
you
is
do know
still
he
one
is.
thing we haven't done, brave
Right.
the singularity. So you aim straight towards the center of the ring and head off towards it. But rather than time ending, you now find yourself in another universe.
You're studying
A
physics?
strange universe,
I'm
one
technically
where
not
pushes
studying
instead
physics
of
right now. I'm
pulls.
Did
watching
you
this
do you have any
video.
problems left, or did you do them all?
No, I have a bunch left, bro.
Oh, you what?
Yeah,
What the f, dude? Do them.
they're hard. I had to learn them first. Yeah.
Known as an antiverse.
If that's too
Wait,
weird,
what's going
you can
on?
always jump back across
Fucking
the
know.
singularity and return
guy's
to a universe
yapping.
with normal gravity.
I need to
It's a
learn.
pretty cool theory, though.
It's basically science fiction,
Yeah,
right?
it
But
is.
if you take the solutions...
Look up finite state machines. You need to learn that.
You're
Robert was trying
essentially
to tell you
face
that.
value and add on a little bit.
No, I'm not. Okay, here we go.
This is literally ECE.
Yeah, not state tables. Yeah. I mean, this is all the. No, but these are like bits.
Yeah, this is literally what it is.
Yeah. Oh,
like- it's
that's
like the same
exact
concept.
Same thing.
It's all the same.
Yeah, this guy's fire, bro. Trev Tutor, he helps me with discrete so much. He's- yeah, me neither. What? Oh my gosh.
What?
How is
George,
this?
how are you in chat? Oh, that's true. That's true. That's true, yeah.
Yeah.
How is he here?
When you get to electronics, what do you mean when you go to university? Are you in university, George?
I think your stream's really delayed.
It's very not delayed. Oh, okay. So it is, I mean, that's university. That's still university. Seneca. That's sweet. Yeah, it's super not delayed.
It's so delayed.
No, it's not. Look, I'm raising my hand. That's 5 seconds.
5
max.
seconds? That's like literally so much time.
Yeah, that's like the minimum max amount of delay.
What if like someone
I'm
like,
running
breaks in here?
10,000 kilobits per second, and and I'm on ultra
I'm running
low.
100 megahertz.
And I'm on ultra low. Fucking shit. Why? Seneca? You enjoy Seneca?
Dude, what,
Can I
did
connect
it
to
just
Wi-Fi
stop
yet?
working or what?
What, my UX play?
Yeah.
Yeah, I don't know what's going on with that.
It hasn't been on for like hours.
No, it's because the fucking... No, it was just on like 20 minutes ago, but it's because of the Wi-Fi. The Wi-Fi doesn't work in here. Subway Wi-Fi. Because my computer's on the Ethernet, but I need to connect to like the actual Wi-Fi to do the AirPlay.
Oh, that sucks. Yeah, just connect your iPad to Ethernet too.
It still wouldn't work.
I want to see if these
This
are
video,
like,
we're going to do some questions for the state. So
What
what
we
to
do.
start off with? Well, we just want to loop back to this.
Yeah, they
so
are. It's just
this
they
is
need
how I
different.
think of Grows on ones. and
Easy
maybe
talk
one
about
machine.
more machines.
The
and
second
more
question,
machines.
we put,
Oh,
as you
no.
were saying, we put a one.
It's like the
until we
same.
put in-
Well, the concept is just that your state is if your state is dependent on your output or not. That's all it is.
These are not... This is not even what I'm doing. None of this. We're doing state diagrams.
Yeah, state diagrams, FSM.
No.
Yeah.
Not FSM at all.
Yeah, this was state diagrams. You probably do K-maps.
No, we do not do state machines, finite state machines. Because those are like bits and shit. We're not concerned with bits at all.
It's the same concept though. Probably. I have
No.
no idea. I don't
We
know.
do like strings. Like you have to build a state diagram that accepts a word. And like the word can only have so many repeating characters or something. It's really stupid. But
Yeah.
Like you can
we did that with bits.
you can have tons of end states.
Yeah, we've done that with bits.
Yeah, but this is not like we
It's
don't
both-
use
it's
bits.
different.
I didn't get the highest marks in school, so I would like to get into McMaster University for power engineering. What's power engineering?
I haven't heard of that before. Look up the university too. You'll probably find more details specific.
Oh, okay, power systems engineering. It's like
Generation, transmission. Oh.
physics, electricity. Bro, you know there's a different, like this is something different. Computer science and engineering. That's a degree here. It's a minor.
It's new though, right? They just started it.
No idea. I mean, I've never heard of this ever.
I think that's one of the new majors for the Siebel.
Yeah, it must be like this year.
I don't think this existed before this.
I've never seen this in my life.
Should I apply
I
to that?
googled it. I googled.
Should I apply?
They don't have an undergraduate degree. Only
They
minor.
literally said
They only have
undergraduate and for a minor.
Yeah, and a graduate degree. But I looked up like CSE, and it was like CSE Illinois. I was like, we do not have CSE. What the fuck? What is this talking about? Because that's what some kid in the chat was like. Oh, I'm going into CSE.
I saw that.
And I was like, what is CSE? I was like, civil, computer. I was thinking of all the words. And like,
Civil systems and.
oh, that's bro. CSE is civil and systems engineering here.
No.
Yeah. Civil and systems engineering. That's what we have.
Civil and systems are different schools. Systems and industrial are in the same school. Industrial and civil are in the same school. Civil and systems isn't one degree, they're different. Civil engineering is separate at UAC. It's industrial and systems.
Oh, and ISE, industrial systems engineers.
Industrial system.
Industrial and systems.
They're technically two different majors, but it's
Industrial
the same. It's the same sub school.
and systems engineering. Yeah, that's what it is.
Yeah.
Oh, but
I was thinking of doing that for a bit, but I decided I did not want to.
yeah, ISE.
Yeah, industrial.
Oh, enterprise systems.
It's the same.
3 stars. Bro, but like
crap.
CSE, dude, when did that come out? Why do we have so many
Physical
major?
components.
We have
It's-
CS, CSE, CE.
But that's
This
what
is 11
but that's
years
what
ago.
but that's what CE and CS is. That's like literally what the difference is. One is more hardware focused and one is not.
So what the fuck is CSE? When did this come out?
Probably
They just
both.
dropped.
It's probably
they
like
just
a combo
dropped
of
this.
both.
They just dropped this.
Which major do I get to make the chips for AI?
No, they don't do. They don't have any AI classes on here.
They don't?
It's fucking pointless. I'm
Are
not
you
taking-
serious?
Yeah, it's
They don't have like any ML classes.
no, not one. Not one counts.
Really?
Bro, they don't have any for the CS minor either. Okay, nice. Oh, there we No. The following four
That's
courses
it?
are required.
That's it?
Yes, it's fucking stupid.
And then 2 upper level courses for a CS minor.
This one actually requires like a lot. It requires 18 credit hours. This one only requires 13. So I guess it's not
That's
that
19.
What?
It's 19 credit hours.
18.
No, the other one requires 19. Look, 13 here, and then you need 2 higher level ones that are at least 6. It's 19.
1, 2, 3, 4. Oh, 19. Wait,
But you literally already have. You only need you'll just get that on your own. Like yeah.
Yeah, but I don't want it.
You don't have to.
Don't
want it.
give
You're
it to
going
me.
to have it.
Don't. I have to declare for them to give it to me.
Why? Because you want it to be your focus on. You don't want physics with CS minor and.
No, because I want to use it for something else. I want to use my my courses for. I don't know.
You can do both. It's not restrictive.
Yeah, I guess. Fuck the CS minor. I'm already getting a master's in CS. What do I need a minor for? But it doesn't tell us if 400 level. Oh, all CS courses are allowed. Oh, so the machine learning classes do count for this. It's only 13 credit hours. I'm done with all of these.
Yeah, you did all of that.
I'm done with all of these.
That's insane.
So I only need 2 more classes, but
I'm
also done with these.
That's like half of a summer class.
Yo, who could help me for a physics lab right now? Not me. I have a physics exam tomorrow. I gotta study myself. Chat GPT. Heard of it? No, but this looks really cool. Like I would rather do this one.
Wait,
but
go down.
None of this shit is like
these
cool.
are all CSE classes. Have they even had a session yet or no? They just made a whole bunch of new classes.
These are existing classes. Well, these are new classes. CSE.
Surface water quality modeling.
Yeah, no, that's crazy. But look, they have all these
computer system. I would take that. I want to do a hardware class. That's what I want to do.
But it's the same as CS 427. Look, it says they've had it since 2004.
Yeah. What?
Yeah.
How have I never heard of this?
I don't know. Electronics and electromagnetics. Bro, but you know what I would do? I would do these bio.
I wouldn't do those. I would do hardware.
Because I would do this class. I would do this class.
Probably groundwater modeling, right?
No, these are the only 2 classes I would do. Actually.
Probably advanced quantum dynamics and numerical fluid dynamics.
These are
you probably are big.
These are 100% the only 2 classes I would do.
Probably groundwater modeling. You should take this off. Everyone thinks you're not looking at chat. So.
Oh right, I forgot about that.
No, don't remove it. Delete it.
Yeah, there we go. No, but this looks really cool. It looks way cooler than the CS minor, but I'm done with this. I'm done with this. I'm done with this. All I have to do is computing electives, which requires 9 credit hours.
Oh, so I can just be ACES major.
I can't even do the bio one because they only have 2 bio classes. These are probably 3 each. 3 or 4. No, 3. It's 3. And this is probably 3 as well.
Power engineering, also called power systems engineering.
This is 4. 7. How many do I need? 9?
For what?
So I can just take.
You need 6. Or for CSE?
No, for this you need 9.
For this you need.
For the thing you need 9.
9. Yeah, but for CS you need 6.
This is 7. And then I need Okay, goodbye.
Bye. Mute chat. You gotta mute chat.
I am gonna mute. Hello?
Call this one or Noah?
I think it was an accident.
You trying to call Dad?
No, Noah called it by accident.
I heard Grandma and Mom are on the way there. She was on the phone with me.
Yeah.
Bro, you got my sunrise shirt on, bro?
Yeah.
That lame ass shit.
I wear it all the time.
Wax is tight.
Yeah.
Wait, why is... And right now.
What? I can't hear you, bro. Alright, bet.
You hear me?
Yeah, a little bit. Bro, come on.
I know you can hear me.
Yeah, I can.
Yeah, why are they coming out if you're not leaving till Wednesday?
Cause mom is busy for the rest of the week, and I need her to come get my stuff from my dorm room.
But yeah, guess what?
Well,
Tomorrow I'm gonna go look at some puppies here in Kansas City.
no, you want to get one from overseas.
No, I'm getting one from America. It's cheap, but I don't think I'm gonna get the ones I go to tomorrow because there's this person that is in Bowling Green, Kentucky, which is about an hour from where I'm gonna live, and they have puppies and that they were like just born. So by the time I move down to Kentucky, they'll be like, old enough, but they'll be like perfect age. Like these puppies I'm about to look at are 10 weeks, but when those puppies are ready, when I move down, they'll be 8 weeks.
There we go.
But the puppies in Kentucky are actually like from a working line. You know what I'm saying? You know what I mean or not?
Yeah. Lolith ready. That's facts. No, this is like one of my easier classes too, which is kind of crazy.
What class?
Physics 211.
Bro, I have a C in physics now.
Is that a good thing or a bad thing?
I had a D, you remember? Thought I was gonna fail.
So that's a good thing?
Yeah, I got it up, and then I got my final on Tuesday. I get a better score. Come on, I'm gonna have an A.
No. Bro, I just need a 75 on this final to get an A in the class. I think. Yeah, I need a 75. Thank God, dude. If I actually needed to get a 90 to get an A in the class, it would kind of suck. I would be stressing. No.
I already feel that this is my last month of rent, but I'm still gonna get paid $2,000 a month for rent for the next 2 months, for June and July.
That's good. You get money before, and then get an NIL. You need an NIL deal. No, you need to get money from NIL.
Yeah, that's what it's from.
No, it's not. It's from your coach.
That's today's. No, it's through NIL through this sunshine. Well, I'm about to go in the girls' locker room instead of the speaker. Is that crazy?
No.
I get caught. My career's full. Oh, it's so weird because it's like nobody.
Alpha equals what? AR.
Huh?
Alpha equals A over R.
You're doing physics?
Yeah. What is this? A spherical shell?
You're saying angular acceleration is an alpha?
Yeah.
Equals the cross-sectional area divided by radius? Or multiplied?
2/3 M/R squared.
Wait, what the fuck? Are you just studying for the final? Or is that what you're doing right now?
MRA.
We're doing like fucking pressure and heat right now. Like latent heat and shit like that. Have y'all even talked about that shit?
Oh, F does not equal 0. F equals MA equals 2/3. No, we're not gonna do that at all. We only do engineering. We only do. Yeah, what's up, Robert? You should do book recommendations on the channel. I will. I have a website. I keep putting the link in the chat.
Are you streaming or something?
Yeah. I stream when I do work. You can go look at my YouTube channel.
What's your YouTube channel?
It's just my name. I have a bookshelf on my website, but show feet. Okay, I will. Next stream. What? Go on my channel. Go to my lives. I stream every single time that I do homework or that I study. Alright. Well, actually, I don't stream every single time I do work, but most times when I'm in front of my computer. And sometimes with my laptop. Okay. Yo, I'm cooking on this question, bro. I know this is right. MA equals... Okay, wait. Let me... Okay, we get MA plus 2/3 MRA equals MG sine theta. Oh, it's all the same M. It's all the same M's. So we can cancel. 2/3 RA. I'm cooking on this question, bro. It's funny because when you streamed a while ago, you somehow got into my recommendation feed while I was studying and working. Yeah, it's fire. Thank God you got recommended in my stream. Now we're locked in. Now we're locked in on LinkedIn and shit. What's R? 0.71. 2/3 times 0.171. Okay. Plus 1. We got 1.114a equals mg sine theta. And we can just solve this. LOL, yeah. Mg 2.02 times 10.81 sine of 30 over answer. Okay, wait, I was cooking on this question, but somehow I got messed up. No. Oh, because I kept G in. That's stupid. No, G is gone. Oh no, M is gone. M is gone. This is just G sine theta. Yeah, 4.4 is also not an answer. Share the classical mix you've been playing. It's this right here. Hold on. It's in my history. Look, I just watched the Veritasium video, like on stream, like 10 minutes ago. I just watched him. It was pretty cool. Wait, how long is the video? Yeah, it was, bro, the black holes are kind of crazy. It's this video. Properties. I guess, I don't know what's going on. Ubuntu's like tweaking. My Files app is frozen. How's that possible? Bro, stop opening at that size. I need to change that. Where's preferences? No, okay, whatever. Downloads. This is the playlist of them, or this is the, yeah, this video. This is the music that's playing. I just put it in chat. I just downloaded that video and played it. Okay, wait, I need to re-evaluate this. Okay, wait, I was kind of just mindlessly doing this. Let me figure it. So we know F is right, like little f. Little f is right. Little f is going to equal M or A. And yeah, F equals MA. equals 2/3. Oh wait, maybe it's mg sine theta minus 2/3 mr squared. We can cancel out the m, so we get a equals, we can do this, a plus 2/3 mr squared. Nope. 2/3 r squared equals, dude, I'm tweaking, g sine theta. Okay. So 3/3. Oh, this has an a on it. Wait, where did the r squared come from? It's r. Dude, I am losing my mind. There we go. So we get 5/3 mr squared. Dude, I'm actually tweaking. Okay, 5/3 a equals g sine theta. Okay. So we do 3/5 times 9.81 sine of 30. We get 2.94. Yes, exactly. 2.94. Who has done a lab report on wind turbines? I have not done a lab report on wind turbines, unfortunately. What aspect of wind turbines? Oh, I can do this. I can kind of do this in my head. I don't know if that's a good thing to do. No, F is not equal to A. Or MA. F is equal to mg sine theta minus MA. Or, in other words, it is, I don't know, is it larger or smaller? Well, we can't really see that relationship. Oh, yes we can. We can see it right now. 2/3 times R. What's R? 0.171. Yeah, it's smaller. F, the friction is smaller than MA. Yeah. Now suppose that 3 objects. A disc, a ball, a disc, and a hoop. So a solid sphere. Look, let's do this. IB equals 2/5 mr squared. Have that memorized. A disc is 1/2 mr squared. And what was the other one? What was the other one? And a hoop, that's just mr squared. And IH equals mr squared. Okay. What is the order? They arrive at the bottom. So A equals 3/5 g sine theta. Oh, because F is going to be different. The force of friction is going to be different. In each case, the force of friction. So this one has F equals 2/5 equals I. Or actually, we can just get rid of the mr squareds, because we can just see it as a value. This is going to be equal F of B equals 2/5 A, right? It's just an extra A. Oh, A over R. 2/5 A over R. F of D equals 1 A over 2R. And F of D equals A over R. F of H. Okay, so we know the forces of friction. Whoever has the largest force of friction will go the slowest. So, so it's gonna go in order: the ball first, then the disc, then the hoop, because the hoop's gonna have the largest friction, right? 2/5, 1/2. Yeah, and this just equals the same thing. It's just 2/5, 1/2, and 1. So this is least to greatest. BDH. BDH. Yeah, that's right. Fire. This one, I have to do like kinetic energy or whatever. What is the maximum speed? Okay, so we know that the potential energy due to the spring equals half k delta x squared. Right, because this is potential energy. Oh no, this is just, oh yeah, half kx squared. Exactly, half kx squared. Please on the ideal spring constant, 185. Okay, what is the maximum speed the mass attains as it oscillates? Okay, so the maximum speed is just gonna be half kx squared equals half mv squared, right? Because that's the maximum. If all of the potential energy is converted into kinetic energy, then that will be the maximum velocity, obviously. So we have half mv squared is going to equal, oh no, that's what we're solving. So we have half kx squared, which we can solve. Half times k, 185 times x, 16 centimeters, 0.16 squared. The mass is pulled 16 centimeters, yeah, to the left, negative, oh, it's squared, it doesn't matter. And then that times 2 divided by m is 3, and then square root of that, 1.256. Okay. And we're going to get one of these intentionally wrong so that I can come back to it tomorrow. How much time does it take for the mass to return to the equilibrium for the first time after being released at t equals 0? What the fuck? Okay. How much time does it take for what to return to the equal for the first time? Okay, so like in its harmonic motion, right? It's gonna be a wave like this. So we want this. T. We want the time of this. Okay, we can erase that. Alright, so we're gonna be dealing with, so here's time here, period, but we're not dealing with period. Do we know distance? No. Oh yeah, we do. We know the distance is 0.16. Oh. Is it constant velocity? No, it can't be. Is there friction? No friction. Wait, is it constant velocity? Oh no, it's an integral, right? It was over time. Yeah, it's integral. Yeah, that's just the final velocity. So there is an acceleration. And the acceleration is like, usually you just do F equals ma. We know F. K delta X. Yeah, we know X, but yeah, I guess we can do that. Okay. F equals ma. What's F? 185 times 0.16 equals 29.6 divided by m divided by 3. A equals 9.8. We want 1.6 equals 0 plus 0 plus half 9.8 t squared. Okay, 1.6. Oh no, 0.16. We needed to move 0.16 centimeters. What the fuck? Okay, 0.16 times 2 divided by this number, and then square rooted 0.18. Okay, I got 0.18, which would probably be rounded to 0.2, but this is probably wrong, so we're gonna see this video. Yep, I remember. Wait. Wait, where did they derive that equation from? Period of a mass on a string. Waves on a string. Wait, why did they not give us this equation? Okay, I guess we solve for that. Mass per unit length. Oh, we're not on a string, we're on a spring. Simple harmonic motion. Yes, here. Mass on a spring. Okay. Yeah, we can use this. So, yeah, exactly. So, equals 2 pi over t. Okay, so we get t equals 2 pi over omega. And we know omega equals k over m. Root k over m. T equals 2 pi over root k by m. Okay. I don't think this is the same equation that they had, but I think it should get the right answer still. 185 over 3. 0.8. No, it's wrong. The correct answer is 0.2. Okay, so I did use the wrong equation. Wait, no, I did use the right equation. I should get the same answer. It's 2 pi times the reciprocal. Wait, I should get the same answer. Yeah, wait, I get the same answer. Wait, yeah, 0.8 seconds, see? Wait, what? It says the correct answer is 0.2. Okay, wait, let's see. They say mass equals 3, k equals 1.185. Mass equals 3, k equals 185, t equals 0. Wait, yeah, this is not right. This answer is wrong. Wait, what? Wait, maybe Drew was right for the other question too. Yeah, my answer's right. So, I guess that's the one that I'm gonna get wrong intentionally, so that I can come back later. Because it's right. I don't know what's up with the solutions. This is someone's exam. Someone must have got someone's answer got corrected or graded incorrectly. Okay, what is the magnitude and direction of the spring force on the mass at the instant the mass is 11 centimeters to the right of equilibrium? So, the spring, wait, what? 11 centimeters? Oh, 16 centimeters. 11 centimeters to the right of the equilibrium. So it's going to be to the left. The force is going to be to the left, and the force is just 8.1 times 0.11. 20.35 to the left. Yeah. Nice. Okay. Oh, I know the answer to this one. Okay, so let me draw it out so I can see it. The equation goes as follows. The force, hello, Apple Pencil. The force of buoyancy equals the density times gravity times the V displaced. Okay, so they all are the same size, but A is out of the water a little bit, so it's displacing half the amount of water as B and C. So F is going to be less than B, but B and C displace the exact same amount of water because P is a constant. Oh, these are both constants. These are both constants. So this is the correct answer. I know I'm right, so it doesn't matter. Calculate the magnitude of the normal force that acts on object C due to the bottom of the pool. Okay, so the normal force is going to be equal to the force of gravity minus the force of buoyancy. Because the buoyancy should be helping push it up. It's gonna help the normal force. So P is density 1000 times G 9.81 times 400 cubic centimeters. Okay, it might be the largest number in the history of the world. Object A floats under A. 3,700. Can we just do 3,700 times 9.81? That minus this. No, that's crazy. That number can't be correct. It's not possible. Okay, wait. I need to figure out how to calculate the force of buoyancy. Because I thought that was correct. But I'm getting like 3 million newtons. So I don't think that's right. The magnitude. Well, I should just watch a video to actually learn how to do it. Fn. Yeah, f of n equals f of g minus f of b. That's what I did. Exactly. Fn plus blah 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 equals 0. Oh, okay. Mg is 3,700 times 0.00004. What the fuck? Wait, what did I do? Oh, times 400. What? That's what this is? Cubic centimeters. Wait, what is this 0.004 nonsense? Oh. Wait, you get this. I mean, you get the same number regardless. Yeah, I do this minus this. 1.05, so 10.59. Yeah, 1.059, so 10.59. So 10.59 is the answer. That's my guess. Is 10, or that's my. I say that. What is it asking for? Fn equals 10.59. Yeah, 10.59 exactly. The problem with this. Okay, so 400 cubic centimeters is equivalent to 0.00004 meters? What? I don't know what the fuck's going on. Cubic meters? Is that what I'm supposed to do? I'm supposed to do cubic meters? Cubic... What? Yeah, I mean, I guess. I don't know what the hell. Okay, so for some reason this makes sense. It's like when you have z equals 0.25 times 0.7y minus 2.3t, this is plus y. And why is that? I mean, I know it's right, but... Or actually, let's get this one wrong. No, let's get this one right. Okay, so how do we know that? Did he say anything in this video? Let me listen.
In this problem, we're asked to determine what direction the wave is moving. In order to do this, we want to look at the argument of the wave equation. As time increases, y would have to increase to keep the displacement of the wave the same. Therefore, the wave must be moving in the positive
Oh,
line.
z is constant. Z is constant. Okay, z is constant apparently. So as t increases, y has to increase to compensate. For some reason, z is constant. I don't know what z is, but it's constant. So calculate the tension in the string. Oh, this is easy. It's is this one. Do they give us mu? Yeah, they do. Yeah, this is super easy. Okay, v squared equals f over mu. And we have v, wait, this is easy, but like, oh, look, because we have, dude, where the fuck did this thing come from? 0.7y minus, oh no, our w is 2.3. Angular is 2.3. Or negative 2.3 or something. I don't know. V equals R omega. Oh shit, do we know R? Wait, we don't know. Oh, there is no R. What? So, do we just use... Wait, what? Wait, what? How do we get V? Oh, V equals... No. Doesn't help us. Okay, they're talking about the spring constant, right? Spring constant, okay. Or... Oh, no. I don't know, dude. Oh, wait, no, they're not talking about K, the spring constant. 0.7 equals K. Bro, this is so stupid. Can they just... There's hella Greek letters. Like, they can use different variables. They don't have to use the same variables for everything. Okay, so we get, V equals over K. Nice. Okay, so 2.3... Let's square this whole thing. So it doesn't matter if it's positive or negative. 2.3 over 0.7 squared equals 10.7. Oh yeah, no. V squared equals 10.7. Okay, whatever, just erase this. So we have 10.7 equals F over 0.056. Okay, 10.7 times 0.056. What the fuck? We got 0.6 newtons. Okay, I got F equals 0.604 newtons. So let's see. Yes, okay, that's correct. Nice. And then everything else I'm coming back tomorrow, right? This one, yeah, I figured that one out. Okay, wait, let me go back to it and see how I figured it out. It was like let me just do it again. I'll just do it here. Okay, so we have the plank here. This is our original position. The guy's here, whatever, guy's here. This is M, the center of mass. So we assume that it's going to move this way because this guy's 72 kilograms or 77 kilograms. So we assume it's going to move to the right. Yeah, we assume it's going to move to the right. So this here, this distance here is going to be our D. This is at L by 2, right? So L by 2 minus D equals XCM. Wait. Wait, conservation of center of mass. Wait, conservation of center of mass? What does that have to do with anything? Okay, well, we can calculate the center of mass. So we'll use the left end as the axis. We have this girl at 58.2 times 0, so it's just 0. We have this guy at 77.6 times 5.5 plus this the 15.9 times 5.5 over 2 all over 77.6 plus 58.2 plus 15.9. So XCM equals 3.1. 3.1 minus L over 2, 5.5 over 2 equals 0.35. Okay, so it's XCM minus L over 2 equals D. Why? Let's find out. Oh, so I didn't draw this right. Oh wait, no, it is drawn right. So this is going to be center of mass. Fucking piece of shit, dude. No, it's good that I have 0 views because I'm about to end stream. I mean, it's not good that I have 0 views, but like, it's okay. Well, actually, I might not, because sometimes it gets glitched. Because Drew was typing in chat earlier, and it said 0, and I was just talking to Drew still. So this is our XCM's position. It's also at L over 2. So, oh, this is also going to be D. This is D here. No, this is the only D. This is not D. That's the only D. So we have L over 2. XCM. Oh, we just forget that this is even L over 2. This is L over 2 here. From here to here. This is L by 2. So, wait, what am I doing? This is L by 2. What am I doing, dude? This is L by 2. So XCM minus L by 2 equals D. Or L by 2 plus D equals XCM. L by 2 plus D equals XCM. Perfect. But to do this method, we have to realize, like, by intuition, since he weighs more, the center of mass is going to be towards him originally, and the mass is going to move. Oh, no. The mass is going to... No, never mind. You don't have to know that intuitively, because you know the center of mass is towards him, and you know the center of mass is going to go through the center of the beam in the second reference frame. So, you know, like, that's, I mean, it's kind of just like just how it's set up. Let's see this question. What was this one? Oh, I actually got this one wrong. Yeah, what am I talking about? We need to know the masses. This is never the answer. What a stupid ass question. What a stupid ass answer. What's this one? Oh, I actually got this one wrong too. Yeah, how the fuck was this? Okay. F is what the fuck does that say? KI1, KI2, K2 equals KCM plus U. U equals... Oh, there's a minus? Oh, I didn't even see the minus. That was it. Yeah, that makes so much sense. I didn't see that one. I just knew it had a minus sign in it. Well, I was gonna choose this one or this one because I knew it was small. Yeah, this one's gonna be equally as small, right? Okay. Damn, bro, what am I at for grade? Oh, it won't tell me anymore. Oh, 77.2. That's crazy. So I would get an A. I would have an A in the class if I left this many questions blank. Just didn't even answer them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 questions wrong. I get an A if I get 9 questions wrong. Dude, if I get 9 questions wrong, I'll freak out. I'll start crying. In the middle of the exam, I'll literally start screaming, crying. Okay, I need to watch state diagrams, and I need to... What time is it? It's 11. Oh, it's 10? Oh, it's actually still pretty early. Oh, but I need to go to bed because I said I was going to wake up at 7. Alright, bet. I'm going to watch state diagrams, I'll just prove the practice final tomorrow. Control C those. I can't. Where's my thing? My terminal. Control C. Okay, let me check my email. Nope, not Teams. So there's 173. This is pretty cool that Piazza's email looks like this now. Thank you. Oh, what the hell? No, I don't like dark mode. Oh, compact sucks. Oh, blue. Now it looks like Outlook. Premium? I'm talking about premium. Okay, well, I'm gonna do blue, I think. Oh, hell no, I'm not gonna do blue. That looks terrible. Alright, what are other things? Details? I can change a lot of stuff. I'm gonna get fucking copyrighted for Mind Over Matter again because this kid's in the shower. Go to today. Look, school's over. All I have is these 2 finals. I'm so fucked for this final. Oh my gosh. I'm about to study right now. Well, not really, but I'm about to look at finite state machines. Yeah.
Welcome to the final video in discrete math, finite state machines. We just talked about formal languages, so now we'll apply them to some finite state machines. These are diagrams which you'll see in the next couple slides, but first I should introduce them. A finite state machine M is a 5-tuple Q sigma delta Q O and F. Now I'll explain what each one is.
The fuck is he talking
Is
about?
a set of states, and these are usually written as Q sub 0 all the way up to Q sub n. We have sigma, which is our alphabet, which you should be familiar with. Delta is a function that takes a state and a letter in our alphabet and takes it to another state.
Okay.
So you'll see how this works in a second. But for instance, I have delta, I take a state, say Q0, and some letter in our alphabet A.
Okay.
And out would come another state that it goes to.
Makes sense.
We also have Q0, which is going to be our starting state. When I say Q0, what I really mean is some specific state that we start at. And we indicate this as an arrow pointing to our state. Sometimes it might be Q1 or Q2, but for all intents and purposes, it'll be Q0. And F is going to be a subset of all the states, and this are basically the final states.
Oh.
It's also called the
Accepting states. Yeah.
So, if a machine takes you to a final state, then the machine accepts that state.
Okay, I get it.
That is a valid string of characters. So
Makes complete sense.
This is an example finite state machine.
Which accepts
Kinda nice. We have a starting
any
point,
string
which
of ones
represents
and
by
zeros.
this arrow. So this is where we start at Q0. And what it does is we input a string
Oh,
of
that starts with a
characters.
1. Any string that starts with a 1.
Give it, say, okay, we're going to let our alphabet be
Any
0
bit
and
string.
1 here.
Any bit string that
And
starts
if we
with
give it a
1.
0, we start in Q0, and if we give it a 0, it goes back to Q0.
Oh wait, it doesn't have to start with a
So as
1.
an example here, we'd say delta of Q0 and 0.
Because this only prevents just 0.
0. While on the other hand, if we give Q0 a 1, then it goes to state 1. So, if we gave it a string, actually what I'll do is I'll go forward a little bit, and I will denote that this Q1 here, if it has a double circle around it, it is an end state. More than one state can have double circles around it, but basically the double circle means it accepts it. So, if I gave a string 0, 0, 0, 0 and input it into the machine, what we'd see here is we'd start here, go back to Q0, then go back to Q0 again, go back, and we'd finish in a state.
Oh, it just has to have a 1 in it.
So the character would be invalid, and the language would say, no, you don't want that.
It has to have a 1.
Try again.
Any bit string that has a 1 in it.
Just give it a 1, and if we just give it a 1, the machine says, okay, finish in Q1, and that is an acceptable state. What's interesting about this machine is that as soon as you enter Q1, whatever number you put in afterwards, it just accepts it. So, as long as there is a 1 somewhere in your string, the machine will accept it. And that is an interesting result, because why would you want a machine that just accepts anything that has a 1? Well, if we abstracted and say, what are the applications of a machine that accepts any input that is a 1? So say there's 2 inputs, and we say this is a yes or no. If there is at least a yes, at least one yes,
Then we
it
check.
accepts it.
Yeah. There's
So
plenty
what
of
would you
examples of
model in
that.
the real world after this?
I don't know.
Perhaps, I don't know.
Are there any
let's
students
say
at
we
my
have
school?
A program, and what it wants is it is a test program. It is for teachers, and you have a student, and basically, what this one here is, it's a create a student button. And as soon as you press that button, you have started the program. And it doesn't matter what button you press after that, because that student is created, and therefore you have satisfied the goal of creating the student.
Oh my gosh, I hate
And
this.
here is not pressing any button. So basically, as soon as you open the program, you create a student, and that is your success story for this finite state machine. So a lot of these are really abstract.
Yeah.
So let's get into perhaps drawing a finite state machine. This is something that is always fun to do. And we're given that the alphabet is just zeros and ones. And we're told to draw a state machine.
Wait, where's my other Rubik's Cube? Dude, I think I have like severe issues. I'm supposed to be watching the video. Oh, there it is. This one's way more fun than the other. It's a lot easier.
Now, here's a question. What do you mean multiples of 2? Because all we can do
Oh,
here
thank God, dude. This is exactly what I need to see.
state machine. So a lot of these are really abstract. So let's get into perhaps drawing a finite state machine. It's something that is always fun to do.
This is exactly what I need to see, bro.
We're given that the alphabet is just zeros and ones, and we're told to draw a state machine that only accepts multiples of 2.
Okay.
Now, here's a question. What does this mean, multiples of 2? Because
Yeah.
all we can do here are input strings like 0, 1, 1, 0, 1, 0, 1. And we can put it right
Suck at this,
back.
dude.
So when it says only accept multiples of 2, you have to kind of abstract an idea and say, okay, what this machine really is, you input a string like this, what we're really saying is 0 plus 1 plus 1 plus 0 plus 1, so on and so forth.
Okay.
So you have to sort of define what you're doing, because finite
Wait, so that doesn't matter. So then zeros don't matter?
So, what we do is we start out with an initial state. We call this Q0, draw a little line to it, and it only accepts multiples of 2. So let's think of some strings that it
Dude, I don't know what I'm
accepts.
doing.
Let's think of the most bare minimum strings it would accept. It accepts the state, I will do this in green, it accepts 0.
I
It
don't know.
accepts 1, 1. It accepts 0, 1, 1, 1, 0, 1, 1, 1, 0.
What the hell is this guy talking about?
0, 0, 1, 1. Now, we've done a lot of things it accepts. What about the things it doesn't accept? And this is equally as important. So these are the OK boxes. Now, the bad boxes are 0, 1, 1, 0, 1, 0, 0, 0, 0, 1, so on and so forth. So the question is, how do we start? Well, if we don't do anything, and even if we just have, say, an empty string that is also acceptable, then we're going to start off in this state here, and it's going to be accepted. As soon as you start the machine, it is accepted.
It's down.
So, because the empty string is an accepted final state, the first one is accepted. Now, here's the thing. Because there are clearly things that aren't accepted, we have to draw another state over here, Q1, that doesn't accept things. And how
I don't know what I'm
does it
doing.
not accept things? Well, here's the thing. If you just input a 0, you're good in the first state. But as soon as you put a 1 in, it goes to this not accepted state. Now here's the question, is how do we get back? Well, if you put in another one, we're okay. Because in order to have
pairs of
Q1
ones.
accepted, you go to Q1 if you're an odd number of ones, and you go back to Q0 if you're an even number of ones. And clearly, zeros don't have any effect on the machine whatsoever. It does not take a state from one to another. Because you're adding zeros, you're effectively doing nothing. So we have these ones alternating states back and forth. So when there's an even number of ones, it's in Q0. And when there's an odd number of ones, it's in Q1. And that is
Yeah.
a finite state machine that accepts multiples of 2 given
I get
this
it.
alphabet. So that's pretty cool. Alright, now that we know how to draw them, what about if I give you a state machine and say, what does it do? In fact, I've put a little bag here.
Do I now know how to solve this Rubik's Cube, bro?
And the letter R. What does R stand for? Well, you gotta figure that out. So take a moment, look at this machine, and tell me what you think it does.
Okay, hold on, let me see. Okay, so the start state. Okay, so we can give it a 0 or an R. Is that a 0? 0, 1, 2, R. Okay, 0, 1, 2, R. Our only end state is if it's a 0 or a 1. We can go to 2. We can get a 0. We can get a 1 or an R, and we can come back. So it seems the 1s can only be put in these 2 places. And Y. Okay, so we can eliminate strings that have a 1, only a 1. We can eliminate strings that only have a 1, yeah. That's 2 1s, so it's not about how many 1s it is. Right, because you can have 1 1, you can have 0 1s, you can have 2 1s. You cannot have 2 1s. You only have an odd number of 1s. 1 1 R. Oh no, you can have 2 1s. Yeah. Okay, so you can have an even number of 1s. A 1 does not come before a 2. No, a 1 can come before a 2. Because like you can start with a 1 and go back with a 2 and then you end. I have no idea, bro. What the fuck? I don't know. Explain it to me, brother.
Alright, so we kind of look at this.
Yeah, I did. Tell me, am I supposed to know what it does?
The first state, it just accepts. It says, okay.
Yeah, I know what I'm doing wrong.
So, if we take this
Oh,
one
wait,
0,
right.
it accepts it.
Wait, what am I supposed to do?
Now,
Not that one.
what I noticed
This one?
is that it also accepts R.
This one?
In fact, if you take a look at this very closely, it looks like
I don't
no matter
remember.
where you are, say if you're
How
at
to solve
one
this?
machine,
Wait, hold on. I need to remember how to. Yeah. We got it, buddy. Okay. No, give me the fucking PDF, bro. Jeez, bro. Up, left. What is this? Up. Yeah, I know that algorithm. What? Wait, what are we trying to get? Oh, that's... Oh! That's what I was doing wrong. Yeah, okay, look. I was supposed to do this until the top is solved. Like, this is the fish, but then now we solve the top. Okay, and now we can take this one. Let me go. Oh, wait, hold on. I need to make it solved. Okay, and now we take this and go like this. There we go. Now I'm tweaking. I completely forgot how to solve this Rubik's Cube. I haven't done it in so long. So hold on, right before the video plays. Oh, this is one. What? It's not solved. What the fuck is going on? Oh, there we go. Okay. Alright.
accepts it.
Put our hands on it.
It accepts it.
Okay, yeah, we got this.
Basically anything that ends in an R, it also accepts. So we can kind of think, okay, maybe this R actually just means reset. And blue wide shows R, back to the original example, the word was reset. I was just being mean by taking out the letter reset. But okay, so that's kind of interesting. If it resets the machine, it's okay. If it's a 0, it accepts. Now, what does it do here? Well, perhaps it's an addition convention that we've done before. So
Bro, what
let's
is
take a look
going
at
on in
some
my eye?
screens. Let's say, okay, if we
Take
put
off
in
my
here
glasses.
1, then we go from Q0 to Q1, and then if we put in another 1, we go to Q2, and if we put in another 1, then that's okay. Okay, let's do something a little bit different. Let's traverse to Q1 and get back to Q0. And we can do that by putting in 1 and 2. Okay, what if we want to go to Q2 and then back to Q1? We can put in 2, 1. It's kind of interesting. But what we haven't done is we haven't gone from Q0 to Q2 to Q1 and back. So let's do that path. Okay, well, from Q0 to Q2, we can do 2. From Q2 to Q1, we can do 2. And from Q1 to Q0, we can do Q, or 2. And that's okay.
Dumbass.
So you can see here,
You know how to talk.
if we add these numbers, they all equal 3.
What?
So we can kind of assume
What?
that, hey, as long as our string equals 3, it accepts it.
This is not 2, 2, 2 does not equal 3.
Let's create.
Wait, am I?
So we can cut, and that's okay. So what we can do here is that if we add these numbers, they all equal 3.
Wait, am I tweaking?
So we can kind of assume that, hey, as long as our string equals 3, it accepts it. And just to test this, let's create a string in our head, just a random one. 2021-0R10201.
Yeah, see, that's not gonna work, right?
Recording
1, 2, 3,
should
4,
accept.
5.
So we just randomly pick some numbers. Now,
That's
if we call
6.
the machine, which I will do in dark purple and then erase afterwards. That's not a good color to do this in. Let's do red. So we start with Q0, and we do 0, so we go here. We do 2, so we go to Q2. We take a 1 back to Q0. Then we do a 0 a couple times. Then we reset once, so that's good. We now take a 1, we take a 0. We take a 2, which takes us back to Q0. We do a 0.
What the fuck is this nigga doing?
And we end up back at Q0. So, it's accepted.
How does that equal 3?
So it accepts multiples of 3.
Oh, multiples of 3.
Is that
Why do you say equals 3?
0
Mod 3.
3 check. Or I
Oh!
should say a 0 is equal to n mod 3 check.
Yo!
In this case, it accepts it. If not, it rejects it. So you can play around with this.
Oh my gosh, you're so stupid.
After the last reset,
Zero
our string
intuition.
adds up to a multiple of 3. And if it does, then it
Mod
accepts the machine.
2 mod 5.
So that's kind of cool. And that is the basics of finite state machines. You can do crazy things with them.
Wait, what's 2 mod 5? What the fuck is modulo again? I was just doing this like, it's just 1. 2 mod 5 is 1, right? Wait, 2 mod 5? Yeah, 2 mod 5 is 1. Is 2? Oh, 5 times 0 plus 2? Okay, I got it now. Okay, I get it. Okay. So n mod 5 has to equal 2. Right? So this is an n mod 5 equals 2. That's what this is saying, essentially. So it only takes in multiples of n mod 5 equals 2. Wait, so how do we keep track of n mod 5 equals 2? So it's like n mod 5 equals 2. Oh shit, that's a lot of numbers. It is a lot of numbers. Okay. Well, cause like, wait, is that a lot of numbers? I don't know. I don't know what the, I don't know.
Construct a machine where in fact it takes multiples of 7.
I gotta relook at the modulus operator.
That has common factors of say 2 and 5, which again, these are really complicated machines compared to this, but they can be done. And the main important part, which I didn't write anywhere, is that these are abstract. Of course, these can be very concrete and just be drawn to do what you want, but most of these are sort of like programming flowcharts.
Okay, dude, can we
And I
get...
think that's probably the best way to describe it, is that these are flowcharts for your program operators. For instance, this 0 mod 3 check is kind of an algorithm, right? Because it takes a number and it does a bunch of things and keeps, basically subtracts 3 times n and checks, okay,
if it equals 0.
Well,
Wait,
yeah,
that's what the modulo operator means? Six minus 3n equals 0. It's 6. He's saying 6. Where does 6 come from? Oh, 6 is your input. So input minus 5n equals 2. Wait, like 12 mod 5 is 2, right? Yeah, 12 mod 5 is 2. Wait, so what's the definition of modulus? It's in my textbook. Oh my gosh, I'm not gonna be able to find it. It's too long. This textbook's too long. Oh my gosh. Where's the definition of modulus? If it only have k is divisible by b minus a. No. There's like a definition. I guess this is it. So what does that mean? The definition of divides is like b minus a over k equals n. B minus a over k equals n. So you're basically saying that kn equals b minus a. So the definition of modulus is kn equals b minus a. Oh yeah, exactly. Yeah, that's the definition of congruence. Wait, what's the definition of modulus? Oh wait, is there no formal definition? Hey, I guess it is, right? So if we want it to be congruent to 2 mod 5, oh, we're doing congruence right now. Yeah, okay, so we use this definition. Right, what's the definition? B minus A equals Kn. Yeah, B minus A equals Kn. And this can be proven, right? Because 2, okay, so like 12 is congruent to 2 mod 5. So B minus A is 2 minus 12 is negative 10. Negative 10 equals K times equals 5 times. Okay, wait. So essentially we're saying, no, come on, stop. Essentially we're saying 2 minus A, right? A is our input. Okay, so 2 minus I equals 5n, where n is a natural number. So 2 minus 12 equals 5n, right? Because 5 times negative 2 equals 10. Equals negative 10. So that's essentially what we're checking in the state diagram. It makes sense. This state diagram is going to be so hard to build, though. I don't know.
so it accepts it.
I need to see some like
And you
examples.
can do this for say, okay, well, what if instead of this sort of thing, we have 3 different types of numbers? Let's say we have odd numbers, we have even numbers, and then we have these imaginary numbers which are neither odd or even. I'm inventing something here. So we'll call these, we'll draw the numbers like this. It's just an imaginary number. And it's like an X with 2 dots. We're doing this and we say, okay, well, I want a machine that only accepts these. So basically, only accepts these. And there's certain combinations of odd and even numbers that you can make with this cool operator that is a donut with blazing suns coming out of it. So if you take A, you have this little star thing, B, then you can get this imaginary number out of it. And this is really abstract and crazy, right? But you can design a machine that under specific circumstances does this, and then you can program it. So that is the whole purpose of finite state machines.
What the fuck is this guy talking about?
Would talk about in a formal languages course of further mathematics. I will erase this red line. So here
Yeah,
we see
this
that
is the
we
normal
start
state
with 0,
diagram.
We put in 0, we go back. We put in R, we go back. We put in a 2, we go to Q2, and put in a 1, we go to Q1. It is
Yeah, because 0 doesn't change anything.
like we know
Of
what
course.
But what if I said, okay, and if you put in a 2, you might go to Q1 as well. Instead, if you're in Q1 and you put in a reset, you might go to Q2. In fact, you might even just go back to itself. Who knows? And what about from Q2?
Yeah, it's too complicated.
Basically, anywhere you go, maybe a 1 would be nice to go back to a cell 2. And then you have a non-deterministic finite state machine. It gets a little bit more interesting, but if you're interested in that, there is tons of stuff online. That was finite state machines. If you have any questions or good homework problems that you should probably let me do on camera, because a lot of homework problems in discrete math, they don't really touch on finite state machines, and if they do, they usually go a little bit beyond this, and that's normally not taught in the first.
Yo, do you go to... Oh shit, I didn't mean to yell, but... Do you go to UIUC?
Kind of a weird spot to be.
Shamir, do you go to UIUC?
Leave them in the comments and I will answer them as quick.
Sorry if that was loud. These are noise canceling. Oh shit, I'm low-key yelling. Rutgers? Oh shit. If you went to UIUC, that'd be tough. Yeah, I have discrete on Wednesday. I have physics tomorrow. Yeah, like I said, I'm cooked. Yeah, I'm cooked too, bro. If I had to take it if I took it today, I would probably get like a 70%. But if I took it tomorrow, I'd probably get like an 80%, which is bad. Like I can't get an 80% because then I'll have an A- in the class. I'm cooked too, bro. I don't even know what I need. I need like I'm just gonna try to get 100 on it, but I need like a 90 to get an A+. You get to make a cheat sheet? What? Bro, ours are in the CBTF, like it's a computer-based testing facility. We're sitting in front of a screen. They don't even let you bring like your wallet. Like you can't bring a single thing. They barely even let you bring a pencil from home. Like they provide pencils. It's crazy. They don't let you bring a single thing. If you're wearing a hat, they make you take your hat off. If you get caught cheating, like you get booted from the school. It's so crazy. I wish we had cheat sheets. That would be so fire. I bet yours is harder though, because you have cheat sheets. Because obviously, it's not going to be the same caliber of exam if we're not allowed to have cheat sheets, and you guys are. Wouldn't be fair to us. So ours are probably a little bit easier. What's the main thing you're worried about? It's your final probably, so it's cumulative. Do you guys have to do state diagrams? I was doing state diagrams right now. It's like the main thing I have to learn. Yeah, they do. Yeah, they take our scratch paper after the exams. They don't want like other people seeing your scratch work. It's 10:32. How long have I been streaming for? $10 and 54 minutes. It's kind of crazy. Okay, I'm gonna end stream in 6 minutes. 11-hour stream. What are you most worried about, Shamir? Shamir. You go to Rutgers, bro? Let me see what Rutgers is about. Yeah, this is definitely an intro to discrete structures. Well, this would be the equivalent to the class I'm in. I don't know what either of those are. FSA. Okay. And NFA. Oh, these are machines? Non-deterministic finite automation. Oh, okay. Non-deterministic's kind of crazy, but we only do deterministic finite state machines. Oh, we did grammars. Yeah, finite state machines, Turing machines. Yeah. Algorithms. We didn't do cryptography. Oh. We did all of this stuff. All of this. All of these. All of this. All of this. Yeah, all of this. We didn't do this. Yeah, we didn't do any of these. Because it's for computer science, not for computer engineering. So maybe yours is for computer science too, but so we didn't do any like anything with bits. They actually cut that all out this year. Previous years they did bit strings and bit manipulations, but this year we're not doing anything bits. Yeah, it's for CS. Yeah, it's typically. Are you a CS major? Is that what you're studying? Computer science. Oh, but this is way better. Bro, your exams are only... Look, I'm going to show you mine, and I want you to tell me if you think it's like the stupidest thing you've ever seen in your life. Look at our grading. Look at our grading breakdown. Oh, great. Exams are worth 90% of our grade? What? Hello? Who in their right mind thought that this was okay? That's what I'm saying. Bro, how is that possible? I have a 91 in the class. Like, I average a 93. No, that's not. I average a 91 on exams, which is like pretty good. Which is good. Like in a normal class, like I'd have an A+. But like in this class, I almost have a B, averaging 91s on the exams. We have 7 exams. So each are worth 15% roughly. But it's not like, I mean, that gives you a little bit of comfortability, but each exam is equally as difficult as the other exam. So it's not like, it's still hard to average over a 90 on the exams. Like, I'll show you my exam scores. This exam doesn't count. The power went out in the middle of my exam, which was like crazy. But like, these are my exams, and this exam right here that I got a 78 on, which is 78 is not even that bad. Like, it's pretty bad. Like, that's like an 80. In a normal class, that would be fine. But since I got a 78 right here, like, I have an A-. With these exam scores, I'm about to have a B in the class. What? That should not be like, how? How do I have, like, I basically like average like a 95, and I have a B in the class. What the fuck? Well, I don't actually have a B. I almost have a B. So that's why I need to make sure I do well on this final on Wednesday. Fuck, it is wild. Oh, Tharoon. I know Tharoon. You were in the stream yesterday? 2 days ago? 2 days ago. Dude, I told you I was going to stream for 14 hours, bro. Well, it's only 11 hours right now, but... I didn't... Yeah, 2 days ago. I didn't stream for 14 hours yesterday like I said I was. I think the stream was only like 6 hours. Which is why I had to study so much today, because I was slacking off yesterday. I was slacking. Yeah, bro, yeah. Got these exams. 1:30 p.m. Damn, bro. Yeah, bro, you guys should sub. Not that I really care. No offense to you, obviously. I care. I would like that you guys to sub, but like I stream kind of just like for fun. Not really competitive. Not really like competitive. Like I'm gonna do studying. I found you all looking up. That's funny. That's funny. Yeah, no, go back to studying, bro. Thank you, Tharoon. I'm gonna be streaming tomorrow too. I'm probably actually gonna start streaming at 8 a.m. tomorrow because I have my physics exam tomorrow and I gotta study before it starts. Good luck, Shamir, on your exam if you're still here, and goodbye. But I'm gonna end stream like right now because I gotta go to bed so that I can get up. Oops, sorry. Linear algebra, yeah. I'm not currently in linear algebra, but it's like I'm taking it next semester. But I have been learning linear algebra. I bought a textbook and I've been reading it. I haven't read it in like a week or so because I have my classes that I'm currently in that I have to study for, but over the summer I'm gonna read it a lot. And I just bought some machine learning textbooks and they also have a bunch of linear algebra in them. So I kind of know linear algebra. I did a linear regression and polynomial regression in my last my last machine learning project. So kind of know it. Are you in Lin Alg? If you're still here, you're probably gone. What says George Phillips? That's funny. I need to start packing. I need to pack my room up. Got the worst professor. He literally just reads a book. No, dude, I know. And I heard Lin Alg is actually hard if you don't have a good professor. Some of the kids on campus here, they have like, they have bad professors and they're like, yeah, the class is hard as shit. But if you have a good professor, like, wait, I should be able to, what is this? My school has this thing where you can see grade disparity. 257. Oh, well, I guess the GPA is not that bad. But this is also old. The class changed a lot. Yeah, they said it was brutal this year. One of the professors is apparently really, really bad. And, he literally just recites the book. That's kind of crazy. Yeah. No, yeah, that's crazy. Doing that, my professor for Calc 2, which is the class I'm in right now, she only does problems. She doesn't even, I don't even think she brings a textbook to class. She only does problems on the board, and is very helpful. I don't really go to lecture, but some of the times that I've been, it was pretty, it was kind of useful. Yeah. But yeah, I'm gonna end stream. I forgot. Alright, good night, bro. Hopefully you guys, hopefully I see you guys tomorrow. Oh wait, actually, I won't even be tomorrow afternoon. If you want to come to the stream, come tomorrow afternoon. Do not come tomorrow morning because I'm gonna be studying, and I swear I'm not gonna look at chat once because I'm gonna be stressing for my exam. Alright, see you, bro.